Hi, I'm Dennis Taylor, and I'm happy to present Excel 2013 Advanced Formulas and Functions. For many Excel users, the central focus of what they do is writing formulas and functions. If you really want to take advantage of Excel's power, you need exposure to its many functions. I'll start off by showing you some great shortcuts for building formulas and functions, numerous variations on the aforementioned if and VLOOKUP functions, vital statistical and math functions, and some date functions that could prove to be indispensable. I'll show you how text functions can help you clean up flawed data, how powerful array formulas and functions give you even more analytical possibilities, and I'll show you how to use functions in combination with one another to achieve even greater power. Welcome to Excel 2013 Advanced Formulas and Functions. If you have access to the exercise files for this course, you can put them on your desktop, as I have, or anywhere else you want. Each folder here, for example, Chapter 6, contains a workbook. Each workbook has multiple worksheets. Each worksheet is used for a specific movie. If you do not have access to these files, you can follow along with your own files as we proceed through the course. If you're trying to make sense out of a worksheet that has formulas in it, it's going to be really handy if you can see all of the formulas at once. Now we can certainly see that there's a formula in cell B7. Simply click on the cell, we see that in the formula bar, and of course we can double click a cell too to see the formula within a cell. But we might want to see all the formulas at once. There's no standard way to do this, but there is a keystroke shortcut and also a menu command that will allow you to get to this capability quickly. In cell C1, I've depicted what's on one of the keys typically found in the upper left corner of most keyboards. The symbol on top is called tilde. The one below it is usually referred to as accent grave from the French. But as a keystroke shortcut, don't use the Shift key, but do use the Control key and press that key on your keyboard. Control tilde, I'll call it. And what happens? All column widths have been doubled, and wherever there's a formula, we see the formula. For example, in cell E5, and also in cell D13. If you press Control tilde again, we're back to a normal display. There are times, and I use this frequently when I'm doing troubleshooting on certain worksheets, Control tilde doubles the width of columns as it exposes formulas, or it takes us back to normal. And the reason this feature doubles the width of columns is to give us a better opportunity to see the formula. Still isn't foolproof though. If you notice that in cell D13, which is currently selected, we still can't see the entire formula here. What you might also want to consider doing in these situations, particularly if you know the worksheet is valuable and you're going to be working with it for a bit, or if you want to absorb its content faster, what we might do is click in the upper left corner and then double-click any column boundary. This will readjust all column widths, and then we could print the worksheet in its current form. And when you do that, it would be a good idea to also display the column letters and the row numbers as well, then use that as a source of documentation. So if we press Control tilde, we'll go back to normal. And since we did readjust the column widths when the columns were wider, we'll want to do this again, clicking in the upper left-hand corner. It's probably still selected anyway. Then double-click any column boundary between the letters, and we're back to so-called normal display. You'll also find this feature in the menu, but it's easy to overlook, and they do refer to the other symbol that's on that same key, that so-called accent grave. So from the ribbon, go to the Formulas tab, and you will see the choice called Show Formulas. Notice that the pop-up tip below it does refer to the other symbol, and you could easily overlook that. It doesn't refer to the tilde, it refers to the other one. But no matter how you view this keystroke shortcut, though, remember it's Control tilde, Show Formulas, or the keystroke shortcut. Now, a companion, but certainly a different feature to what we've just seen, is the idea that you might want to highlight all the cells in this worksheet that have formulas. The key first step here is to make sure you've got only one cell selected. If you have 2 or 3 or 4 cells selected, for example, if we are about to use this feature, it will only search within the selected cells. So somewhat counterintuitively, we will click on one cell, and then from the Home tab in the ribbon, the extreme right button, the Find and Select button, the binoculars, click it and choose Formulas. And all cells that have formulas in this worksheet are currently highlighted. Now, before clicking anywhere, what you might want to consider doing is applying a color to all these so you remember which cells have formulas. We can do that simply from the Home tab, the Fill Color bucket right here, Give it a color that's light enough for the text to show through it. I'll just use this tan color right here. And as we zoom back a little bit, we know at a glance where the formula cells are, the ones that have this tan color. Now the feature is not dynamic. If we were to write a new formula here, it's not going to turn tan. Or if we erase this formula here, it will continue to stay tan. So from time to time, you will want to run the feature again to make sure that it's up to date. A companion to this is the idea that you might want to highlight all of the cells that have pure numbers in them, not formulas, but just pure numbers. Here too, begin with the active cell in a single location, and then on the Home tab, choose Find and Select, then Go to Special. And in the Go to Special dialog box, choose Constants, but then uncheck the boxes for text, logicals, and errors. Click OK, and now we've selected these. And similarly, as we did with formulas, we might want to choose a contrasting color here. I'll use a light blue. There we are. And so in this worksheet, the light blue cells are those that contain pure numbers. The tan cells are those that contain formulas. So it really helps you figure out what's going on in a worksheet. And the more you work with these two features and its predecessor, where we were able to highlight the formulas, you'll have a much better capability for understanding and working with worksheets that have formulas. When you're working with a worksheet that has a lot of formulas in it, there's a concern sometimes as to what will happen to a lot of formulas if we change a cell. For example, cell B3 has the value 65. Cell B7 has a formula that refers to cell B3. If we change that 65, then the formula in B7 will react. Now, we're also concerned about other cells that might react if we change B3. If we were doing this manually, we'd have to worry about which cells will change if B7 changes. So in other words, a so-called ripple effect. Which cells will change in this worksheet if we change B3? And what about the fact that there could be, in other worksheets of this workbook, formulas that refer to cells here that also refer back to cell B3? Tracking down dependencies is an almost unthinkable manual task. So let's go to cell B3. This is the cell whose dependencies we need to locate. On the Formulas tab in the ribbon, we've got the choice in the Formula Auditing group, Trace Dependents. Click it once, and what we see are references by way of arrows to cells that have formulas that refer to cell B3. So for example, if we go to cell G5, we see there's a formula that refers back to B3. It includes other cells as well too. Similarly over here in cell E5 and all the others that have arrows in them. When we're checking dependencies, we don't want to click Trace Dependence just once, but repeatedly. As we start to click this again and again and again, eventually we will hear a beep if you've got a speaker on, or we'll stop seeing new arrows appear. And so the implications are quite large. Doing this manually would be unthinkable. All of these cells that have arrows have a dependency on cell B3. Now, we're not necessarily saying that they will change. It means that they could change because they have formulas that refer back to B3. And you'll notice something looking a little different in the midst of all these blue lines, a dashed line that actually is pointing to an icon that represents a different sheet. And so there is a formula on a different worksheet that is dependent upon cell G5, which is dependent upon cell B3. If you want to trace that reference, then you'll double-click the dashed line. This will bring up the Go To dialog box. And this tells us that in a different worksheet of this particular workbook, we've got a formula that does get data from cell G5. And if you double-click this or simply click OK, it will take you to that other location and show you that formula. And there's the formula there on a completely different worksheet in this workbook that's getting data from cell G5 in the starting worksheet that we were looking at, Auditing Tools. So I'll go back to that worksheet, this one right here, and for the moment we're seeing all cells that have a dependency on cell B3, and it's quite extensive in some worksheets. If you want to start checking the dependencies of other cells, I think the first order of business will be to remove the arrow so that we can check the dependencies of another cell. Now, the reverse, called Trace Precedence, is perhaps equally valuable, maybe more so in some situations. Imagine in this particular worksheet, one of the key values that comes out of it after plugging in specific numbers here and there is to come up with a total, for example, in cell L27. Here, we begin with a cell that has a formula in it. And in this case, it's a rather simple use of the max function. But the question here is, where does this cell get its data from? And the reverse of dependence is called precedence. So if we'd like to look backwards, so to speak, and answer the question, where does cell L27 get its data from? We make sure that's the selected cell. And then on the Formulas tab in the Formula Auditing group, we click Trace Precedence. And here too, we click it repeatedly until we either hear our speaker with the bell or we see no more lines appearing with arrows. And so in this particular worksheet, all the cells with blue dots or arrows in them, if altered, can change that value of cell L27. So these auditing tools, you could imagine, could be invaluable, both checking precedence, as we did in this example here, in the previous example of checking the dependence of cell B3. In the worksheet called Row References, we're about to tabulate an east total here. Any number of ways to do this, perhaps easiest might be to begin with the AutoSum button. Remember, it's found in 2 locations in the ribbon. On the Home tab, it's off to the right in the Editing group, and as you would expect, on the Formulas tab over on the left-hand side. Let's click AutoSum. If we're trying to come up with an east total, we certainly don't want to add these numbers. We probably would want to add the 2 eastern cities here, Boston and New York. And I think a lot of people would approach the task this way. And certainly nothing wrong with that in any way. But what if the number of items here is going to grow? In other words, we might be additionally adding data in columns N, O, P eventually. Why not, instead of referring to specific cells here, why not refer to rows 4 and 5? And as I'm dragging across these with the mouse, look at the notation style. Sum of 4:5. Now that means rows 4 and 5. Press enter, we have an answer here. It's an unusual look at first, but it gets the job done, and it does have that flexibility of when we add new data, we don't have to readjust the formula. Of course, the data in cell A4 and A5, the text entries, are ignored here, and so we can get our total quickly. Similarly with Midwest, slightly different though, the cities are not adjacent to one another, but here too, we could begin with AutoSum, and then click row 7 for Chicago, comma, click row 12 for Cincinnati. A different look as well, but it means add up all the data in rows 7 and all the data in rows 12. Enter. And we're not going to do all these, but similarly with the South here, once again on just this example, AutoSum, our southern totals would be Atlanta from row 6, and that might be the only one, and possibly you might be including Houston as well, so possibly with a comma, Houston that way too, and enter. Using entire row references will make sense and simplify the look of certain formulas. In the next worksheet over, column references, these are likely to be used even more frequently. Suppose, for example, we want a total off here to the right, and maybe we're going to put it in column M temporarily. We want to know what the total salary is. Now the salaries in the example here in column H go all the way down to, as I double click the bottom edge, down to row 742. And we'd like to add up that data. And this might be a dynamic worksheet where the number of records changes from time to time. And so just as we saw with rows, we're going to put in a formula now that refers to columns. And once again, we'll make it simple with AutoSum. Again, we could start from the Home tab this time, use AutoSum, and then click on column H to add up the salaries. The reference here reads H:H. That's it. Enter. We've got an answer. We'll have to double click to make the data readable, and so we see our formula. Simply use the entire column reference. So we might add new records, we might take out records. Our formula doesn't have to be readjusted. Using entire column references, as we saw with row references too, makes sense. And you could imagine other columns here using different features here. If we wanted to know the average job rating, equal average would be one way to do this. We could then click column I here. That reads as I:I. The average job rating here is this. We want to simplify the display of it. Using entire column references does simplify the creation of any number of formulas, particularly if you're working with large lists of data. In this worksheet, we've got a formula in cell F2. It calculates the years of service based on a hire date. And we'd like to copy that formula down the column. And similarly, although we don't yet have a formula, we're going to put a formula into cell J2. It's going to calculate a new salary. Everybody's going to get a $2,000 increase in this particular organization. And in both cases, what we need to do, and it's a common need in Excel, is a formula needs to be copied into adjacent cells down a column. Of course, at other times, you'll be copying these across rows. But one of Excel's great shortcuts is the quick ability to copy formulas across large distances. In an adjacent column here, I'm just going to double-click the bottom edge of a cell to remind us that in this worksheet, there are 742 rows. We've written the formula here. Now, copying a formula with copy-paste techniques is just not the way to go here. A standard technique is to drag the lower right-hand corner. Now, with 700 rows, this might take some time, and what if our data was 7,000 rows or 70,000 rows? Simply double-clicking the lower right-hand corner will allow us to copy this formula and adjust it down the entire column. Now, when that happens, I think the first question that would enter your mind would be, well, how far did it get copied? Did this formula get copied all the way to the bottom? And we could certainly scroll to find that out. But a nice shortcut here is to press Control period. And when you do that, the active cell moves to the other end of the range. Press Control period again, we're right back up top. So Control period, which is a very strange keystroke shortcut, simply moves the active cell around the corners to the corner cells of a selected range. So once again, when we copy a formula down a column, Excel looks at adjacent data. It actually looks at other columns in this list and then makes sure that the formula gets copied down to the bottom of the list. So as I press Control Z here to undo, we'll do this one more time, double-click the lower right-hand corner, and then immediately press Control period to see how far it got copied, down to row 742. Similarly, in cell J2, we're going to write a new formula, equal current salary plus 2,000. And a small tip here, if I press Enter, the active cell moves downward into the next cell. I want it to stay in place because I want to copy the formula. So I'll simply press Control Enter, and the active cell will stay in place. And then we'll simply double-click the lower right-hand corner. And we see that the formula has been copied. Once again, we press Control period. Make sure that happens all the way down the worksheet, and it does. And double-clicking the lower right-hand corner of a cell copies that information. It works also for just pure text and pure numbers as well, although it's probably most beneficial when using with formulas. So it's a great shortcut, and there is no corresponding shortcut for quickly copying formulas across rows. This only works down columns. Sometimes in Excel, when you write formulas and functions, you want to actually take the results of the formulas and essentially turn them into pure values. In other words, throw away the formulas and keep the results. In this particular worksheet called Convert Formulas to Values, we've got formulas in column B that take the employee names and display them with only the first letters capitalized. It's by way of a function called proper. And so let's say that column A is not the way we want our data to look, but column B is. And yet right now, column B depends upon column A. We're using the function called proper to give us the results we want. So what we'd like to be able to do is convert these formulas into values. And there's a very fast and efficient way to do this. And we'll show you another example over in column K. First, let's look at column B here. What we want to do is freeze these results. Remember, they're all formulas in column B. And it would be kind of a cheap trick and a cop-out to say, well, let's just hide column A. That's not really the way to do this. We want to actually get rid of that data and have only one column for employee name, and we want those names to look the way they do in column B. So here's one way to do this. We can click the entire column. There's nothing else in the column except names. And then use the right mouse button and drag any edge. It could be the right edge, top edge, left edge, doesn't make any difference. But as we drag the data, we use the right mouse button, put it on top of the old data. And when we let go of the mouse, there's a menu, and we want to choose Copy Here as Values Only. When we do this, what we have in column A then, for example, that's page, comma, space, Lisa, and nothing else. We don't need column B anymore. It still contains formulas. We don't need it at all. We'll right-click column B and delete. And column A looks the way we want it to look, and all the formulas are gone. Now, in column J, we've got a formula here using numbers. We're calculating new salaries that are $2,000 bigger than the old salaries. Sometimes when you copy formulas, you simply want to copy them to themselves. Now, as we did with the previous example, we could use the right mouse button and drag this data on top of column H. That's one way to do this. Another way would be simply to copy this data to itself, again using the right mouse button. And this technique, slightly different than the other one, simply means we're going to temporarily drag this, for example, into column K, but not let go of the mouse, just drag it right back on top of column J. Then let go of the right mouse button, copy here as values only. And so what have we done? We have no formulas left in column J, just the pure answers. So here too, what we would probably do next is just get rid of column H, right-click and delete. And we can either leave this salary in this location, or if we wanted to drag it leftward, we could do that with the Shift key and simply drag this leftward between columns G and H. We'll let go of the mouse here, and we've simply moved it over here. But the main thrust of the shortcut here is the idea that we've taken the formulas that had existed here and converted them into their results. And there are any number of situations, particularly when you're cleaning up data, where it makes good sense to, in effect, throw away the formulas and keep the results. There are times when you might want to update values in a worksheet without writing formulas. In the data in columns B through F, imagine these were sent to you, and someone had calculated these. We don't know how necessarily, but they appear to be incorrect. And you've gotten some of the numbers back and you realize you want to make them bigger by 5. Now, one technique, of course, would be essentially a shadow set of formulas down here that would take all those amounts and increment them by 5 and then do a copy paste special and some other technique. But we can do this much, much faster simply by adding 5 to all of the cells without formulas. Pick a nearby cell, put in a value that eventually we'll get rid of. I'll put in a 5 right here. This is the incremental value. We're going to copy this, perhaps Control-C, right-click copy, either way. Select the data that we want to change, and then go to Paste Special. And you can get there with a keystroke shortcut, Control-Alt-V, as in victory. And then we'll simply add. Now keep your eye on a couple of the numbers. The 33 is about to become a 38. The 40 is about to become a 45, and so on. We've copied the 5. We're now going to add 5 to all of these numbers. They're all bigger by 5. And we don't need the 5 anymore. We can go to that cell and simply delete it. We have no formulas here. You could say no paper trail. We simply changed all of the values by 5. A different scenario over in columns I through M. Maybe these represent last year's totals, and you'd like to project this year's totals as being 10% bigger. And so if you were doing the math, you'd say, well, we need to multiply all of these by 1.1. You probably can't do too many of these in your head, but the 40s will become 44s. The 30s should become 33s if they go up by 10%. So as in the previous example, just pick an empty cell nearby, put in 1.1. This is our multiplying factor. We'll copy this, Control-C or right-click copy. Select the data that we want to change, right-click Paste Special or Control-Alt-V. And here, the operation is multiply. We'll click OK. Now, we probably would want to see the decimals here because most of those numbers are not even. So a quick fix here. From the Home tab, use the comma button. And we probably don't need 2 decimals, so we'll simply decrease that by 1. And so the 30s have become 33s, the 40s become 44s, and of course all the others have been adjusted too. They are all 10% bigger than they had been, and as in our previous example, no formulas here. We simply have new numbers. We've got different results, and we don't need the 1.1 anymore. 2 quick ways of changing values without writing formulas. As you work with formulas in Excel worksheets, there are times when you know a formula is incorrect, and yet you can't quite figure out what the problem is. I'm going to zoom in on the formula in cell D13 using the Control key and the mouse wheel. and then double-clicking the cell. Let's imagine that you know this formula is giving you an incorrect answer, and you've been working with it for a few years, and you recognize that if a certain portion of it is equal to a certain amount, that's going to be helpful in figuring out where the problem here is. So when you double-click a cell, or if you click in the formula bar, you can highlight a portion of a formula. Maybe it's this portion right here that you think is the problem. When you highlight this, you can then press the F9 key to see what that current result is. Now, what you're highlighting must be a coherent piece of a formula. F9 tells us that the average there was 162.5. Now, maybe immediately a light bulb goes off in your head and you say, oh yeah, that's it. That's the problem. Let's escape and go out and make some adjustments to the data that's being referred to there. Or maybe at another time you're saying, maybe it's this part of the formula. And so you can do this in pieces if you wish. Now, I'm going to highlight this chunk right here and then press F9. And we'll see what that's equal to. Maybe that's not very helpful just yet. So we'll then take that amount, divide it by the 12,000, we'll highlight this portion of it. Now, when you do this, you want to make sure that you're highlighting what would constitute by itself a valid formula. So in this case here, if I'm not picking up that left parentheses, if I press F9, I get a strange message here that's totally misleading. You just want to click OK and get out of here and probably press Escape. Maybe start over again. Double clicking again, maybe highlighting this entire portion this time, including that left parenthesis, press F9. Maybe that's helpful, maybe not. Maybe it's the average along with the information to the right that's a problem. Maybe it's the B1. And so if you have a sense of what the formula is supposed to do, and maybe it isn't working, by highlighting pieces of it and pressing F9, you do see what that piece of it is currently equal to. Now, it is important when you're doing this too, nearly all the time, do not press enter, because what you will have done is, of course, altered your formula and turned those locations into pure results. So many times you'll just press escape to get out of here. And so that can be a really valuable tool when you're trying to debug a formula. Another example here, and you might not have yet seen this kind of a formula, but a formula involves logical tests. In cell R1, here's a formula, and as I double click, it's quite lengthy, and we're not really going to get into the logic of it too much, but if you've worked with ands and ifs and ors and so on, when you highlight a portion of a formula, you might want to know whether it's true or false. So highlighting this portion of this formula while editing, once again pressing F9, tells us that that is false. And if you're familiar with how and works, you could say, well, no matter what this is, it's going to be false. That might be true or it might be false, but let's see what it is. Let's press F9. That's true. An and with a true and a false is going to be false. Possibly you'll highlight this just to verify that idea. As you do this, though, it's easy to lose track of what had been there. So it certainly isn't foolproof, and it doesn't get you everything you need when debugging, but the ability to edit a formula, highlight a portion of it, and press F9 to see what that piece of the formula is equal to can be extremely valuable in working with formulas in worksheets. To provide better worksheet documentation and make certain kinds of formulas easier to write, you can use what are called range names. In other words, you can give a name to a cell or a group of cells, and then use those names in formulas. In this particular worksheet, we're about to write a formula in column J. It's going to calculate a new salary. Everybody's going to get a 2.91% increase. There are standard ways to do this using absolute addresses, but the use of a range name negates the need for absolute addresses, and it provides some documentation. Let's give this cell a name, cell M1. As we click on this, then go to the left of the formula bar into an area called the name box. You'll want to click the drop arrow to see if there are any other range names already in place. In this case, there are not. Range names cannot begin with numbers. They should not look like cell addresses, and you cannot use spaces in them. You can use underscore. You can shift between upper and lowercase to simulate the look of words. I'm going to call this % increase. %_increase. And press enter. That cell now has a name. When we write a formula in J2 to simply calculate the new salary, we'll be using that cell reference but we'll be using its name, and we won't have to type it either. Equal H2 times, and I'll click on cell M1, and look what happens in the formula. The name pops in automatically if it exists. And then we'll complete the formula by adding on H2 to come up with the correct answer. And then copy this down the column by double-clicking. So every one of these cells, for example, this one, as I double-click it, refers to percent increase. That's cell M1. When you encounter a range name and aren't sure what it refers to, one quick way to find out would be to go to the name box, click the drop arrow, highlight the name in question, and when you click it, you will jump to that location in the worksheet automatically. And it might be in a different worksheet too. So that's the cell that has the name. And of course, we just created it, but at other times you don't always know that. It's quite possible that in this worksheet, we might also want to refer to other portions of it by name too. And there are times when you can use the adjacent labels. We've got labels here sitting on top of all the columns. Now this list might grow, it might shrink. We want to be able to refer to all of the statuses or all the salaries or all the years in different kinds of formulas. So in this case, we'll select columns A through J. And then on the Formulas tab in the ribbon, use Create from Selection. We want to create names from the top row, not the left column, so we'll uncheck left column, click OK. So what have we done? We've now used the word status, for example, to refer to all the data below it, the word salary to refer to all the data below it. So in a different context at a different time, if, for example, we wanted to know the average years of service here, we can type equal average, left parenthesis, and as we type Y for years, we see all the functions that begin with Y, but we don't want those here. We want range names, and they appear in the list too. Here's the name called years right there. Click it, press Tab, and so we have our answer. Similarly, what's the total for the new salaries? Equal sum, or we could have used auto sum. Now we can simply start typing N. There it is right there. New salary, click it, tab it into place, enter. We've got our total there. And we could use this with other functions as well, maybe a COUNTIF to figure out how many people have a certain status. So we can use those names here. Now, different scenario off to the right here. Maybe we simply want to refer to this data as a unit. And so we'll simply select it and give it a name. How about Jan-June data? So once again, using the name box to the left of the formula bar, click the drop arrow. And now, of course, we've got quite a few range names that we just created quickly by using those top row labels. Now we're going to create one called JAN_JUN_data, Jan-June data. And so if we want to write a formula over here that, for example, calculates the average, equal average, left parenthesis, I'll type J. There we see it right there. Click it that way, then press Tab and enter. Another way to get to these range names is, this time I'll do median, left parenthesis, press the F3 key to get a list of range names, and we can just paste the name. There's the one we want right there. Click OK, it's in place. And now we have the median. Again, referring to that group name Jan-June data. There will be times when you don't want to use the range name anymore. You don't need it. And so you can, by way of the Formulas tab, go to Name Manager. It shows you the different range names. Maybe we don't want to use Jan-June data anymore. It's right here, so we could delete it. Now that is going to cause that formula to no longer work, but we don't care because we do want to get rid of it. We delete this range name. Are we sure? Okay. Then click Close, and these two formulas don't work anymore because we got rid of the range name. And it's not a bad idea when you're working with strange data or a new worksheet from someone else who's sent you information, just to check out to see if there are any range names in place. When used judiciously, they provide a great source of documentation, and they do simplify the creation of certain kinds of formulas. In this workbook called Regional Sales, we've got 4 sheets with identical layouts. Here's the East sheet, Midwest sheet, South sheet, West sheet. We might be adding more regions. And you could imagine lists like this that might be comprised of data for each of 12 months, or possibly if it's geographically oriented, maybe one for each state, 50 different sheets. If they all have the same layout as these do, there are ways to create summary formulas and summary worksheets quickly and easily. Let's imagine that we might want to create a summary worksheet here. First thought might be, let's go to one of our sheets, for example, West, highlight this data maybe, and then copy paste it onto sheet 1, which is currently empty. That's certainly a viable approach. But a better way and a faster way is simply to make a copy of the entire sheet. And that takes care of formatting issues along the way as well as the data. You can move a sheet simply by dragging it. You can copy a sheet by holding down the Control key, and as you drag the sheet to the right, you'll see a little plus there. Let go of the mouse first, and you can easily copy the sheet. These two sheets, West and West 2, are identical in all respects except for their name. So what we're going to do is turn West 2 into a summary sheet. We begin simply by double-clicking the Sheet tab, typing in Summary, or some similar appropriate name. And by the way, this sheet could have been to the left of all of these sheets or to the right, doesn't make any difference. After typing in the name, we'll press Enter. And then, to be in sync with the data, we'll go to cell A2 and type in Summary. Now again, the data itself has not yet been changed. It's the same as what we have on the West sheet. But here's where we switch gears. In cell B4 on this summary sheet, we want this to be the total of retail couch sales from the East, Midwest, South, and West sheets. Now, we don't really have to make the column wider, but in order for this to be displayed more properly, let's do, somewhat arbitrarily, make the column wider. So we're going to write a formula here that will involve very little typing. And there are two major ways to create these kinds of formulas. They're often called 3D formulas. We'll begin with the equal sign and then simply go to the East sheet and click on the retail couches total. It's in cell B4, as it is on all of these sheets. Then put in a plus, go to the Midwest sheet, do the same sort of thing there, click that cell, put in a plus, then click on the South sheet, go to cell B4, put in a plus, and then off to the West sheet, click that cell, but no final plus. We press Enter, and we've got a total, 4870. Adding up the data from multiple sheets, simply by clicking. The only typing that was done there was the initial equal sign and the 3 separate pluses. Now imagine, if you're doing this for 12 months, a lot more back and forth. What if you're trying to do this for 50 states? You'd probably, somewhere along the line, make a mistake, click the wrong spot, something like that. So although this is appropriate and it is correct, as soon as we get a few more sheets here, this becomes a bit unwieldy. So there's a better way to do this. Let's begin simply with AutoSum. There it is on the Home tab. It's also available on the Formulas tab. Let's start with AutoSum, and then let's select all the sheets in question. And if you've worked with multiple worksheets before, you know that you can select different sheets by clicking the first sheet and then using the Shift key and clicking the last sheet. So the next step is to click the East sheet, and with the Shift key held down, click the West sheet. If you look in the formula bar, you see a formula that isn't complete, but I think you get the idea of what's about to happen. We're gathering data on all of the sheets, East through West. Now, we haven't indicated which cell we're trying to add here, so we'll click cell B4, and we're done. Enter. Same result that we saw before, a much more compact formula. Both of these are sometimes called 3D formulas. This one is much more concise, and this would work just as smoothly if we had 12 months or if we had 50 states. If we had all the states alphabetized, this would read Alabama: Wyoming. We only need to have to refer to the first and the last. No real typing here, really. We simply select the cells. So that completes this entry. We then copy it into the next 2 cells downward, and then across into these cells right here. Readjust our column widths, click in the upper left corner, double-click a column boundary, and we truly have a 3D summary worksheet that tabulates data from multiple sheets. So this kind of a formula is very simple ultimately and provides a lot of power when we're tabulating data from multiple worksheets that have the exact same layout. Probably the most common reason for a formula not giving you a correct answer is either the misuse or the non-use of parentheses. It does emphasize a concept too in Excel, what's called the hierarchy of operations. In this worksheet called hierarchy, we're about to write a formula in cell C17 that's going to calculate the percent of change if our total grows from 28 to 42 we've actually grown by 14, which is half of what we started with. So this would represent 50% growth. And in standard calculators, if we were working with a manual calculator, we would perform the subtraction first, something like this, and then we would divide our answer by the number that we began with. And pressing enter here gives us an answer, but not really the answer that's correct. It's 50% growth. Now, what really has happened here? In this particular formula, Excel, unlike standard calculators, performs the division first. Now, the symbols you see in column A, starting in row 19, represent what's called the hierarchy of operations. And when Excel sees a formula, you could say it refers to that list and says, in effect, what's the first symbol in the formula that I see here, looking down from the top? Well, it's the division symbol. And so Excel will actually divide these, and of course that's the value 1. And then we're simply saying, what, 42 minus 1? That's how we get the 41. That's not the correct answer. And so what we really need to do is to change this so that the subtraction takes place first. And we do that by putting in parentheses. And of course, in the hierarchy of operations, parentheses are considered before division. Everything within the parentheses is done left to right. So now the calculation will be such that we will subtract the 2, then take that result and divide by our starting value. And the answer 0.5 is correct. Most of us would then click the percent button on the Home tab to display it as 50%. And anytime you've got a formula that's giving you an obviously incorrect answer, certainly one of the first things to look for is either missing parentheses or possibly misplaced parentheses. Some people overcompensate by putting in additional parentheses. For example, here, that doesn't really hurt. It does make the formula maybe a little bit more complex looking, but that's not a problem. Anytime you've got a formula with an incorrect answer, that's likely to be the first thing to be checking for. The caret symbol that's depicted right here is not used by too many people, but if you have mathematical applications, it would be appropriate to use that symbol to raise a number to a power. So in an isolated case, here's a value. If you wanted that value squared, equal this cell caret 2. And perhaps in a different situation, if you wanted the cube root, fourth root of a value, equal this particular value, and we raise this to the 1/3 power if we want to do a cube root. Not too many of you will need that, but that's how that's done too. And the parentheses are absolutely critical in this example. So the cube root of 56 in our example here is 3.82. So it's important to recognize how Excel performs calculations and formulas, and most of the time it's simply a question of putting in parentheses in the appropriate locations. If you're trying to get some sense of the many functions that exist in Excel, and there are well over 450 of them, a starting point can be the Formulas tab in the ribbon. Now, let's imagine you're working with some data here. You've got some statistical background, but you're not quite sure which functions are going to come into play here that you might want to use. On the Formulas tab, and by the way, your display might look different here depending upon screen resolution. Sometimes these are stacked up more horizontally than you see them here. Recognize that if you have been using functions recently, there's a category called Recently Used, and if this is one of the ones you've used recently that you remember that you're looking for, you can certainly click one of those options there to quickly get to a function you've used recently. Without going through all possibilities here, recognize there are quite a few financial functions, and as you slide the mouse over any one of these, you can pause and read the description there, possibly even click Tell Me More to get more information about this function or that function. And so they're organized in categories. And most of us don't have the time to go exploring all the possible entries here. Text is another category you may or may not have heard about, and yet there are some extremely valuable functions there as well too. Usually it's the need that drives the looking for this function or that function. So there are quite a few here. And although I did mention a statistical function, strangely enough, you usually don't see that in the initial list of categories here until you come to More Functions. And then you will find statistical. Quite a few of those there, also quite a few engineering functions. And of course, if you've worked with Excel for a bit, you recognize that some of these are highly specialized. Some of you will never use these engineering functions. Others of you might not use these statistical functions. But if we did want to use one of these, suppose it's a statistical function, and maybe it has something to do with standard deviation. That's a concept that a number of people are familiar with. You don't necessarily know at first where to look, although beginning with the letter S would be a good guess. And as we get to that part of the alphabet, recognize looks like there are any number of them here. And at this point, of course, your knowledge of standard deviation is going to either start to kick in, or you will go at different times to the Tell Me More option here. But maybe you've figured out that it's this one here. You can click here. This will pop in the function name for you, give you some more information. You might, at that point, for example, move the title bar rightward. And if we wanted the standard deviation for these numbers right here, possibly we'd be highlighting these. In other words, we're taking advantage of the fact that we weren't quite sure which function we needed. We think we found the right one, and we're being invited here to actually select the cells that are in question. Formula is even displayed before we click OK. Click OK, and it's in place. Now, that's just one example in one function of all the many possibilities, but not a bad starting point because you get some idea of the scope of functions in Excel and a place to get started and to get some initial help on a description of each function as you encounter it. If you're about to use a function that you've never used, or maybe a function you haven't used in a long time, it's going to be helpful to use what's called the Insert Function button. Imagine this little scenario. You've heard of a function, you're not sure of its name maybe, but you know it can calculate the monthly payment on a loan, perhaps for a car or for a house, as we see with this raw data in columns B and column C. Let's imagine you don't know the name of the function. What's a good guess? Now, one approach here, and not the best, would be to go to the Formulas tab, click the drop arrow for Financial, and although the function is here, how long would it take you here to figure out which function it is? Not so fast. However, the Insert Function button, and you'll see it in two locations, is to the left of the formula bar right there. You'll also see it on the Formulas tab, the leftmost button. In either case, if you click this button, a dialog box opens. If you knew its name, of course, you would find it in the list here, and you could narrow it down, and let's say you don't know it though. There's a panel at the top, search for a function, type a brief description of what you want to do, and then click Go. So I'm going to describe monthly payment, or monthly loan payment, or how about loan payment? Is that going to be good enough? Loan payment, click Go. Excel narrows down the list. Now, it might not narrow it down quite as much as you would want, but let's just pick the first one is PMT, and the description below seems to be the match. Now, you can't always guarantee that what you've typed in is going to give you the first match right away, but looks like it worked in this case. Calculates the payment for a loan based on constant payments and a constant interest rate. That's what we're looking for. So if you have time, you can click Help on this function, get a help screen describing the function in more detail. Or if you think you're ready to go with this, maybe you do remember that you've used it a long time ago, let's just press OK. Excel will continue to lead us through the steps. And you may not be able to get every one of these perfectly right the first time, but the rate here represents a percent. Now, if you have data in the worksheet, you can simply click on it. So in this case here, the percentage rate is in cell B2, so you can click that. If you didn't have anything in the worksheet, you could be typing in a percent here too. Now, if you look at the fine print below, it does remind you that you need to divide this by either 4 if it's a quarterly payment, or 12, even though it doesn't say that explicitly, 12 for a monthly payment. And for those people who use this function only occasionally, that's what they often forget. You need to do that. NPER, we see the description of that, the number of periods of the loan, the payment periods. And in the example here, it's in cell B3, so we'll just click cell B3. The third choice here, the description, could be better. It's not in layman's terms exactly, but this is the amount of money that you're actually borrowing. And so in the example here, we'll just click on cell B4. And the answer is right here before we even click OK, but we'll click OK, and there's an answer. One slight variation on this could be if you want this to be expressed as a positive number so that you can plug it into the family budget or something like that, then the resulting function, and I'll double click to display it, if you want that to be displayed as a positive number, simply put a minus in front of PMT, or perhaps more pertinent, in front of the B4. So that's your monthly payment for borrowing $25,000, paying it off over 48 months when the interest rate is 3.5%. If you use this function every 6 months or so, that approach using insert function makes sense. If you start to use this with more frequency, you might just either write down the example or simply type it in manually, as a lot of proficient Excel users do after a while. And since the data that we're dealing with here is dealing with those 3 cells up there, if we had a similar need to calculate a monthly payment, principal and interest only, for a house, we could simply copy this formula, write word into this column, and then get an answer for what's our monthly payment, principal and interest only, for borrowing $200,000, 30 years, 3.75%. So just an example of how the insert function button can lead you along step by step and help you build a function that you're not too familiar with or maybe you've never seen at all before. The AutoSum button, found on the Home tab off to the right side and found on the Formulas tab off to the left side, is extremely valuable in building formulas. And probably out of all the operations performed on different worksheets, sum is probably the most commonly used function. A particular example might be in this worksheet. In cell G2, we simply want to get a total of the numbers off to the left. We'll click AutoSum. We see the display and we press enter. We can also do this in columns. The AutoSum button is designed to add data from above or from the left. We can also select the data ahead of time, and this means we only need to click AutoSum once, and the total will appear below this automatically. Sometimes we've got a situation where we want totals on the right side and below, maybe just one side at first. If we want a total here, we can simply press AutoSum. And by the way, there's also a keystroke shortcut. It's Alt equal. We could use that. We want totals down here. Maybe we'll use Alt equal instead. It's just a question whether your hands are on the keyboard or not. Alt equal also puts in totals that way. And pressing Control Z here to undo those last 2 actions, you could have a situation where from the beginning you knew that you wanted totals on the right side and on the bottom. Highlight the cells in this manner and either press AutoSum or Alt equal. Either way, you'll get totals on the right side and on the bottom that way. Now, you could have a situation where you want to add up data from above. I'm going to take out this total, just move this downward, and you can override the way AutoSum is about to calculate data. If we click here and use AutoSum, AutoSum will look upward for data first, and it's about to add that data. We don't want it to do that, so we'll simply take the mouse and highlight this data. In other words, redirect what AutoSum is about to do. And we can certainly do that too. And if you had a situation back at this data here where we simply wanted a grand total but didn't want any interim totals, we could put it here, we could put it there. We could simply press AutoSum, and then regardless of what it's highlighting, we'll redirect it to highlight just these cells. Also, when you're using AutoSum, you can highlight cells from different locations. If we somehow wanted to add up that data, comma, as well as the data over there in columns B, we could certainly do that too. Comma, and if it involved using another value somewhere, a value of 200, we can certainly do that. So regardless of the context, we can build and use the sum function in a variety of ways. Now, not so well known is the fact that AutoSum has a drop arrow to its right on the Formulas tab, and on the Home tab, it's got a drop arrow to the right as well. And suppose, for example, in this worksheet here, maybe we just wanted to do, instead of a total on top, we want to do an average right here. So we'll click the drop arrow for AutoSum, choose average, and it's about to do an average for us. We'll click enter. And all the other examples here where we used sum, we could easily have used average as well. Recognize the drop arrow only gives us a few choices. It gives us a max for maximum, a min for minimum. But it is handy at times to be able to get to these different tools simply by clicking the drop arrow that we see there. And here's a particular kind of situation that you'll want to be aware of. It's an oddity, but if we're about to add up these hours and minutes, we use AutoSum, and we know that's not correct. If you highlight these cells here, you can see in the formula bar at the bottom that they add up to 27 hours and 38 minutes. 338, do the math in our heads, that's 24 hours short of what it should be. So if you are adding up times, which you'll need to do here, a quick right click, go to Format Cells, and then in the time category, use the option that has a 37 in it. That certainly isn't intuitive, but you can see what it's about to display up above here, 27:38. and we could click OK and get a correct answer there. And if you didn't need the double zeros at the end there, you could go back and, by way of format cells, then jump into custom and take out the remaining seconds that are there, which we wouldn't need since they're just hours and minutes. So we could do that as well too. If you want to do an average here of this data, then again, you could take advantage of average and then redirect the cells to be average. In other words, we wouldn't want to include cell K9 there, but all the cells above it. So we can drag that corner as soon as we see the diagonal there. We can then just highlight this data here and then simply press enter to get an average of those cells. And then probably in this case here, line it up on the right side. So the AutoSum button and its drop arrow gives us quick ways for using commonly needed mathematical tools, mostly addition, but also average, sometimes maximum, sometimes minimum. Many Excel formulas take advantage of a basic feature called a relative reference. If we write a formula in cell J2 here, it's going to calculate a new salary. We will refer to a cell that's 2 cells away to the left. And when we end up copying that formula, we'll make sure, and we won't have to do anything special at all, that every formula that we copy will also refer to cells that are 2 cells to the left. It makes perfect sense in this example. But sometimes we need to use what's called an absolute reference. So let's begin with a formula here that's going to calculate a new salary based on data not only in cell H2, but also in cell M1. And there are any number of different ways to write this formula, but certainly one way would be equal H2 times M1, and then take that amount and add to it the initial starting salary. And so our new salary will be this amount right here. So we've referred to a cell that's 2 cells to the left and also a cell that's 3 cells to the right and up 1. And if we do nothing special in Excel, the standard way that we copy formulas, either by copying or in this case simply dragging across a few cells to see what kind of answers we're going to get, the idea of a relative reference kicks in, but it's not helping us in quite the way we would want here. In this formula, the formula is correctly picking up the next salary. That's from cell H3, because we need to go over 2 cells and get the salary. But the reference to the percent of increase, which is in cell M1, now has become M2. And as I double click on the next cell below this in J4, we see how that reference now becomes M3. And so what we really need here is an absolute reference. The relative references, in this case to H2, they become H3 here. Those are working just fine. But the reference to the absolute cell, M1, the one we want to be absolute, isn't working. We need to make this reference absolute. And as you pick up on this, as soon as you see these in the future, you make the change immediately, usually. But if we're editing this, we can click after the M1, in front of it, or click in the middle, or even highlight it, any of those. But we make this an absolute reference by pressing F4, or manually typing $signs. Now, you wouldn't instinctively know why $signs are being used here, but it does mean now that if we copy this formula, the reference to M1 stays the same. It's an absolute reference. And that's exactly what we want in this particular situation. So completing this entry here and then copying it into a few cells just to check it out, make sure it's working okay. Looks like those salaries are changing. What's this third one look like? Double click, we see what's happening. The reference to cell M1 stays the same. And there are certainly times like this where that's the only way to do this intelligently. Filling in column M with that percent over and over and over is not the correct way to do this. The absolute reference is what we use here. And so simply pressing F4 makes the reference absolute, although you can manually type the $signs as well. But they certainly are needed at times, and it's not uncommon to see formulas with relative references like the H2s here and absolute references together in the same formula. In this worksheet called Mixed References, we need to write a formula here that's going to calculate how many couches go to our different regions here. And not only couches, but also recliners and other items here too, and potentially maybe a much bigger list. And writing a simple formula here takes almost no time. If we were calculating only the total for couches for the East, we'd write a formula equal and then multiply these 2 cells in no particular order. either C4 times B5 or B5 times C4, we'd come up with an answer. Now, in Excel, that formula could be read as, let's multiply the cell from above by the cell to the left. And so if we were to copy this formula, we would quickly get some answers here that wouldn't make a lot of sense. If we simply drag this down here, we see immediately we've got a big problem. What's this formula doing? Well, it's doing exactly what this formula is if we describe it as multiplying the cell above by the cell to its left. What is this formula doing? Multiplying the cell above by its cell to the left. We don't want relative references here. And it looks as if at first what we really want to do here is to change our initial formula so that it always refers to C4. And if we were to click behind the C4 or in front of it or between the two characters, we could press F4, and that would certainly work if we were concerned only with this column. And so if we complete this entry and then copy it downward into the next few cells, we do have correct answers. But we've got other regions here. And if we look at this formula again, what we're really saying is every formula, if we were to copy this, will always refer to C4. And we certainly don't want to refer to C4 when we're calculating the Midwest totals. We need to refer to D4. So it seems a little tricky at first, but here's something we would notice. Every formula, if we were to consider writing it manually, if you think about it, always needs to get percentages out of row 4. And every formula, if we were to write it manually, would need to get the quantity out of column B, no matter what. And so if we go to our first formula here, what we can do here, and this is by no means intuitive, but if we make sure that our formula always refers to percentages in row 4, we take this portion of our formula and either selecting it all or simply clicking within it, press the function key F4 repeatedly. And notice that we're now seeing the dollar sign appearing in front of the row reference, or in front of the column, or in front of neither, or in front of both. Whatever follows the dollar sign will remain absolute. We want every formula that we would consider writing manually here to always get data from row 4. We need to press F4 repeatedly until we see the dollar sign in front of the 4, but not in front of the C. The quantities in all cases, no matter where the formula might be here if we were doing it manually, needs to get data from column B. So in the other portion of our formula, click in front of it, after it, or between it, press F4 repeatedly so that we see the dollar sign in front of the B, but not in front of the 5. So that's going to be our master formula. Complete that entry, then drag downward, and then drag rightward. Or right then down, makes no difference. And every one of these formulas appears to be accurate now. And if we just pick one of them, double click it, we see what's happening. Like every other formula, there's a dollar sign in front of the 4, there's a dollar sign in front of the B, and these are called mixed references. In other words, a portion of the reference is absolute, and a portion is not. Either the row or the column reference is absolute in these examples. And you can imagine in a situation like this, as we put in more and more furniture items, we still need only write one basic formula. Make sure our references are mixed here in the appropriate way, and then copy our formula rightward and downward, or downward and rightward as the case may be. So a mixed reference is sometimes required, and there's no other quick way to come up with these formulas in a sensible way other than how we just saw it here. One of Excel's most important functions is the if function. It's almost like it's a threshold function in the sense that it opens the door to a more expansive use of functions in Excel. It's almost programming-like in nature at times. In this worksheet called Simple If, we're going to use the if function in column I to provide one of two different answers. This company has decided to provide bonuses for those whose job ratings are 4 or 5. And so a different way of stating the situation is to say, if your job rating is 4 or 5, we're going to put the value 2,000 in the bonus column. If not, 0. Now, the if function might be lengthy in its actual text entry, but the result is going to be a simple answer here. So we don't really have to make the column wider, but I'm going to do this so that we can see the function in its entirety on a single line as we create it here. So scrolling to the right and then arbitrarily making column I substantially wider. We're going to use the if function right here in cell I2 to check the job rating. Equal if. In its basic form, the if function has three arguments, or sometimes called parameters. The first is a logical test. A logical test could be something like comparing two different cells, or in the case of what we're about to do here, comparing a cell with a value. You can also compare a cell with a formula or with a text entry as well. So quite a few variations on what a logical test might be. So in this example, we simply want to type or click J2 to see if it's greater than 3. Now this is one way to come up with our test here in the example. That means, of course, 4 or 5. All the job ratings are whole numbers. Now a different construction, but one that will have the same meaning in this example, is to say greater than or equal to 4. So either way, it's the same. Now, as soon as I press comma, watch the bold print below change to put the emphasis on value if true. The value here could be a simple value, for example, 2000. It could be a calculation, a formula within the if function. It could be another cell reference. It could be a text entry embedded in double quotes. In our example here, it's simply going to be 2000. Comma, what's the answer when the condition fails? In other words, if the job rating is 1, 2, or 3, what is our answer? We might put in 0. That would make sense in this context. If we want to display nothing, we put in double quote, double quote. If we'd like to display a text entry, we put text between the double quotes. So a number of variations here. All functions end in the right parentheses, but you don't really have to type it if there's only a single set. So we can press enter here, or slightly better, if we know that we want to copy this function downward, we'll press Control Enter so that the active cell stays in place. And that's the answer you'd expect in this context because the job rating is 1. So we'll double click the lower right-hand corner, and as we look at the various answers, we can see they seem to be making sense. I'll press the F2 key here to display the content of cell I2. And so that's the same kind of formula, of course, that we're seeing in the remainder of column I. So in all these examples here, we're simply testing the job rating, and when it's equal to 4 or 5, the answer is 2000, otherwise it's blank. In this example, we've seen a simple use of the if function. A test, it's either true or it's false, and we've provided an answer for each condition. There are times when you're using the if function when you want to provide more than just 2 answers, maybe 3, maybe 4. In this worksheet, in column I, is a formula. The test to see if a job rating is 4 or 5, and when that's true, the answer is 2000, otherwise blank, empty. This company has changed its mind and now wants to give smaller bonuses to those who have a job rating of 3. Now, when you're looking at a function, you can't really observe what's happening as it's actually being used, but the logic actually happens left to right. When this condition is true, in other words, when the J2 entry is 4 or 5, the answer is 2000, and you could say the logic stops, the function is over. But when this condition fails, the logic goes after the 2000, and you could say it's waiting right there. And so what we're about to do now is to say, let's check and see if the job rating is 3. And so we're putting in a second if, called a nested if. If this job rating equals 3, comma. When that's true, we're going to provide an answer of $750, comma. And when it's not true, and that means the job rating would be 1 or 2, the answer is blank. So this is an if inside of an if, and we do have to put in the final parentheses. The total number of left and right parentheses must always match, and in these cases, they must be typed. So in English, we're saying the following. If your job rating is 4 or 5, you get $2,000. If it's not, we'll check to see if it's equal to a 3. If it is, you get $750, but if it's not, nothing. So as I press Control Enter here, and then double click to recopy, we'll see a slightly different result. For example, in row 5, we have an answer of 750. The function, a use of the nested if, now provides 3 possible answers. We could take this a step further. You might question the wisdom as to why they would be giving a bonus to those with a job rating of 2, but they still might want to do that. And so here too, extending this logic even further, we would, after the 750 and the comma, put in another if to see if the job rating, and this time since I can't click on it, the editing is extending into cell J2, I'll simply type the J2. if J2 equals 2, comma, and this company has decided to provide them with a token bonus of $100. If that's not true, in other words, if it's not a 2, comma, the answer is blank. So now we have an if inside of an if inside of an if, and we need one more closing parentheses. This, by the way, is referred to as two nested ifs. And in older versions of Excel, 2003 and prior, the maximum number of nested ifs was 7. And believe it or not, as of Excel 2000, you can have up to 64 nested ifs. And I think you can see how unwieldy this is becoming. Now, if you're familiar with the data, this maybe isn't that big of a stretch, but the more ifs you add, the more opportunity you have for making a typing mistake, misplaced comma, you forgot a parentheses here or there, you typed minus instead of equal, that sort of thing. And I would strongly suggest if you're using functions like this, if they somehow have become necessary, use a large zoom factor. Make this large and clear on your screen. So as I press Control-Enter to complete this, and then we've copied all these, we see different answers now. And of course, here's what happens when it's a 2. There's the logic. And I'm just displaying the function there, you can see it too. So in all these examples here, we're providing additional answers by way of a nested if. Remember, the maximum is now 64, and as they say sometimes, don't even think about it. You're not going to see too many more than 3 or 4, but here and there with certain kinds of more complex situations, at least you have the possibility of using these extended ifs. If we wanted to display this ultimately, and we could just drag it out to here and then see the entire function played out in the cell here with the answer to the right a bit more clearly. Ultimately, if this is all we wanted to do with the particular function, of course, we just make column I by double-clicking its rightmost edge, just wide enough to display the answer. So we've seen an example here of using a nested if, and in the final example, we've shown 2 nested ifs. Sometimes it's necessary to use the if function in a compound way. In other words, to check for multiple criteria. This is different than a nested if. In column I, we're using the if function to come up with either an answer of 2,000 or blank, depending upon the job rating. This company has decided to only provide bonuses for full-time people. And you can see in column D, the various kinds of status there. Not everybody's full-time. And so what they'd like to be able to do now is say the following in English. If your job rating is 4 or 5, and your status is full-time, you'll get the $2,000. But only if both of those are true. Otherwise, no bonus. So I'm going to type the word and here in front of the J2. And that seems a little strange maybe at first. The and function can stand alone. It's not uncommon to see it in an if function. And is followed by 2 or more conditions. We've got one condition in here already, and that is that the job rating must be 4 or 5. But along with that, we want to also provide the requirement that the status entry, that's in D2, is equal to full-time. And we put this within double quotes. Now, the upper and lower case isn't critical, but why not type it the same way? The spacing certainly is. And a comma. So the and function, which can stand alone, is followed by 2 or more conditions separated by commas. And a lot of times people say, why can't we put the and, or why isn't the and between the 2 conditions? Well, there certainly can be more than 2 conditions. There could be 3, 4, or 5, up to 31. And if we were to use the word and over and over and over again every time we had a new condition, it certainly would make the function much, much longer. So and appears once here, followed by a set of parentheses with 2 or more criteria. So when both of these are true, 2,000 is the answer. So if I were to complete this with Control-Enter, in the first case, of course, no bonus because the job rating is low, even though the status is full-time. So even though one of the 2 criteria is met, not both of them are. So as we double-click the lower right-hand corner here to copy this down the column, I think you can see pretty readily, and I'll press F2 to display the function in its entirety. We can see what's happening. In row 4, the status is full-time, the job rating is 5. Both criteria are true, therefore the answer is 2,000. Same thing is true in row 6. And you can see in certain other examples, for example, in row 9, good job rating, but wrong status, and so on. And so sometimes you'll see the and function being used in this way. Now, its companion, but certainly with a different meaning, is the word or. And in this case, if we were to use or, we're saying if either condition is true. And that's certainly a more popular decision by management because a lot more people are getting the bonus now. Even the person in row 2, now for the moment we can't see the job rating. Let me make column I substantially wider and then press F2 to see this again. There is a bonus for the very first entry there. Even though the job rating is 1, the status is full-time. And you can also see the same kind of thing happening in row 10 here. Bad job rating, but the person is full-time. And there will be times when you see a mix of ands and ors and it starts to get a little tricky. What if once again this company changes its mind and says the following: we're going to give you a bonus if your job rating is 4 or 5. Flat out, no matter what else is true, we'll do that. But if that's not true, we will give you a bonus if you've got a combination of being full-time and having, for example, more than 10 years of service. So we'll put in an and here, an and inside of an if, and the and requirement is that you be full-time, comma, and your years of service, that would be F2, in cell F2, is greater than 9, let's say. 10 or more, of course. So I've got an and inside of an or. We've got to be careful with these parentheses. We need another right parenthesis right there. And as I complete the entries here, not a whole lot has changed until we start to scroll, but let's look at the function again. I'll make the column even wider. And what are we saying now? If either your job rating is 4 or 5, or you've got a combination of being full-time and having more than 9 years of service, you'll get the $2,000. As we look at some of the entries here, we can see, for example, in row 4, that person gets the bonus just on the basis of the job rating only. Now, a bit later here on some of these entries, for example, the entry in row 10, down here. In row 10, the job rating is poor. It's only a 1, but that person does have that combination of being full-time and having more than 9 years of service. Therefore, that person gets the bonus. Now, when this is your data and you've been working with it a lot, even though this logic here is a bit tricky, these tend to fall into place a little more readily than you might expect. Still, there are times when these can get quite lengthy and expansive. And again, pure logic is at work here, and based on the numbers that you're working with here, these do make sense. You got to be very careful with the parentheses. Very easy to make a typing mistake. But I think you can see there's the programming-like aspect to these as we work with more complex situations. And here's a tip too when you encounter one of these. On a different worksheet here called Locate Formulas, there's a formula in cell R1. Now we're not really going to be worrying about the answer here, but as I double-click this, imagine encountering this and trying to figure out what's going on. There's a little tip for seeing these a bit better, and that is the following. You may know, and I'll do this in a different cell just for an example, if you're typing an entry and you'd like to put an entry on a second line within the same cell. Suppose, for example, you're typing 2014 and you want the word salary to appear under this. You can press Alt-Enter and then type salary, and then Enter, and it keeps the two items in the same cell. Now, it doesn't seem like it's exactly pertinent here, but in cell R1, if you were trying to figure out this formula and were having a tough time with it, while editing it, and I just double-clicked to do editing, you can also do this in the formula bar. I'm going to press Alt-Enter right in front of the second if. And I'll do this in front of the next if and the next if, and all of the ifs, ultimately. Alt-Enter. All I'm doing here really is introducing a line break into the function. I'm not changing what the function is doing. The logic might be faulty. It could be better, no question about that. But the key idea here is we have a much better chance of understanding and picking apart this particular use of the if function, this multiple nested ifs here, 4 nested ifs. We're going to have a better chance of understanding it if we can view it this way. In other words, we're giving this structure simply by pressing Alt-Enter. Notice the color-coded parentheses, that helps a bit, but you've got your work cut out for you. These functions, when used like this, are sometimes called job security functions because only one person seems to know how to fix it, and maybe that's the person that wrote it. Nevertheless, by pressing Enter here, we have not changed the result. We haven't really changed the function, but when we come back to it and double-click, and we're prepared at some point to pick this apart and make it work properly, we can work with it much more easily when it's displayed in this structure. So in this movie, we've seen a number of different examples of using the and, the or, and sometimes in combination functions along with if for more complex situations. Comparing data in Excel is a frequent need, and on the Formulas tab in the ribbon, you'll see a category of functions called Lookup and Reference. The two most important functions in this category are called VLOOKUP, you see it at the bottom. V means vertical. Its companion function, HLOOKUP, H means horizontal. When you're looking up information, it's not uncommon to want to compare data with a table. And tables sometimes are in the same worksheet as the data you're trying to compare them with, or sometimes in different worksheets, even in different workbooks. In this workbook called Lookups, we want to come up with the tax rate in column K for the salaries in column J. If you didn't know about lookup functions, you'd be tempted to try an if function, but it would become very unwieldy very fast. We'd have to have multiple nested ifs. It would take quite a long time. When you're looking up information in a table could be structured vertically, like what we see here, in which case we will use a VLOOKUP function. A table could be structured horizontally, like the one to the right. If you look at these two tables side by side, you see that they do contain exactly the same information. So if you were designing a table to look up tax rates, would you use the one on the left or the one on the right? I think most people would use the one on the left because it's just more compact on the Excel screen. It just fits on the screen better. There might be cases where you inherit a worksheet from someone else. Some lookup functions are already being used, and maybe they are using this table. You'll probably go with the flow and continue to use that table. But if you're designing it on your own, you're probably more likely to use a vertical table. Based on the two examples, and with no other knowledge about tables, you might think that they are always either two columns or two rows. But off to the right here is a different situation, one that we'll see a bit later in a different worksheet, where the table has many columns and many rows. So there are quite a few answers in this particular table, these potential answers. So tables can be of varying sizes. And wherever possible, when you're setting up tables, it's likely to be easier if the table's in the same worksheet. Now, sometimes you might want to move them later, that's fine. And sometimes you must use tables in different workbooks, worksheets, and that's just the way it's going to be. So in column K here, whether we use VLOOKUP or HLOOKUP, we'll essentially be using the same kind of mechanism. The other thing that we need to say about these two lookup functions is that sometimes they're based on looking up information in an approximate way. In other words, here, we're trying to find this value, 61,760, in the left column of this table, or possibly the top row of the other table. But do we really expect to find that value here? Well, theoretically, it's possible. But this list only contains breakpoint type numbers. And so when you're looking up values of a certain type, like here, we use a VLOOKUP in a manner for what's appropriate for an approximate match. At other times, if we're trying to compare an ID number or someone's name with a list, it has to be an exact match. Can you imagine somebody, for example, looking up a social security number and saying, well, close enough is good enough? That's not going to be good enough. So sometimes when we use lookup functions, we're concerned with them being an exact match, and sometimes not. But as we've seen in this particular worksheet here, we might be using a vertical table or a horizontal table, or in other cases, possibly much larger tables to look up information from. And these VLOOKUP functions and HLOOKUP functions certainly are going to be a much better result. And these lookup functions, both horizontal and vertical, are going to get the job done much, much faster than using unwieldy if functions. In this worksheet called Approximate Match, we need to have a function in column I that's going to look up the salary from column H, and then using either the vertical table in columns M and N or the horizontal table to its right, we need to return the percent, in other words, the tax rate for that appropriate salary. The first thought might be, what will Excel do, or what will these functions do, in looking up this value? I think the way most people would understand this, thinking outside of Excel for the moment, if you were looking up 61,760 in a list of this type, you would say, in effect, that the 65,000 and the 10% is too high because the value hasn't reached that level. And so your answer would be 8%. And that's the way the VLOOKUP function and the way the HLOOKUP function will provide answers here. Now, we want to contrast the two functions. VLOOKUP is likely to be the better choice because it fits on the screen better, it's easier to read. Keep in mind, these tables could be in different worksheets, even in different workbooks. It's certainly going to be easier to set up if they are nearby. So let's make the column wider also so that we can actually see the function better. And let's begin by using the vertical table in columns M and N as we use VLOOKUP. We begin by selecting the value that we're trying to compare with the table. It's in H2, comma, then the location of the table itself. It'll be these cells right here, comma, and then we put in the column number of the table that has the answer. And note that I said column number, and the prompt below that says column index number. So although it's literally in column N, it's the second column of the table. If we were using VLOOKUP to find an exact match, we would use a fourth argument. And the term range lookup probably doesn't mean a whole lot, but that's necessary if we were trying to match up the data exactly. We're not trying to do that, so we're finished here, and we can press enter. And we do get our 8%. Now, what's going to happen if we copy this formula down into the next few cells? The reference to the table will drift away from it. So we want to make sure that our reference here is absolute. So we highlight these cells and press F4 to make that an absolute address. Now, there are two other solutions here that could be better, but this is certainly viable, and we could then double-click and copy this down the entire column and check out a few answers. They all make sense. The reference to the table stays constant, stays absolute, because we put in the dollar signs by selecting the table location and pressing F4. Now, one different way to do this is to give the table a name. We can highlight the cells and give it a range name by pointing to the name box, which is to the left of the formula bar. Click the drop arrow to see if there are any other range names, because we don't want any conflicts there. And use a name that does not contain spaces, cannot begin with a number. You can use upper and lower case, something like this too. You can do that, something like we see here, or possibly use an underscore. So we're naming the yellow cells tax table. Then we can come back to our formula, and instead of using this, we'll use tax table. Now we could either type it, or we could go highlight the yellow cells, or we could press the F3 key to get a list of range names. We have only one, there it is there, and we'll simply click OK, pop it into place. By definition, that is automatically an absolute address. So we'll complete that and double click the lower right-hand corner. And then all of these entries have tax table in them. Slight downside here is, if you're not the one that created the range name, when you first encounter this, you're not sure what it refers to. And what you do in those cases is go to the left of the formula bar, into the name box, click the drop arrow, highlight the name in question, and then Excel jumps over and highlights those cells, even if they happen to be on a different worksheet. A third approach to this also has merit, and it has an additional value over a range name if, over time, maybe this list will grow a bit. You might put in different breakpoints. Maybe it's going to take up a few more cells down below. So that we don't have to redefine that, we could use column references here instead of a range name. So instead of tax table, we could use MN. Just click and drag across it. Now that too is a variation on the concept of an absolute address. If we copy this function downward, it's always going to say MN. We don't have to worry about an absolute address. And as long as we put nothing else in columns M and N, except the kinds of data related to this table, this is going to work indefinitely. So that has some merit too. And it's a clean look also. Had we been using the other table, we would use not VLOOKUP, but HLOOKUP. And we simply change the V to an H. And of course, we were looking at a different table. In this example here, we'd be highlighting that and changing it to the cells over here. Now, I'm not going to give a range name to these, but we certainly could. I'll just highlight the cells. And you can see, as I scroll back leftward here, as we're looking at this here, if we were going to copy this, we'd want to make this be an absolute address. So we'd press F4. When this was a VLOOKUP, the 2 stood for the second column of the table. In an HLOOKUP, the 2 would stand for, and does stand for, the second row of the table. So even though we don't change it, it has a different meaning here. So we're going to be getting the same answer here. So whether we use an HLOOKUP like we've just seen here, or in the previous examples of a VLOOKUP, we can quickly come up with the tax rates here much more simply and directly than we would if we're using an if function or some other complex construction. And one other aspect of these tables that needs to be observed before we conclude this discussion is that the entries in the left column of a vertical table, or in the case of a horizontal table, the entries in the top row, must be in ascending order. Now, when they're not, strangely enough, you still might get a lot of correct answers, but it's going to be inconsistent. And so if, for example, here, if I go back to this list here, I'll just press a few Control Z's here to go back and make this be a VLOOKUP again. What happens if a mistake is made here? I'm typing this, making a correction or something, and I type 85,000. Of course, I'm doing it on purpose here. Now, watch the answers off to the left. A lot of them are going to stay the same. A couple of them changed, but you could easily be fooled into that. And so you want to make sure that these entries are in ascending order. They don't have to be equally spaced. The other thing you want to concern yourself with also is that make sure that the lowest possible entry is covered, and it certainly is in this case. If somehow this table started at 25,000 and you had a salary that was less than that, you would get a distinctly incorrect answer for sure. Any value over 95,000 in the list of salaries in column H would automatically revert to 13%. But do keep an eye on the order of these, and so to recorrect this, I'll simply make that be a 35,000 again, as it should be. So we've seen the value here of using either a VLOOKUP or an HLOOKUP function to look up information from a table. In this worksheet called Exact Match, we're trying to get the ratings in column E to be translated into a numerical score. The table in columns A and B gives us the lookup information that we need. And so there's a function in cell F2 that appears not to be giving us the answer we would want. Fair, as we look at the table, should be a 71. So let's take a look at the function in F2. It's a VLOOKUP. In other examples where we were trying to match numerical information in an approximate way, we simply would put in 3 arguments using VLOOKUP. But here it's a little bit different. We need an exact match. We have to find the word fair exactly in that table that's in columns A and B. When we do find it, we want our answers to come out of the second column. So far, this function has everything in order. We're looking up cell E2. We've got a table over in columns A and B. We want to get our answers from the second column of that table. However, for an exact match, we need a 4th argument. And as soon as we enter a comma here, the pop-up tip gives us 2 choices. True for approximate match. Now that's called the default, and you don't need to use it in those situations. You can just ignore it. But if you want an exact match, you use false. Now there's an option here for using 0 as well. You can click on this and press tab, or you can type it either way. Now, do you think you would instinctively know that false means exact match? I don't think so, but that's the way it works. We use false or 0, and I'll use false at first because it's more commonly seen. So anytime you're looking up information, and the information that you're looking up, if it has to match exactly with information in the left column of a table, then following the column that has the answers, you put in the word false to make sure it's got to be an exact match. So when we press enter here, we're expecting to get a 71. And that's exactly what we get. And by double clicking the lower right hand corner here, we should get correct answers for the others as well. You check out a few, seems to make sense. As an option or as an alternative to false, you can use 0. Now, I'm not saying that that's any more logically accurate, or you wouldn't instinctively use 0 either, but there is another lookup function that we will see a bit later called match that does use 0 for an exact match. So with that in mind, why not use 0 here also? It is less typing too. And a third thing is that false seems to suggest that maybe something didn't work, even though it means exact match. So you could just as easily use 0 as well as false in these examples here. A couple of issues come up when you're making comparisons for exact match. First of all, if somebody had just typed something different here, completely different. If I type in mediocre, that's not in the list. And this is an exact match kind of VLOOKUP. And so there is no mediocre found in the table. So what else can Excel do here but provide an answer like this? So obviously that's not going to work. But here's what's more insidious. I'm going to put a trailing space behind fair in George Babbitt right there. I'm double clicking to edit. I'll put a space behind it and then enter, and you see what's happened. And down here under Sebastian Cabot, I'm going to put in multiple spaces between very and good, and that doesn't work either. And sure enough, a leading space somewhere here in front of Norman Bates, those are all failing. So a quick workaround here using another function, and not uncommon when it comes to using VLOOKUPs with exact match, is to use, in effect, a cleaned up version of what's in column E. And the function to use here is called trim. Now trim removes leading spaces, trailing spaces, and multiple consecutive interspaces get reduced to 1. So as we use trim on the first entry here, it will solve the trailing space problem there and cause our match to work. And as I recopy this downward, all these except for the entry under mediocre will get corrected. So we've got the multiple spaces that are dealt with there, and it's always using the trim function to clean up the data. And the leading space that we have down here, that's also dealt with properly here as well. For an exact match, you need a fourth argument of using 0 or false to mean exact match. The fourth argument is needed. This is always going to be the case when you're looking up text entries, and it's also going to be the case if you're looking up ID type numbers. So sometimes VLOOKUP needs to have an exact match. If you're using HLOOKUP on a horizontal table, the same thing is true. You'd be using that same fourth argument of 0 or false for exact matches. Sometimes in lookup kinds of situations, it's going to be more appropriate to not have an external table, but have the answers actually embedded into a function. We're talking about the choose function. In this example here in column B, in this worksheet called choose, we'd like to come up with the quarter information based on what we're seeing in column A. A key function that we will be using here inside of choose is the month function. And I'll use it just independently at first here. The month function will tell us which month of the year this is. So if this is September, we get an answer of 9, and we see that. September's in the 9th month, but that's the 3rd quarter of the year using standard chronological quarters. So what we want to do here, instead of having a table to look up this information, we'll use the choose function here. Now, a mathematician might come up with a better way to do this. It might not be clear to others necessarily, but you could certainly use other techniques to come up with an answer here. The choose function begins with the concept that we have a value somewhere, either by way of a function or another cell. In this case, that happens to be a 9. But what we're going to do following this, instead of an external table, is have all possible answers. We have only 12 possible answers here as we look at different dates. There are only 12 possible months. When that answer is 1, that would be January, we put in the answer for January. That's going to be in 1st quarter. If this answer here is 2, meaning February, then that 2 is going to be in the 1st quarter, so we'll put a 1 out here too. And the next one, of course, would be March, and we have another 1. So if these entries are 1, 2, or 3, meaning January, February, March, our answers are going to be 1, meaning 1st quarter. And I think you can quickly see how we can fill this out by putting in 3 2s, and then 3 3s, and then 3 4s. Right parenthesis, we're done. We'll double click to copy this down the column. And I think you can see that in all cases here, we do have correct answers. In some organizations, and certainly in the federal government, the quarters work a little bit differently. In the federal government, their fiscal year begins in October. And so January, February, and March are in the 2nd quarter. So if we come up with a month that's 1, 2, or 3, our answer is not going to be 1 for 1st quarter. It's going to be 2 for 2nd quarter. So all we'll do in this case is take out the 3 leading 1s and put them at the end after the 4s. Make that correction, change, readjust, and now we've got the appropriate quarters if we use a quarter system the way the federal government does. So September's in the 4th quarter. Remember, month of A2 in this example is actually 9. So the 9th entry that we see over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's in the 4th quarter. So we see that example out there. October begins the 1st quarter of the fiscal year. So you can see how with certain kinds of lookup situations, if the numbers are relatively compact in terms of their variation, this might be a better way to go than having an external table. Everything is embedded within the function itself. Ultimately, of course, this column only needs to be that wide too. So using the choose function is an alternate to a VLOOKUP or an HLOOKUP, both of which require external tables. This doesn't. In this worksheet called Large Table VLOOKUP, we're trying to look up a tax rate from a table that's quite large by most people's estimation. The table is from column F over through column M and goes all the way down to row 18. Got well over 100 different answers there. And what we're trying to do is to look up the appropriate tax rate for people whose salaries are in column B and their dependents are listed in column C. So we'll be using a VLOOKUP here. And we're first comparing the salary. Now this will not be an exact match, it'll be an approximate match. The salary is in cell B2, comma, and the table in question extends from column F through column M. And once again, as in previous examples, if there's no other data in the columns, it's going to be simpler to use the column references in their entirety. It's a simple display, it's easy to read, you don't have to worry about absolute addresses. The tricky part comes in to the idea of which column will have the answers. And as we look at a person with one dependent, if we look at the table, it's going to come out of column H. Looking into the next record in row 3, if you've got 3 dependents, the answers are going to come out of column J. But what we need to be thinking here is which column number of the table do we need? If a person has one dependent, the column H entries are going to be the source of the answer, but which column is that in the table? If the table begins in column F, then column H is the 3rd column. So if someone has one dependent, then we need to get data from the 3rd column. How about the next person who has 3 dependents? Which column of the table are we using? Column J. Which numbered column is that as we read from the left? 1, 2, 3, 4, 5. So it looks as if every time we need a column, it's 2 greater than the actual number of dependents. If it's 1 dependent, we get data from the 3rd column. If it's 3 dependents, we get data from the 5th column. And so what we need to do here to pick up the appropriate column is to take the dependent entry, in this case C2, plus 2. And in all other cases, as we look downward and start comparing this list with the number of dependents, the column we need is always 2 greater than the actual number of dependents. And so if this is all going to be working properly, as we look at this 46,000 here, we'd be looking in row 9 for our answers. And because this is one dependent, we should be getting 10.4% here. And that's exactly what we're getting. And looking ahead into the next entry for 56,000 and 3 dependents, we'd be looking in row 11, 3 dependents, 8.7%. So we'll double click, and sure enough, we're getting that answer as well. So you can see in these examples, if you're using large tables, you sometimes need additional methods to come up with the answers. And depending upon the nature of the data, sometimes these will be exact matches, sometimes not. But in this case here, we wanted to point out the unusual aspect of a particularly large table, and also perhaps an unusual way of coming up with the appropriate column reference for the VLOOKUP. In this worksheet called Nested VLOOKUP, we're trying to come up with the regional tax rate for each of the entries here. The data off to the left, presumably each one is for a different person. We're trying to come up with this regional tax rate based on the state where the person resides. Sometimes we need to use VLOOKUP twice, and a VLOOKUP within a VLOOKUP, a nested VLOOKUP, is even going to make some sense, as it will here. What we need to do first of all, as we look at the 2 tables off to the right, is recognize that the tax rates come out of a table identified by regions and number of dependents. In the first example, looking at the data off to the left here, we've got somebody who lives in Florida. And so we have to find out which region Florida is in. You can see by the list in columns J and K that Florida is in SE, the Southeast region. Once we find that it's Southeast, then we can use Southeast to look up data in the table in columns M through U over here to find out, based on the number of dependents also, what that rate is. So we begin by using a VLOOKUP here to look up Florida, comma, in the list that's in columns J and K. And once again, using the entire column reference will make sense here, comma. The answers will come out of the 2nd column, that's 2, comma, and this needs to be an exact match. We've got to find Florida exactly. So we'll either type in 0 or false, makes no difference. And for the moment, we will have the identification for Florida its region is SE. But now we want to use that as a way to look up information in the table off to the right. Think of that as the first component of another VLOOKUP, the first argument. The outer VLOOKUP begins with this data right here. Now remember, this is equal to SE. We're looking up SE in effect. Remember, think of this as being SE. That's what we just found. We're going to say, by way of VLOOKUP, take SE, comma, and look it up in the table to the right. That's in columns M through U, right over there, comma. Which column of that table is going to have our answer? Off to the left in our data here, and I'll scroll leftward, we see the number of dependents. It's 3. If you look in the table here, if it's 3 dependents, it's the 4th column. If it's 4 dependents, it's the 5th column, and so on. So we need to take the number of dependents here plus 1. And that's going to give us the column that has the answer here. Now, when we're looking up here, remember this is SE. We've got to find SE exactly. That's got to be an exact match. So in the outer VLOOKUP, here's the value we're looking up right here. Here's the location of the table. Here's the column of the table that's going to have the answer. And because we want this to be an exact match also, we put in a comma and then 0 or false as needed, and a final parentheses because we've got multiple parentheses here. Now looking ahead here, as we're looking at this, Florida, 3 dependents. Remember, Florida's in the southeast region. As we look at the table to the right, it's going to be in row 3 here. We should be coming up with an answer here of 0.6%. And as we press enter, that's the answer we get. So it is working properly, and we should be able to double click and copy this down the column. Because all the table references here are column references, we don't have to worry about absolute addresses. So we'll simply double click from the corner to get a series of other answers. So checking out another one here, here's Washington. Or let's pick one that's higher in the alphabet so we don't have to scroll. Well, here's Delaware right here. We can see in our list that it's in the MA, presumably Middle Atlantic region. So Middle Atlantic region with 2 dependents. We look at our list over here to the right. That should be a 1.1%, and that's what it is. So you can see at different times how sometimes, just like with if functions, you sometimes need to use VLOOKUP functions in a nested way. A VLOOKUP function within a VLOOKUP function. Sometimes you need to look up information simply to know if it exists. And so we don't always need a VLOOKUP or an HLOOKUP to come up with data from nearby locations. Let's imagine that this Social Security number that we see in cell C2 on this worksheet called Match, maybe this is in a different worksheet, different workbook. We're trying to see if the Social Security number exists in column A. I think you can see clearly that it does. It's right here. But imagine that this is located elsewhere, and we might have a whole series of numbers that we're trying to match up here. The function we're about to use is called match. And here's the value we're looking up, comma. The location of the data that we're looking through is in column A in this example, so we'll just click column A. There's nothing else in column A except the label and a bunch of different numbers there. Comma. And notice the entries that we see here. If we want an exact match, we'll use 0. Now, in certain other kinds of data, but certainly not this kind of data, sometimes it's more appropriate to find less than, and you can see here, find the largest value that's less than or equal to a lookup value. The array must be placed in ascending order. Another situation could be greater than, that's a -1, finds the smallest value that's greater than or equal to a lookup value. The lookup array must be placed in descending order. So in different kinds of other situations, those are appropriate. But if we're trying to find an exact match, we choose 0. And you can type it, of course, or tab it in either way. And then when we complete the entry, if this is found, in other words, if we get an exact match, it tells us the location. Doesn't give us any other information. If there's information in adjacent columns, we really can't do anything with that by way of match. This simply confirms by giving us a value as an answer. It tells us where it's found in this location. It's in the 7th position of column A. Sure enough, it's right here. If we somehow had used exact cell references, in other words, if we had done this, our answer would be 6 because it's within the 6th position of those entries right there. We get that answer. So the previous example probably is easier to set up. And once again, using an entire column reference makes good sense here. If you wanted to have an answer here that says if it's found, then it's found or it's not found, we could simply make an alteration here using other functions to say, for example, if error, in other words, if this comes up with an error and doesn't find our answer, comma, what is it that we want to do? If that is an error, then maybe we want to say, double quote, not found. This is certainly one approach. And what happens if we do find it? It'll simply come up with a number, like the number 7 that we saw here. So for the moment, that hasn't changed, but if this is a different number, and I'll just change one character in it here, change that to a 4, that's the kind of answer we'll get. So you could imagine using other functions along with match, possibly giving you answers in a clear way. But the main purpose of match, many times, certainly not always, but many times, as we saw it in its previous state, was simply to see if we have a match or not. In both of these cases here too, the formatting for Social Security numbers, do beware of the fact that this looks like here, like they're hyphens, but in the formula bar, if you double click here, this is one of those special kinds of formatting that exists strictly for Social Security numbers. The hyphens are in the format, not in the content. And so whenever you are comparing Social Security numbers, make sure that the item that you're comparing and the table that has the comparison list has the same formatting. And the example over in column A, both of these have the same format, the column A entries and these here. And that's important when you're comparing certain kinds of entries. Phone numbers are another situation. When you're comparing phone numbers, sometimes they don't match up when you know they should. Possibly you're using different formatting there. And as a quick reminder, if you do have Social Security numbers, take out the actual hyphens that might be there, right-click the entries in question, go right into Format Cells, and choose Social Security number right here, the format that displays the hyphens for those entries. So we can see here how match could be used by itself or possibly in combination with the if error function to let us know if we actually found data elsewhere. In this worksheet called Index, we've got a table over in columns B through J that represent costs for packages based on their size and the shipping zone that they're being sent to. And in column S, we're trying to look up the shipping cost for various items based on their size in column Q and their shipping zone in column R. And we could do this probably with a combination of VLOOKUPs and HLOOKUPs, but it's going to be much more direct if we use a function called index, which allows us to pull information out of a table based on a row and column reference. Recognize here that the size 5, as we're looking at this first entry, will actually come out of the 5th row of this table, and the shipping zone will come out of the 4th column of the table. And so these are the actual numbers that we will be using as we create this index function. Equal index begins with the location of the table, and we don't use the headings in the table, we just use these cells right here, comma. Any function that uses row and column references always uses the row reference first. So the row reference, as we look at the table, relates to size. So we get our entry from Q2 right here. So we'll be looking at the 5th row of the table, which is actually the 7th row in the worksheet, comma. The column reference from that table is going to be the 4th column because the shipping zone is 4 right here. There it is. So we're expecting an answer as we look at the table over there. It's in the 5th row of the table, 4th column. Answer should be 3149. And it is. And as we copy these down the column, what do we have to first worry about? The reference here to the actual table needs to be absolute. So we select this data, press F4. An alternate, of course, is to give it a range name. So as we check out a few of these, we see how these are working as well. Here's an example here, size 2, shipping zone 2. We look at the table over to the left, row 4, column D, 1469. That's the answer that we're seeing right here. The range name will make it look slightly cleaner, so a quick change there possibly. We highlight the table here, and maybe we'll just give it a name. As we click the drop arrow here, we'll call it rate table. Then we can use this in the reference, and perhaps that's slightly cleaner looking, easier to use, and a bit more relevant here. Remember, we can press F3, add the name that way, click OK. Complete the entry and recopy it. Still getting the same answers, of course. So the index function allows us to pull data out of a table based on a row and column reference, respectively. In this worksheet called Index Match, we're going to show you how you sometimes need to use match and index together to come up with answers. We could imagine this table on a different worksheet, maybe even a different workbook. What we'd like to be able to do here is type in any month here or any product here based on the ones that are available, and then come up with an answer as to how many of those items were sold for that particular combination of a month and a particular item. We can begin by focusing first of all on the month. In the example here, we've got March set up as the month, CD drives as the item in question. And you can see both of those respectively in column E and in row 1. So we can build this slowly or possibly come together ultimately in a single formula using match and index. First of all, let's figure out which month is going to be appropriate here. We want to use this later to come up with the appropriate row number. So there's March there, and of course it could be any of the 11 other months. We'll use the match function here to match whatever that entry is, in this case it's March, comma, with the entries that we see here. And let's say that we also might want to use total from time to time, so we'll include it as well too. So actually 13 possible entries, comma, and we want that to be an exact match. So what will we learn from this? The relative location of March within the list. And of course, that should be 3. Once we put our 0 in place here and press enter. So it's 3. Now with products, we want to be looking across the top here. And here too, we want to be using the match function. This time we're gathering the data from cell B2, right there, comma, and the range that contains the different entries of that type are from F1 over to J1. And here too, we're looking for an exact match. 0 and enter. So that's in the second column. So what we've identified here are 2 numbers that we're ready to now use in the index function. Remember, index allows us to pull data out of a table. So we've got a table consisting of data here, all these yellow cells, comma. And if we want to pull data out of the third row, that's our month offset right here. We'll use this cell reference, comma, and the appropriate column, which is the second column out of that list, comes from right here. Looking ahead here before we actually see the answer, if we were looking at March CD drives, then we should be expecting to see the number 3358 as we press enter. And we do, it's right there. Now, as I press Control tilde here to display all worksheet formulas, recognize that we could have built as a single formula an index function that pulls together the 2 different matches. Let me press Control tilde again. So we can set that up relatively easily here simply by taking this data here in the sales entry, copying all this except for the equal. So highlight this, press Control C, escape, go into cell B8, and for the moment here we'll type equal, Control V to paste that in. For the moment, we haven't done anything additional, but now we want to plug in the entries from B4 and B5. So we'll first press enter, go back to cell B4, pick up this data right here, not the equal sign, but everything else. Highlight this, press Control C and escape, come back to our formula in B8 and put it in right here in place of B4. Highlight this, press Control V. So the function is definitely going to be longer, and it isn't always necessarily better to have a function like this put together into a single formula, but seeing it like this sometimes has merit as well. We haven't taken care of the B5 yet, so let's go to cell B5, double click, and highlight that data right there. Press Control C to copy and escape, then come to our single formula entry in B8, and now plug in the B5 entry right here, based on what we had just copied there. So now a Control V to paste. So this pulls together the 2 uses of match along with index to come up with the answer there. So a little bit involved, and I'm not necessarily saying a single formula answer is the best way to do this. Maybe building it in pieces is going to work better. Now you can enhance this even further by providing drop-down lists in cell B1 and B2. And you can do that by way of data validation. And in a later movie in this course, you'll see how to do that. That's probably a bit much for the example here. And do imagine these situations possibly where the table information is on a different worksheet. But there's no question that sometimes using the index and the match functions together will make sense. Another example could be out here in columns M and N, where we've got, for example, in column P, the social security number, and we're trying to look up the name. Now, right away, a lot of us would say, well, why don't we just move the name to the left of the social security column? You certainly could do that in a lot of cases, but what if what we're looking up is in one location? This is in a different worksheet, and there are a lot of formulas working off of it already, and you just don't have the luxury of changing the layout. How could we find someone's name here? We begin by using the match function to find the relative location of that social security number. For the moment, we're looking at this value, comma, in column M, and we're looking for an exact match, comma 0. We press enter. It tells us it's in the 7th position. Now that's going to be handy when we use the index function, because when we're using index, let's say we're only looking at column N, comma, and we're trying to get data out of which row? The row that we just got out of here, row 7. Click it there. Now, if the index function is looking at a table that's only in a single column, we don't need to provide a column reference. It's automatic. Who is associated with that social security number, that 560? It's going to be Quinn Collins, and there it is. So here we're using index and the result of a match, and here too, it might be appropriate. Go back to the use of match right here, copy this data, Control C and escape, plug it into the index, and in the example here, we'll use it for Q2, Control V to paste. So this function by itself, the index that's looking up data in column N, based on our example of getting the row number by way of the match function, gives us the answer we want. So ultimately, we wouldn't need this anymore. We've simply got this here. So we can look up, in effect, it's like using a VLOOKUP, but looking leftward in the example. And it's for those cases where we don't have the luxury or the possibility or maybe the time to restructure the source data. But using match and index together, quite common occurrence as we work with Excel functions. If you're trying to tabulate data, particularly from large lists, you want to take advantage of a family of functions called COUNTIF, SUMIF, and AVERAGEIF. In this worksheet, we might want to know how many full-time people work here. We could do this by way of a pivot table or possibly a more complex formula, but COUNTIF works quickly and easily. Equal COUNTIF. I'm using this in cell K2, and we're looking in column D for these entries, comma. And what are we looking for? Full-time. Now, if we don't have this in a nearby cell, I do in cell L2, but if we don't, we would type double quote, full, space, time, double quote, press enter, we get an answer. Since it's in a nearby cell, we'll just refer to that. Enter, we have our answer. And we can double click here to copy this down into the next 3 cells as well too. So in all cases here, we have a count of how many hourly people we have, how many contract people, half-time and full-time, quickly and easily. Occasionally, you might want to use this feature with wildcards. It would be probably unlikely you would want to total the full-time and half-time people. You could see what that total is right there. It's 489. But if we were doing this in an isolated case, we could type equal COUNTIF, left parenthesis. We'd be looking in column D, comma, and then double quote asterisk time. Asterisk is a wildcard, meaning any number of characters preceding the word time, and then a double quote, and there's our total, 489. By highlighting these 2 cells, we see the total at the bottom, that's 489. So in effect, we're doing the same kind of thing here, but in a different way. A similar use might be, we're looking at our list over there, we're just kind of curious. How many of these entries contain the letters TIM, like in Timothy here, and maybe there's some Tims, we've got a few Timothys perhaps popping up. How many of those do we have? In that case, Tim is preceded by text, it's also followed by text. So in this example here, if we're doing a quick COUNTIF, we're looking in column A, comma, and then within double quotes, it's asterisk, TIM, asterisk, double quote, and then we're done. There are 9 of them. And we can verify that with a quick use of filter. Just clicking within the data, use a filter, and then jumping into column A, simply in the search panel here, type TIM and press enter. And there's our list of all the Tims. There's actually one single Tim and a lot of Timothys. but we've got 9 entries there, and that's exactly what we found in our previous example. So getting rid of the filter, going back to normal here, and viewing this once again. The asterisk on either side means Tim preceded by and or followed by any number of different characters. So you can also use this function in a more expansive way using wildcard type symbols. Now, the companion to COUNTIF is called SUMIF. The idea with SUMIF is we might start off in the same way. In other words, we're looking for people who are full-time. But SUMIF has an additional argument, a third argument that allows us to say, in effect, once we've found the full-time people, comma, let's go get their salaries and add them. In other words, what are we spending on salaries for full-time people? We're looking in column D to see how many of those entries are full-time. It comes out of cell L2 here. And when we do find an entry that's full-time, we go to column H, take that value, let's add up the full-time salaries. There they are, and we'll simply double-click to copy it down there. There are the salaries. We look at the bottom of the screen in the status bar, 41,653,876, and we should see the same number if we click column H. And there it is, identical. Keep in mind the status bar will vary if you right-click it and possibly check or uncheck some of the options found in this section here. I tend to leave them all checked. I don't always need them all, but anytime you highlight 2 or more cells, and that includes if you highlight a column, you will get totals at the bottom, and it's real handy at times to do cross-verification. So, getting back to SUMIF. For years, in prior versions, there was a SUMIF, there was a COUNTIF, but no average-if. And a lot of users kept saying, give us average-if. Finally, they have. If you don't have an average-if, you've got to take SUMIF and divide it by COUNTIF. But it certainly is a lot more straightforward here to say, in effect, let's get the average of salaries for full-time people. And there it is. And here too, double-clicking will get the average salary for our other kinds of entries as well. And so the example here in column K, right here, average if, remember cell L2 has the text full-time. If the entry in column D is full-time, then let's go to column H, and what are we going to do? Average all of those salaries. So we can see how COUNTIF, SUMIF, and average-if give us easy ways to tabulate data from lists like this without having to sort the data or rearrange it in any way. Although the SUMIF, COUNTIF, and average-if functions give us a lot of capability in tabulating information, they don't allow us to use multiple criteria, and sometimes that's what we want. For example, we might want to know the average salary of the full-time people who have a job rating of 5, or maybe we want to know the average job rating of those people who have been here more than so many years. Or we might want to know the average salary of those people who have been here so many years and have a job rating. In other words, using multiple criteria from different aspects of the data in a list like this. So the 3 functions in question that we will be using all end in the letter S, and they correspond with the other 3 functions. So we're about to talk about COUNTIFs, SUMIFs, and average-ifs. Let's start with the idea here that we might want to tabulate data regarding full-time employees and those who have job ratings. I'm going to put these in column K, and to make it a bit simpler, I've got lined up in column L some of the criteria that we're going to use. Not all of them, but some of them. So let's start with the idea of counting how many people in our list here are full-time who have a job rating of 5. Equal, COUNTIFs. Now, the pop-up below this shows criteria range 1, and we can't see the rest of it. But think of these as happening in pairs. The first pair is the combination of these 2 locations. The status, right here, comma, and the fact that it's full-time. Now, we could type double quote full-time, double quote, or since it is over in cell L2, that makes it a little easier, we'll just click there. So that's one criteria pair, comma. We might have another. And we can have up to 31 of these, so quite a few. The next criteria pair will be job rating. That's in column I, comma, and we're looking for those that have a 5 in there. That's a numeric entry, so you don't have to put it in quotes. So how many full-time people have a job rating of 5? 102 of them. And we could possibly imagine having a list of those that have a job rating of 4 and 3 and 2 and so on. But in the example here, we're simply looking for 2 sets of criteria together. When this is true, in other words, when the entry is full-time And when the job performance, the job rating is 5, let's keep account of only those situations where both are true. Now we could add a third argument here, those who have been here so many years, comma, I'll click column F, comma, and if we want to say greater than 9 or greater than 10, something like that, we use double quote, and I'll use greater than 9, double quote. So a third criteria set. Think of these as pairs. The first pair is about the status being full-time. The second pair is the job rating being 5. The third pair is the years of service being greater than 9. So we press enter, and we've got 32 people. Remember, our previous answer, as I press Control Z, was 102. Pressing Control Y, reverse order here. And once again, displaying the function, we see count ifs used with multiple criteria. We might want to perform something similar using sum ifs. We might want to tabulate the salaries. But if we change this to sum, watch the pop-up tip below this change also. Sum ifs begins with the range that we're trying to tabulate. So if we're trying to tabulate salaries here, we would first put in the entry for column H, comma, then we've got our criteria pair. Here's a pair right here, and I'm essentially using the same ones that I'd used with the count ifs, now with sum ifs, but we tabulate the totals. We're going to be adding the salaries from column H based on this criteria set being true, this being true, and this being true. Enter. And if we wanted to do that for the others right here, we'll simply double click, copy downward to see what those are. And a quick format there off the home tab would probably be appropriate too, a comma and hide the decimals. So we see what's happening there too. So sum ifs, unlike count ifs, begins with what we're trying to tabulate. And average ifs follows this same basic structure. What's the average salary? Followed by ifs, average ifs, so we're getting the salary out of column H for these three criteria pairs. In other words, once again, we're looking at status is full-time, job rating is 5, and years of service greater than 9. And as we complete these, we have another answer here. These are the average salaries. And again, double click if we want to copy the others here as well. So these are quite powerful, and we can have up to 31 pairs here. And we've only used 3 in these examples here, but it gives us much more power in tabulating information like this. We see an average ifs here, and this was preceded by a sum ifs and a count ifs. They allow multiple criteria when working with database type lists to come up with totals. A common statistical measure is called a median. It's the middle value in a range of values. If we click column G here for the salary column, we do see in the status bar at the bottom of the screen an average, account, perhaps some others as well. Keep in mind that you can change what's being displayed here if you right-click and then consider checking or unchecking the boxes in this area right here. And if we wanted to write a formula, we could certainly do that as well to reinforce this. But median isn't found there. Recognize also, if you go to the auto sum button, click the drop arrow, we don't see it there either. And yet, some people need this frequently. And I often use this with data to compare with an average. So let's simply type equal median. And because we're concerned with the data in column G and nothing is there but salaries, we can simply click column G and quickly get an answer. That's the median. Now what's happening behind the scenes, and we don't need to see it happening, is that all the salary values in column G are sorted, and the middle one is our answer. Now, if there's an even number of them here, the 2 middle values are then averaged, and that's how we get our median. It's valuable at times to compare it with an average because sometimes an average is skewed by the fact that you've got an extremely high number or low number that pulls it one way or the other. So not that we necessarily need to use it here, but if we did, we could simply click the drop arrow next to auto sum, choose average, click column G, and possibly contrast the two. Sometimes we've got numbers across a range of months and locations. For example, here, simple median here, same general idea, equal median, left parenthesis, highlight the data in question, and enter. And so we have our median there too. We don't always have to contrast it with average. Now, another function, not exactly related to these two, but it comes into play commonly when we're talking about basic statistical measures. It's called mode, and it simply tells us which value occurs most often within a given range. What's our most common job rating? Equal mode, Left parenthesis, we'll simply click column H. There it is. 5 is the most common rating. Now that may or may not be a fair assessment of the data, but it gives us some information. What's the most common number of dependents that our staff has here? We've got quite a few people here. So we could simply take this and redirect it. Instead of column H, we'll just click on column C. The most common number of dependents based on our employee list here is 2. So valuable functions to be sure, median perhaps a lot more important for most people than mode, but nevertheless, these are functions that are easy to get to and are frequently used in Excel worksheets. In this worksheet called Rank, we've got a list of employees in column A and their salaries in column B, and we want to know how the salaries rank compared with the others. And we can certainly do this by sorting the data and then simply putting in a number there and copying it down the column. But we don't want to sort the data. And furthermore, the salaries will change from time to time. We want this to always be accurate. And so we're going to use a function called rank. But like a number of functions in Excel, we also have a new capability. And we'll see this as soon as we start to type the word rank right here. As we're typing already, you can see below that there are 3 functions there. And as I slide the mouse over the lower entry here, right here, rank, this function is available for compatibility with Excel 2007 and earlier, and it returns the rank of a number in a list and so on. So this is the function we need, although it seems to be saying that this is going to disappear. And eventually it will probably. Rank EQ does exactly the same thing. So we can use either one here. So I'll simply use rank, then put in the left parenthesis. Rank begins with the number that we're interested in this case B2, comma, and then the range of cells we're comparing it with. Now, there's nothing else in column B except salaries and that text entry in B1, so we can simply use column B. And as we press enter, this is the 71st highest entry. We'll double click, copy this down the column. Now, what if there's a tie? And we do have that here. Those 2 salaries will share the same ranking. Here are 2 salaries exactly the same. They share the second rank. Now you won't find any 3 in this list. There's 1 right there. Later we'll see a 4, there's a 6, but there's no 3 here. And so you could say that these 2 cells occupy the second and third positions. So they share the same ranking. Let's do something similar with a different set of data over in column H. Let me zoom in a bit so we can see it better. As we start to type rank, this time use rank EQ. Now it will give us the same answer as if we were using rank. Tab it into place here. We want to point out its contrast with rank average. So here too, we're comparing an entry. It's in G2, comma, with all the entries in column G. Click there, we get an answer, just as if we had used rank. We'll copy this down the column. Now let's contrast this with rank average. Once again, as we start to type this, we see it right away. As soon as you see it, by the way, you can click it and tab it into place if you wish. There it is. And again, we'll be comparing that entry in G2, comma, with all of the entries in column G. And the first answer we get, no surprises. But as we double click here and look at the others, there's some big surprises. Let me zoom back a little bit too, and look at some of these that share the same ranking. And that's where things are different. Here's a 9 here, there's a 9. And that's what happens when we use rank or rank EQ. Over here, we've got 9.5, and down here, we've got 9.5. So what are we saying here? One way to describe this is that we've got 2 values that share the 9th position, or a different way of saying it, they share the 9th and 10th positions. Now, the average of those 2 is 9.5. In other words, they add up to 19 divided by 2. We've got 9.5. Now, I think most people, most of the time, don't need to know that information. I think rank or rank EQ will work just fine. And we'll bring this out a little bit more clearly simply by sorting the data. I'm going to sort this in descending order. We don't need to do this, but I think it'll clarify it a bit more. Now we get perhaps a better handle on what's going on here. And so here are 2 16s. They share the second rank using rank or rank EQ, but under rank average, remember they are the second and third positions. That adds up to 5. Therefore, we get 2 2.5s. And here we've got a situation, 3 of them have 11. And so the average of those, imagine they occupy the 11th, 12th, and 13th positions. So what is the average of those 3 numbers? 12. That's why we get the 3 12s. Now, with some analyses of data, sometimes knowing these differences is important. I think for most people, the simple use of rank or rank EQ will work just fine. If you need to extract the largest value from a list or the smallest value from a list, both of those are fairly straightforward using the two functions max and min. And to make it even simpler, we can use either from the Formulas tab, the drop arrow associated with AutoSum, or on the Home tab. Just click the drop arrow, and if you want to get the maximum value, simply choose max. And in the example here, if we're looking for salaries, we'll simply redirect this by clicking column F to come up with the highest salary. And similarly with lowest, same general idea, use the drop arrow. There's min, and then we could click column F and find the minimum salary in this list. Fairly straightforward in both cases. But sometimes you need to know the second highest salary. Certainly one way to get there would be to sort the data, but there is a function called large. Large simply says, I'm looking at some data, for example, in column F, comma, and I want to know the second highest entry, or the third, or the fourth, or the fifth. Any number you want there. Type it in, or if it's nearby, and I put the numbers here in column J ahead of time, I'll simply refer to that location. So this will give us the second highest salary. And simply because we are using an entire column reference, we can simply double click to copy this down here and then get the second, third, fourth, and fifth if that's what we need. And similarly with lowest, and you can almost guess the name of the function. If it's large, to find the second, third, and fourth, etc., largest number, then it's going to be equal small. So if we're looking for the second smallest entry, then here too, we would click column F, comma, and I could either type in a 2, but since it's to the right, I'll simply use the value that's over there, and we'll put in the second smallest entry, and then double clicking will get the others as well. So large and small, occasionally handy. For years, I never saw them, didn't know they existed, and then one day needed them, and they came in really handy. Can't say I've used them a whole lot since, but it gives us one more tool and one quick way to get a hold of data. We don't have to sort the data as we use these functions, so they're very valuable in certain contexts. In this list of employees here, we've got a column G where there are some blank cells. Not everybody has benefits, and we might want to know how many do not. And that would mean counting the number of blank cells here. And there's a function for that, equal count blank. As you're typing longer function names, by the way, as soon as you see it in the list here, you can click it and then tab it into place if you wish. So we're looking in column G to count the blank cells. And as I complete the entry here, we see that that's obviously not right. We're looking in the entire column there. And that's why we get such a large number. Remember, there are well over 1 million rows in Excel. So that's not very helpful. And what we need to do here for this to be accurate, at least for the moment, is to select these cells right here in column G down to the bottom of our list, right there. And as we complete the entry, we will have an answer, and it will make sense. It's 28. There are 28 people who do not have benefits in this list. We could actually come up with a different way of calculating this. We also want to show you how, if this list is a table, it's likely to be more direct. Here's a bit of information that at first may not seem that useful. If this list grows and shrinks, our total here is going to have to be readjusted. Our formula has to be different because we'll have a different number of rows. If we count the number of entries in column A, let's say we will always have entries in column A for every new row. We can do that simply now with equal count A. And A, of course, doesn't necessarily mean column A. It does in this case, but we can do this for any column. Count A, how many cells have data? Count A is sometimes described as, let's do a count of the cells that are not empty. So there's 100 of them. Okay, that's a valuable bit of information. How many cells do we actually have in a column? We can do that with equal count blank. Once again, we'll tab it into place. And let's just focus on an empty column like column J. That's the total number of cells. So we can put this together in the appropriate way simply by writing a formula. Let's begin with this equal count A. Now we could type the count A, but why don't I just use this already? It's right there. Minus, and then we want to put in the calculation of the total number of cells, that's right here, and then subtract the number of blank cells that we get in column G. Another count blank. And as we press enter here, it's not quite there. Now, all we really need to do here is put in parentheses correctly, and we should have a correct answer. In other words here, and that of course reverses the calculation. And there's our answer of 28. So I think you could say that wasn't exactly as straightforward as we might want it to be, but it is dynamic. And if this list grows or shrinks, we will always have a correct answer with that combination there. A more direct way could be if we wish to change this data into a table. Not everybody is familiar with this concept. It was introduced in Excel 2007. If you convert data to a table, it has some very obvious visual advantages, and it also has some formula advantages, as we'll see here. So we'll click with inside the data. We can either press Control L, think of L for list, or Control T, T for table. You can get to this on the Home tab by way of the Format as Table option, or Insert tab, there's Table as well. Click OK, it's now a table. When you get a table, you also get field names automatically. And this time we'll start with count blank again, tab it into place, and now, somewhat differently than before, I'm going to be typing T for table. When you create a table, if you don't give it a special name, it's going to have a name like Table 1, Table 2, etc. And when I type T right here, we see in the list, there's Table 1, the only table we've got in this workbook. So we can click that and tab it into place. Now, tables have field names, and they are delineated by brackets. So I'll type left bracket, and look what we see. The different field names here. I'm interested in the benefits column right there. Tab it into place. A right bracket, and simply press enter here, and we've got an answer. Much more direct than what we saw before. This doesn't mean that you always want to work with the table concept, but it does point out an additional benefit of it. This is a much simpler, direct, more readable, and more understandable formula than the earlier one that we saw. Keep in mind count blank can be used in a variety of other situations. In the list over here in columns M through R, we're simply showing how many sales were made on any given day by our various salespersons. Imagine they sell large equipment, so they don't sell a whole lot on any given day. We want to know how many days there were no sales for the employees here. And not one by one, although we could do it that way. We just want to simply know how many person no sale days were there. Equal count blank. Once again, tab it into place possibly, select this data, and we quickly get a count of the blank cells. If you wanted to do this for each person, of course, possibly move this up here for the moment, we could of course then do equal count blank and then do it for each person. Simply highlighting this data here, press Control Enter, double click the corner, and do it per person as well. So you can see there are any number of different situations where count blank is ideal for counting blank cells. It does exactly what it says it's going to do. And we saw in an earlier example how valuable it could be for a different kind of list and how potentially valuable using table data might be with this function. There's a function called count and also a companion function called count A, and both are valuable, but there can be some confusion that arises when we contrast that with what we see in the status bar. For example, if we click column D here, the information at the bottom of the screen, which might include all or some of these, and remember, you can right-click here and adjust which of these statistical measures appear, we see a count of 93, and that means there are 93 entries in column D that contain text of any kind. You'll also see the entry here, numerical count 92, meaning 92 of the cells have numbers. And so the top entry, of course, is the difference of 1. And we see that when we click column D, we see those two entries. So we get used to the idea here that count means what? Counting cells that have data. And so if we were about to use a function and we did a quick look at our list of functions, we might go to the Formulas tab, maybe go to Math and Trig. Where do we find these? Count and COUNTIF, it's not there. Where is it likely to be? We've got some other functions out here, more functions. How about statistical? And there we've got a count, counts the number of cells in a range that contain numbers. Count A counts the number of cells in a range that are not empty. Different way of saying it. If we didn't know any better, we'd say, well, let's do a count. How many entries in column D, or a different way of saying it, how many of our people had sales over the last 14 days? Let's do a count. Count here means count numbers. So if we click column D and press enter, 92 of these have numbers. Now, if we select column D and we see count at the bottom, the 93 there means count the number of cells that have data. That's where the confusion might arise. I think if you try to not make it confusing, and I'm trying not to, when we use count this way, it's counting cells that have values in them, numerical entries. And if we use count A, that's the same as saying how many of the cells here are not empty, or a different way of saying it, how many of the cells have any content whatsoever. So count and count A both have a role to play, and depending upon the kind of data we're looking at here, they're valuable in tabulating information. Recognize something else here. If this data is centered, and I wouldn't say that's a good idea, although it's not horrible in this example, but if the data were centered, and if somewhere in the list here, and let's actually do this, notice that with values, you can't center them unless you use, for example, a format like general format. It does allow you to center them. I just press Control-Shift-tilde to get there. So this is general format. What if one of these in here was an L, which looks like a 1, unless you have other 1s around. Now, if you see another 1 out here, you recognize the difference for sure. But now recognize what we've done here. And occasionally you might use the count function to find oddities like what we've seen here. This is truly accurate. It's saying that 91 cells have values in them. And of course, that is not a value. That's the letter L. You run into the same issue with a capital I too. Capital I looks just like a lowercase l. And normally you don't see those, of course, in numerical columns, but you might occasionally. Again, using the count function to count values, using count A to count the number of cells that have entries, or those that are not blank, are both valuable, but recognize that when we are using the status bar, we have to think that count means something a little different there. Take that into account, pardon the pun, in using these capabilities. Excel has any number of different rounding functions, and it's really important to use them in situations where you're coming up with answers where it's important to have your answers accurate to the penny. In this worksheet, we've got a formula in cell E2, and it's showing an increase on the price that's in cell D2. And eventually, all the entries in column E that we're going to put in are going to be based on a 2.34% increase. That's in cell G1. So the formula is all set up, and it's giving us an answer of $9. A simple test of this might reveal something a little different. Suppose somebody orders 10,000 of these items, or is about to. We're going to write a formula here, equal 10,000 times this 9. And of course, our answer is going to be 90,000, except that it isn't. In fact, we're $43.14 short here. Is that 10,000? Well, you can look in the formula bar. It surely is. Is this $9? Can't really tell by looking in the formula bar. But on the Home tab, in the number group of the ribbon, let's click the button for Increase Decimal. Now, as I do this, watch cell E2, and also keep an eye on F2. Cell F2 is not changing. So when we increase the decimals here, all we're doing is showing more decimals. We're not changing the value at all. And whether we increase or decrease, we are not changing the value. And it's a common mistake with Excel novices to somehow assume that using these buttons changes values. It doesn't, not at all. So we've got a bit of a problem on our hands. Now, in a different context with real simple numbers, the problem jumps out immediately. We've got data over in column A with the total below it right here. And right now it makes perfect sense. 4.6, 5 different times adds up to 23. What if we displayed these with no decimals? I'm going to use the button here for decreasing decimals. It's pretty obvious we wouldn't accept this. Those are 5 5s, aren't they? Why does it add up to 23? Well, they aren't really 5s, and we can click here, look in the formula bar. These are 4.6s. Changing the display of the decimals does not change the content. Those are 4.6s no matter what. So the issue here then is that we need to change this calculation so that we truly round it to the nearest penny. There are other ways to round as well too. We'll use the round function, left parenthesis. Round is based on decimal places. Comma 2 means round this to the nearest 2 decimal places to the right of the decimal, therefore meaning pennies. Now, as I click enter here, watch the formula in cell F2 react immediately to our $9 price. And there it is. Now we've truly changed this to be $9. And we're not going to keep our display looking this way. We'll simply decrease the display of the decimals, and that's the way to say it too. Now, similarly, we've got data over in column K for salaries. We want to calculate new salary in the same kind of way that we did these price increases. We'll give you a couple of other perspectives on how you might do this. This time we'll start with our basic formula of the existing salary times this percent, and because we're going to be copying it, we use the function key F4, make that an absolute address, and then plus the K2, existing salary. And there's an answer. Now, with yearly salaries, we could certainly keep the pennies, but is that accurate as we see it? Once again, we might increase the decimals. It's not, and we see finally what's happening here. It's not uncommon to see yearly salaries expressed as whole numbers. So what I'm going to do here is use round, this time slightly differently than before. Let's round these to the nearest whole dollar. And that's not 2 decimal places, it's 0 decimal places. So we'll be rounding these to the nearest dollar. And regardless of how many displays here we have decimal-wise, we have an answer here. And we'll just drag this down a few cells just to check it out. So all these are now to the nearest whole dollar, and we might leave it that way. However, it's also not uncommon to see yearly salaries as multiples of 100. I've seen that from time to time. I don't know how widespread it is, but what if we wanted to change our calculation and make sure that we round our new salaries to the nearest $100? Instead of 0 here, we use -2, and I'll press Control-Enter for just the first one here. Remember, that was 36,444. And if we drag this down into the next cell, it's going to go down to 68,000. Next one down, 78,300, and so on. Where's the next one going to go? We don't see the raw number underneath, so we don't necessarily know it went up here. Next one's going to go up to 500, and so on. We have the possibility of saying we want this to go up to the next 100 no matter what. And so a variation on round is a function called round up. So as I press F2 here to edit, I'll use round up. Now this is going to take us upward to the next 100, even if we're $99.99 away. So as we make a change here, remember this had been 36,444. We had taken it down to 36,400. Now by using round up, we're going to the next 100 upward. So sometimes you want to use that function. And round down, of course, the opposite of it. All we need to think of here is what we do with our ages. If you are 39 years and 11 months old, well, you're 39. But we could certainly use that here as well, too. So 3 different functions, round being the most important, ways to make sure that the calculations that we create truly are accurate. And many times when we use these functions, we want to emphasize the display of the decimals and eventually decrease to get these in a more sensible display. So no question, round, round up, and round down, valuable functions for controlling our data. When you use the round function, typically you're dealing with rounding numbers based on decimal placement. For example, in this worksheet called Specialized Rounding, in column C, we've got formulas, and in C2, we see the formula here that's rounding a calculation to the nearest 2 decimal places. In other words, to the nearest penny. Now, we also could round this if we wanted to the nearest dollar. We probably wouldn't do that with pricing items like the ones in column B, but we could do that. But the numbers that we use here in the final portion of the round function relate to the number of decimal places. What if we wanted to round this to a multiple or a different number not related to decimals? What if we wanted to round all of our prices to the nearest nickel, for example? We can't just plug in a 0.05 there. We need to use a different function called mRound. We now want to round this to the nearest 5 cents, the nearest nickel, you might say, 0.05. Now, the example in our first case here, since the price was $9, it's going to stay $9. But we haven't dragged that into the next cell below. You can probably foresee or predict what's going to happen here. If we use mRound the way it's used here, to round our calculation to the nearest nickel, then as we drag this into the next cell, you can be sure it's going to be 3.25. And the next one down, 4.25. The next one's going to stay at 7.95. And the next one after this would be 6.45, and so on. And so you can try these one by one or just take out a few of them to see what's happening here. In some cases, what you want to do is to make sure that these go up no matter what. Now, in all cases here, we're providing an increase, but as I press Control-Z slowly to move backward here, maybe in some cases here, what we might want to do is to always go up to the next nickel. And mround doesn't do that necessarily. It goes to the nearest nickel. So if we want this to go up, and if you've seen other round functions, you would probably make the guess, well, we've got round, and then there was a round up and a round down, so it's probably what? M round up and M round down. But that's not the case. The companion functions here will be ceiling and floor. You see them listed out there to the right in column F. So if we want to go up to the next 5 cents, we put in ceiling. And that stays the same here because the actual calculation comes out to be 8.999, something or other like that. So this goes up to the next nickel. But in the next case downward, that's going to go to 3.30. In the next case downward, 4.30. Next case is probably going to be the same. Now, actually, that one went up too. So that was slightly over 7.95 earlier, although we didn't actually see that amount. So the companion function for mround to go upward, in other words, override standard ruling techniques, is called ceiling. And of course, if we wanted to go downward, it would be floor. Now, as we look at the data over in column H, similar kind of setup, obviously with bigger values. And there's a formula already in place in cell H2 and doesn't have any rounding just yet. And let's imagine here that we might want to round these. So a standard way to round these would be to round these to the nearest dollar, for example. In a yearly salary, that's not uncommon. So comma 0 certainly would be one thing to do here. Now, I've seen situations, perhaps you have too, where people get paid 26 times a year, that's every 2 weeks, or maybe 24 times a year, that's twice a month. Is this evenly divisible by 26 or possibly 24? Suppose we have a biweekly pay period, you get paid every 2 weeks, and we want that amount to be a whole number. Right now, if we take this value and divide it by 26, it's not a whole number. In other words, it's got pennies there. So could we do something with our calculation here for our new salaries to make sure that they're evenly divisible by 26? Let's leave the formula there and use mround to round this to the nearest $26. In other words, multiples of 26. So instead of 0 here, we'll use 26. And when I press enter, we'll have a new calculation, a new result. And over here, we left in the formula that divides this by 26. It does come out even. So the gross pay for each pay period will be, in this case, $21.87. And here's our formula again, looking at the number that way. So how much did this really change? We're looking at 56,862. I go back with Control Z a few times. Looks like it went down about $8. So that's the difference there. And similarly, if we wanted to make sure that these are even, if there are 24 pay periods a year, we want that to be evenly divisible by 24. Simple fix here, we would simply use, in our example here, 24 here, and that, of course, would be an mround as well, too, if we go to the nearest multiple of 24. So now that's evenly divisible by 24, and here's our check on it. So I think you can see how if you need to calculate numbers and have them evenly divisible, you could be using mround. Possibly it's 2 companions, either one ceiling to always round upward no matter what, floor to always round downward no matter what. But the main point is that you can use these in a way that isn't restricted to decimal type settings. mround, ceiling, and floor. When you're working with certain kinds of data, you don't need or want to keep the values to the right of the decimal. Just drop the pennies. And although they're rounding functions, there are also 2 functions that essentially let you throw away the pennies. Simply drop them. One of the functions is called trunc. Think of the word truncate. The other one is int. Think of the word integer. And much of the time they work identically. We've got some data here in column C, and we don't really care about the pennies. We want to throw them away, in effect. And so in column D, we're using the function called trunc. There it is, pretty straightforward. Whatever's to the right of the decimal just gets thrown away. Same thing with int. It's happening right here. And all these examples here, same thing. The 2 functions are identical. A different way of describing these is to say that these functions both lower the value. They drop the pennies. But look what happens when we've got negative data. Talking about the data now in column C. Trunc does, as we might expect based on our previous examples, it simply drops everything to the right of the decimal. These are all examples of trunc right here. But look at what happens with int. Now, if we phrase this a different way, we could say int is really consistent, because if we say that this function always gives us a lower value, well, it does. In other words, if we're looking at 15.58, the next lower value downward, if we get rid of the pennies, is minus 16. That's lower than this value. Truncate actually raises the value, whereas if it's a positive number, it lowers the value. So regardless of how you think of this, do recognize that many times trunc and INT do the same. But when the numbers are negative, you get different kinds of results. And you just have to assess the situation to decide which is going to work best for you. Now, there are two other functions called odd and even, and they're not nearly as widely used, but they are being used in column H here and also in column K. And you can begin to see what happens as we expose the function here. Odd simply says, I've got a value in a different location. Give me the next odd number upward from 0. And if we've got decimals here, the next odd number moving away from 0 is 21. We see it this way. If we go below, if we're looking negative, what's the next negative number after minus 3.4? Moving away from 0, it's minus 5. And similarly with even, works in the same way. That's already even at 22. There are no decimal values to the right of it, so even simply stays the same. Here's a 19.3. The next even number moving away from 0 is 20. And we can assess the others just by looking at the answers here. So although less widely used, it's another variation on how we can control and adjust values by using functions, odd and even, and then prior to that, trunc and INT functions. If you were exploring some of Excel's many functions and you went to the Formula tab and were looking at some of the math and trig functions, your eye probably wouldn't drift toward the mod function. And if it did, you might look at its description and say, returns the remainder after a number is divided by a divisor. Why would I ever use that? Well, there are at least two situations where you might. In this current worksheet, we've got a list of our items. Say we're about to move our warehouse. We've got a number of items in stock here. And in order to move these, we have to put them in the appropriate containers that they were originally produced for. So we've got 162 items in row 2 here for this particular item number. And if we put these in boxes, the boxes that we use for this item hold 16. How many will we have left over if we put all these in the boxes? And you can probably do the math in your head for some of these. Divide this by 16, what do we get? It's going to be 10, but we'll have a remainder of 2. So we want to know for each of these items, if we put them in their appropriate containers, and all these different items here have a different storage amount, and certainly some of them are the same as each other, but we see the differences there. We'll use the mod function to, in effect, say, take this value here, comma, divide it by this, and don't give us the answer of the division, but give us the remainder. The example here, it's going to be 2. And as we do this for the rest of these, we'll simply double click. So now we have a list of how many items we will have remaining. And of course, in some cases, maybe none, because we've got just the right number here. This example, we've got 168 items in stock. The boxes hold 24 each. Well, that's times 7, so we'll have nothing left over. But we see all the other items. So all we're doing is calculating the remainder in a division. Now, another use of mod is a more creative use, perhaps, and it involves using conditional formatting. Suppose this list is going to grow, or imagine in any different worksheet that you're working with, it might be better if every 5th row were yellow, every 10th row, every 3rd row. Make your own choices there. Now, if you've turned this into a table, you will get that so-called banded look of every other row, but you might not want to use the table feature, and furthermore, you want your own color scheme, and you want it to be every 5 rows or 6 rows or something like that. Now, we could do this for the entire worksheet or just for columns A through D, doesn't make any difference. If we want to do this for the entire worksheet, we'll simply click in the upper left-hand corner, selecting the entire sheet, and then go to the Home tab and use conditional formatting. And what we use here is not one of the standard features, but a new rule, which will actually be a formula. And the new formatting rule, the rule type will be use a formula to determine which cells to format. What we're about to do in English is to say, if the row number is evenly divisible by 5, we're going to make it be, for example, yellow. So the function is equal mod. And how do we refer to the row number? There's a function called row. And if we follow it by simply an open and close parentheses, it refers to the current cell, comma 5. So for every given cell in this worksheet, as we consider it and divide its row entry by 5, when that calculation leaves us with a remainder of 0, then we want that row to be yellow. So that only happens when the row is 5, 10, 15, 20, etc. Got to be evenly divisible by 5 when there's no remainder. I'm going to highlight this, press Control-C so we can display it larger in a minute. We're going to use the format here. Any format we want, of course. I'll simply use a bright yellow here, and we could use other techniques, border techniques too, if we wanted to. But we'll simply click OK, and OK again. And there's what we see. Now the formula in place, and I'll put it up here temporarily, is what we see right there. And if we wanted to make this every 4th row, of course, we change the 5 to a 4. Every 4th row could be yellow or green or whatever it is we want it to be. As long as this is in place, and typically you wouldn't put the formula there, but that's just a reminder as to what we used. In a real-life situation, what happens if I delete a row here? I'm going to delete row 4. We don't need that data there. We don't need the row or anything in it. I'm going to delete it, and automatically the display readjusts so that every 5th row is now yellow. So the data moved up. The color was not associated with the data. It was associated with the actual row number. Throughout this entire worksheet, no matter how big or small it gets, every 5th row is yellow. And if we wanted to make a quick adjustment here and say every 4th row, fine. We'll click in the upper left corner, go back to conditional formatting, manage the rules, and here's our rule. We'll edit the rule, change the 5 there to a 4, click OK, and OK. And now every 4th row has the highlighting. We changed the 5 to a 4. And if we were doing it right here, we'd emphasize that by making that be a 4 to represent the current conditional formatting formula that's in place. So the mod function does have its uses. Earlier, we saw a day-to-day example of how you might want to calculate the number of items left over in packing. And then we saw here this conditional formatting technique, both using the mod function. The mathematical function rand, which generates a random number between 0 and 1, doesn't sound like the kind of function that a lot of us would be using. Certainly mathematicians, scientists, engineers would have use for this, but how about the rest of us? Well, here's a list of data here. Looks like it's sorted by social security number. It's about 400 records or so. Maybe from time to time we review these entries here. It's our form of quality control. We want to pull out 6 of these at random. How do we sort this list in a random order? And it could be any kind of list, of course, that you want to review from time to time. Pick the next available column to the right, equal rand. Left parenthesis is all you need to type. All rand does is generate a value between 0 and 1. And you don't necessarily have to adjust the display or anything. And by double-clicking in the lower right-hand corner, we see a series of random numbers. Now, depending on how this was formatted, possibly you're seeing random numbers like that. I just used general format on that, Control-Shift-tilde. But whether it's this display or the other one makes no difference. To make this slightly more appropriate, let's just give it a dummy heading, RR, something like that, anything. Notice how all the entries change. And every time you do a recalculation or make any change to a cell, these random numbers get regenerated. But if we base our sort simply on this data, and all we've got to do is make sure the active cell is within the column. If we've got an empty column to the right, any other data to the right of that gets ignored. We're going to sort this list quickly based on the random numbers as we now see them. So on the Data tab, we could click AZ or ZA, makes no difference, and we've ordered the list based on the random numbers. In the meantime, they all got changed. Now, we don't have to worry about the nature of random numbers, how they got generated, anything like that. As we look at this list, it is in no particular order. And because the random numbers got regenerated, we don't even have a paper trail of how it sorted them. But we don't care. Our purpose was simply to put this in a random order, and then maybe we'll copy this data here, maybe for the first 10 records or so, paste them somewhere out, review the contents, and that's it. We simply wanted to get a random list here based on this entire entry, so we added a temporary new column and used the rand function. Don't need this data anymore, we'll delete it. Now, if you work with sample data, and I tend to do that a lot, you might not necessarily have that need, but here's another example. I need to generate some random numbers here, but they all need to fall within a certain range. So I could select all these cells at once. A companion function to rand is called rand between, equal rand between, left parenthesis. I want all these numbers to fall between 110,000. And because I've selected all these cells at once, I'll simply press Control Enter, and we'll have a random number in every case here, a whole number between 100 and 10,000. That's inclusive, so possibly those two numbers could turn up in our list. And there we are. Columns get readjusted. Now remember, they are dynamic, and so, for example, if I go to another cell and just type in a number or something or make a change, as soon as I press Enter, all of these numbers will change. So at some point here, if you say, well, I want them to freeze, in other words, let's not allow them to change anymore, a quick way to adjust this, and you may have seen this in an earlier movie, is highlight this data, and then with the right mouse button, simply drag this temporarily elsewhere and then right back on top of itself. So I'm going to slide this into column S and then slide it right back on top of the data. But I'm using the right mouse button here, dragging the data rightward, then leftward, letting go of the right mouse button. Copy here as values only. So we've taken those random numbers that were generated by the rand_between function and simply turned them into pure values. So that's a set of random numbers for these entries. Now, similarly, if you need to set up some random dates, I want some dates in here. I'm setting up some sample data. It might be quite a few too. I want them to all fall within this date range right here. And so you haven't necessarily formatted these just yet, but you could have certainly. But let's say we got a chunk of numbers here and here too. And by the way, this example, we could be doing this across multiple columns. It's not restricted to a single column. Equal rand_between. In this example, we want all of our results to fall between the range represented by January 1st, 2012, and also the other date. Now we want all these functions to be referring to U2, so we want that to be an absolute address. So we'll press the function key F4, comma, and the top entry, or the highest entry, will be the entry from cell U3. We'll press F4 to make that an absolute address, and we can simply press Control Enter here. And we've got a bunch of random dates that fall within this range. Now, once again, these are still active, meaning they will change if we make changes to the worksheet. So if they appear to fit your needs, now some people might say, well, gee, there's a bunch of Aprils there. Can we somehow change this? Well, you can press F9 to regenerate them all. That's one way. Or go to an empty cell, type space and enter, something like that. But as we do this now, we've got a different set. Sometimes you don't like the results of these random calculations. You want something a little different, so just press F9. If that looks reasonable to you, highlight the data, and once again, with the right mouse button, this time we'll drag it rightward and then right back on top of itself using the right mouse button. Copy here as values only. So we've generated a bunch of random dates that fall between these two dates, and we don't need to keep those there anymore. We could get rid of them if we wished. So we've seen how the rand function and then rand_between allow us to generate random numbers, and maybe more important and more common use might be simply to use as a vehicle for sorting data to put it in random order. If you get worksheet data from different countries, or you're simply working with data and you need to convert between different measuring systems, the function you want to be using is convert. It's actually not a math function. If you're looking in the Formulas tab in the ribbon for this, you'll find it under the heading More Functions, and then under Engineering. And there it is, called Convert. The description converts a number from one measurement system to another, and it's quite extensive. A few simple examples we'll start with here. 190 kilometers. How many miles is that? Equal convert. Here's the value in question, comma. Note the pop-up tip below, from unit and a to unit. Two different entries following this. And the pop-up list here is huge. It's over 102 different choices here. Now, oddly enough, if you look through this, you will not find kilometer, but you will find, and this would not be the fastest way to do this, but you do see in the list here, for example, meter. We could certainly type this faster, but we could tab this into place, then put a K in front of it. So second time around, you'll probably just type KM. Comma, miles, we could pick it out of the list or simply type it. You'll see it in there as well too. Notice that the pop-ups here are now limited. In other words, we don't see the complete list of 102 of them, but we do see miles. So there is a certain amount of context sensitivity about what the first unit is, the from unit, because it alerts us to the possible entries we might want. We could certainly override this and type in something different if we knew what it was, but in this case, maybe we'll just click statute mile here and press tab. and find out how many miles that 190 kilometers is. And it's 118.1. And similarly, going the opposite direction, we could do this here. What I might do here is just use the control key, drag this down to here, copy it. Obviously, it's not the correct answer yet, but just reverse the order of these. So I'll make this one be MI, and this one to the right to be KM. Get rid of the I. And we will have the number of kilometers that 95 miles represents. And similar here with Celsius, and here too. As you're typing these, you might forget, unless you use these frequently, as to what code to use. So for example, for Celsius, are you going to type CEL, or is it found in here somewhere? You won't find it easily necessarily, but there it is. It's simply the letter C we can use there. Now you can tab it in or type it, comma, and you can of course guess the other one will be F. And it is case sensitive, so you want to be careful with the upper and lower case. Some of these will work either way, some will not. So 37 degrees Celsius, perhaps a lot of you know, is 98.6 Fahrenheit body temperature. Now, if I make this a small f, will this work? It could stand for something else, and it doesn't apply it at all here. Off to the right in columns G and H, and then J and K, I've indicated just a few of these, but this is by no means extensive and not the complete list. The ones you'll find yourself using frequently, you'll probably remember, but here are a few of them to use. So this is very handy when you're working with different measuring systems and you need to make conversions by way of this convert function. When you're trying to get summary information out of large amounts of data, sometimes a single cell problem can cause formulas not to work. In this worksheet, we're interested in the sales for column B for 2012. When we click column B, we're not even using formulas, but we are getting some good information down here at the bottom of the screen. That's handy. We're interested in the total maybe, almost 8.9 million. And you have control over what's displayed here simply by right-clicking. You can check or uncheck some of these choices in this section right here. But we're also interested in sales for 2013. So we'll click column C and be disappointed in contrast because we're not seeing nearly as much information here. So why is this? As we scroll down column C here, eventually we encounter an error. Now, how many other errors are there like this in here? Different kinds of errors too, possibly. Maybe division by zero, some others, that sort of thing. We might have tens of thousands of rows. It sure would be great if we could ignore those cells and come up with some totals. And as we write a formula here, we can certainly write a formula for column B using the Home tab, for example, the Auto Sum button. We can easily come up with totals for column B. That's great. We'll try this on column C. There's Auto Sum, click column C, but it doesn't work. In the same way that it didn't work on the status bar either. But fortunately, there is a function called aggregate. Now, if you had heard about this function or heard its name, or maybe you clicked the Formulas tab and happened to discover it in the Math and Trig group here, aggregate, look at the description, returns an aggregate in a list or database. That really doesn't tell us a whole lot, does it? But it's just the function that we need right here. Equal AG, immediately we see it. We can just press tab to pop it into place. Then we see a list of 19 numbers followed by various statistical measures. Certainly for many people, the most common ones will be sum, that's number 9, 1, or average. So if we want a sum in this case, we'll simply put in a 9, then a comma, and then we get another list of 7 entries here. And recognize that the 6th one, ignore error values, is exactly what we want here. There's also one for ignoring hidden rows, not for hidden columns though. And number 7 here covers both hidden rows and error values. We only need, in this case, 6, so we could use 6 or 7. I'll just use 6 here to ignore the error values, comma, and then the range that we're looking at, in this case, column C, there it is right there, enter. And so that's the total for column C. We'd probably format it like this up here. Simple drag with the right mouse button down here, copy the format. So that really takes care of what we need here. Now, ultimately, of course, we do need to clean up column C, but it does allow us to come up with totals and ignores the empty cells. Now, let's do something a little bit different in columns I and J, and let's also pretend for the moment that we're in a totally different workbook. So I'll simply hide the columns to the left by dragging across, then right-click and hide. And now we're simply looking at this data. In J17, there's a total. For the moment, it's accurate. But what if before printing this list, we want to hide a couple of the rows? We just don't want to show the data for Larry Wood and James Abbott. Maybe they've just left, but their names are still on the list, something like that. So we'll drag across these two rows, and I'm going to right-click and hide. And as I do, keep an eye on that total, the 577,000 that we see below the list. It stays the same. And so if we were making a presentation, or if we printed this, some sharp-eyed observer might say, you know, I don't think those numbers add up to 577,000. What's going on here? Well, we do want it to add up to the appropriate amount. Oddly enough, if you drag across these, you will see a correct total in the status bar. It's 489,800. That's the number we really want to see here. And the sum function is not giving us that total. But of course, aggregate will. Once again, type equal AG, that's good enough. You can tab in remainder here. This time we want to do a sum, it's a 9, then comma. We want to ignore the hidden rows. That's option 5. 5, comma, and the data we're looking at, the data right here. And as I press enter, we're not going to be seeing 577,000 anymore. We will see the correct total, 489,800, that we had seen previously when we highlighted these cells down in the status bar. So the aggregate function has at least two great tools. One we just saw here for not counting the data in hidden rows. And previously, and perhaps more powerful, the idea we want to add up or tabulate data and ignore the errors that exist there. So the aggregate function covers both of those capabilities. A function that's been around for a while in Excel is called Roman, and it simply translates Arabic-type numerals, for example, like the ones we see in column A, also in column C. We're converting these into Roman numerals. So in cell D2, we see how this is working, equal Roman. I have accentuated this by making the entries here in Times New Roman font to suggest ancient Roman days, but that's not critical. And for the most part, this feature isn't critical, but it does come in handy at times for special kinds of titles. You want to display things this way, Super Bowls, that sort of thing. And for years, we've had this Roman function, but occasionally perhaps user community is saying, give us a function that translates these into Arabic numbers. And by the way, if you are working with Roman numerals, here's a 3999. That's the highest value that can be handled by way of this technique. If we drag this down into the next cell, we get an error. So Roman can only handle the numbers 1 through 3,999. Let's take the case of some numbers here. Now, I just typed these in somewhat randomly, and I know that if I were really putting in a number here, I'm trying to type in, for example, a 46, a 47, something like this. I think a lot of you know this would not be the correct way to do it. But let's take a look at this function called Arabic, the new function in Excel 2013, looking at this value right here. And what do we get? It comes up with a 46. Now, if you had a 46 and you asked Excel to come up with a Roman numeral equivalent of this, it would come up with the concise answer, not the one that you see in column F. So oddly enough, it takes almost any combinations of X's, L's, I's, V's, C's, D's, all the Roman numerals you may or may not be familiar with, and it makes an attempt to translate them. So even though these are not the standard way, I'll copy these down, and then just for comparison, let's see what the Roman numeral equivalent of those will be. And in all these cases here, it's somewhat more concise. Now, actually, those are different, but we come up with the same answer. If you type in a number like this, that represents 5,000. Now, we saw earlier how we have a limit of 3,999. What does the Arabic function do here? It actually gives us an answer. On the other hand, if we were trying to convert this into a Roman numeral display, here's the Roman function, and we see what's happening there. So a little bit strange in how it handles those borders, but not a heavy-duty function, and most people don't use it for anything too sophisticated, mostly for titles, but it does come in handy, and we do have a new function in Excel 2013 called Arabic that allows us to translate those Roman numerals into Arabic-type numbers. One of Excel's most powerful features is its ability to handle date and time arithmetic. When you're working with date data, it's important to know how much time has elapsed between certain dates. And sometimes it's a question of actual days elapsed, sometimes it's a question of hours, minutes, and seconds. Excel can handle nearly all of those situations beautifully. Behind the scenes, and something you should know just a little bit about, is the fact that every date from 1900 onward until the year 10,000 has a value associated with it. Here's a date here in cell D1. Do we really care what the date value behind the scenes is? Probably not most of the time. If you do click the comma button on the Home tab, you can see what that date number is, but that's not really something we need to do very often. But it does set the stage for understanding what's happening here when we're working with date and time math. And so if we're tracking, for example, the starting date and the ending date of a piece of equipment that's been around for a while, we want to know how many days it was in operation. So we'll subtract the two dates. Now, we don't really care what the values are in the background. We care that they are there, but that allows this math to work properly. Equal this cell, which has some value like 39,000, 40,000, something like that, we don't know, minus the value of this cell. How many days was this piece of equipment in operation? We press enter, 2,321 days. A different kind of scenario here. We installed a piece of equipment on May 15th, 2013. It's got a lifespan of 1,500 days. When will be its last day in operation, if this is typical? Equal our starting date plus 1,500. And there's our answer, June 23rd of 2017. Here's another date here. We simply want to know the dates 90 days before, 90 days after. Simple subtraction in the first case, equal the date in question minus 90. And so that was February 12th of 2013. 90 days later than our date, equal that date plus 90. Something else you need to know about dates is that there's an arbitrary split, and you wouldn't necessarily encounter this unless you happen to be using dates in the 20s and 30s. Let's give an example here. Maybe you're dealing with the age of retirees or Social Security recipients, something like that. Maybe it's the age of a building. So I'm going to type in an entry here of December 13th, 1930. I'm typing a 30, and that's the way it gets displayed. I typed a 30. Now, how about 1 year before that? December 13th, 1929. I'd probably type it this way, but that's 2029. So what's going on here? For the last few versions of Excel, and perhaps maybe one more, the split is at 30 and 29. And that means anytime you type a 2-digit year from 30 through 99, Excel automatically assumes that it's in the previous century, in the 20th century, like this number here. If you use a year from 0 through 29, Excel assumes you mean this century. Now, if you're working with any kind of data where there's potential source of confusion, type 4-digit years, and usually that eliminates any potential problem that you might have. Either in the next version of Excel or the one after that, Microsoft is likely to move this split line to be at 39 and 40. And for the most part, it's not a big issue, but just be alert to that concept. Now, we can also work with time arithmetic. And time is about the unit 1 refers to a day, and within that we've got decimal equivalents for different hours in the day. If we were to look at this in its pure number form, it's almost 8 o'clock. That's about a third of the day if we're trying to see the number behind the scenes. And I would emphasize we almost never really need to do this, but just for the record, that's going to be about 0.31, 0.32, maybe something of that nature. I'll click the comma button up here temporarily to display it differently, and you see it that way. So that's almost a third of a day. That would be 8 a.m. to be exactly on the money there, 0.3333. Let me undo that and emphasize the idea here that we want to track the amount of time elapsed between someone who checked in at 7:53 a.m. and checked out at 4:47 p.m. In both of these cases, we could have put in the time differently, simply by typing just the pure numbers in the so-called 24-hour style. And so for the AM entry, nothing unusual, 7:53. For the PM entry, we'll use 16:47. Now, all these entries are equally acceptable, but the key idea now is to track the time elapsed, equal the later time minus the earlier time, and we get an answer like this. Now, there will be times when you subtract the two where you actually do see an AM or a PM in there, and you want to change the format. Are we going to get the same kind of thing over here? Probably the same. If you do see an AM or a PM, and you wouldn't want that in this case, a simple right-click, go to Format Cells. You can also get here by way of Control-1. Sometimes you'll make the change to be 13:30. If it is displaying AM, PM, and it's inappropriate, you'll make that second choice. And sometimes that pops up a little bit unexpectedly. So we see how much time has elapsed here. Now, what if you say, well, this person took 45 minutes for lunch. We want to track the actual working time. How would we make a change here? I think a lot of you would find this surprising. To subtract 45 minutes, we put in minus and then in double quotes, 0:45, double quote. So now we're likely to see 8 hours and 9 minutes. That's exactly what we get here. Once again, here's what the formula looks like. So we can work with dates and times in a variety of different ways. And look at the entry below this. We've got a piece of computer or control equipment. It went down at 6 p.m. on November 17th. It went back up in operation again at 3:40 p.m. a few days later. How much time has elapsed? Well, these are not in date-time format, so let's make the entry here. And we can make these together. In other words, we can put in date and time together. So in cell G5 here, I'm typing 11/17/13, that's the date, then a space. And I would either type now 18:00, 6:00 space PM, or to make it even faster, how about 6 space P? That does work. And for this entry here, we put in the date first, just like we did previously, 11/20/13 space. We can either type 3:40 space P or possibly 15:40. Either way. Now we have two times here that we can subtract. All right, they do cross multiple days, and without knowing exactly what the answer is, it looks like it's almost 3 days, so we're expecting to see a number perhaps near 72, something like that. Equal the later time minus the earlier time. And unfortunately, we get an answer like this. Now, even if we saw a time, it might be an issue. Is that an acceptable answer? It actually is okay. In one sense, it's 2.9 days, but we probably would want to display this as a time. How many hours is that? About 70 hours or so, something like that. Pressing Control 1 or doing a right-click format cells, we'll go to the time category on the number tab and choose 13:30. And when we do this, we're likely to be disappointed. That is not the correct answer. When you are dealing with times that extend over a 24-hour period, you have to make a formatting adjustment here. This isn't one of Excel's finer moments, although it is easy to correct. This time we'll do a right-click, go right into Format Cells, and on the Number tab here, we choose Time. But who would ever guess that we choose the option here that has the 37 in it? And when you do click that and you've got the appropriate cell highlighted, there's the preview up above that shows the answer that we're about to see. 69 hours and 40 minutes. Now, in this display also, it might have seconds in there that we don't really need. So if you don't want that, jump over to Custom, take out the seconds and all the remaining character out there. So this is a bit of a runaround to get here, but at least we have this capability. And when you see the H within brackets, that means that it can handle hours over 24. Every time I see this, I think there should be a better way to do this. But nevertheless, it does work, and that's the answer that we would want. The key idea, of course, is we are able to subtract times across multiple days. And you saw in these previous examples different ways to handle date and time issues in Excel. When you're working with dates and times, it's not uncommon to want to have the current date and the current time. And there are two different ways to use these capabilities. If you simply want to type today's date, you don't have to really type anything. Use the keystroke shortcut Control semicolon. Now, at the time of this recording, it's April 17th in 2013, so that's what we get. Now, if I close this file, open it a few days later, that date's going to stay the same. It will not change unless we type something different in that cell. If we want the current time, it's Control Shift semicolon. So these two shortcuts are simply shortcuts for typing in the complete entry, and they're really handy at times. Now, sometimes you want today's date to be like a moving target, or you might want to use it as a date timestamp. To put in the current date, simply type equal today, left parenthesis, and enter. Now for the moment, those two look identical, but if we save this file and open it tomorrow, it will pick up the date off the system clock and read 4/18/2013. If we want to put in time as a dynamic entry, we type equal NOW, left parenthesis. This gives us more than time. It gives us date and time, and certainly nothing wrong with that. If you did want to display just the time here, take advantage of a keystroke shortcut, Control Shift @ will display it in AM/PM style. You could certainly explore other ways to display this too. But in this example here, with the function called now, and in the example up above, in the function called today, these two functions always get updated when you open and close these files. And as you're working with a file, this time actually will change, provided you're making data entries and changes in other cells. In a few minutes from now, we might check back and see that that number will have changed. That's not the real purpose for why we're using this, but sometimes we do need this in calculations. In column C, we've got some due dates. They're not further identified, but we need to know how much time exists between today's date and these due dates. And right now, it's April 17th for me, but I want to be able to open this file in a few days or next week and have this number always be accurate. And so I want today's date to be stored in here and used in this formula in a way that's dynamic. Equal this due date, which is right here, minus today. In this case, we do need to type both parentheses. So right now, from my vantage point of April 17th, and we do get answers like this sometimes, and it does throw us, what we need to do is quickly turn this into a value. And you can use the comma button here. That's one way to do it. You don't need the decimals really. Another way is to use general format. That's Control-Shift-tilde. Perhaps that's a faster way, maybe better way. And so this is the number of days between my today right now, April 17th, and July 22nd. When I save this file, if I open it a week from now, that's going to be 89 days. In other words, we're using today as a moving target, and we can do the same thing when necessary with times as well. And by the way, that now reads 1:14. This adjusts as we work with the worksheet. But both of these can be used, and you'll see examples in later movies how we actually use today as part of a calculation for calculating an anniversary date. You can also do those with birthdays. And so it's important sometimes to enter dates in a dynamic way using either the today function for dates only, or possibly the now function, which gives us the capability of displaying these as dates or times. And they're both handy tools in working with dynamic data. It's important when working with some kinds of data to know day of the week. You're analyzing sales or orders or shipments. Why do we get more orders on Wednesdays? Or why are we doing more shipping on Fridays? Sometimes we want to know these things. And pulling out the day of the week from a date is done with the weekday function, equal weekday. So in column B here in this worksheet called weekday, we're looking for the weekday of this first sale date, and then eventually all of the entries in column A. The answer we get here at first is not exactly the one we would have expected or hoped for. It's certainly not wrong. In fact, it tells us indirectly that that's Monday. 1 is Sunday, 2 is Monday, and so on. We'd probably like to display this, though, so that it says Monday or MON, either way. If we right-click and go into Format Cells here, we can simply, on the Number tab in Format Cells dialog box, go to the category Custom, and either put in 3Ds. Now, if I type this right here, you'll see immediately how it will be displayed. You see up above, MON. That could be fine. If you want a full day spelling, use 4Ds. There we see the Monday in the preview. So we could do that. Then double-click to copy this down the column, and we see all the different days of the week when these items were sold. Now, sometimes you want to extend this a bit further and make some controls. Possibly one approach to this would be data validation, and that's not a bad idea for column G here, but we're making sure here that the shipping dates that were sometimes put in an arbitrary way do not include Saturdays and Sundays. We don't do shipping on those days. So let's use this same function here. And since it's immediately adjacent to our data, we could simply copy this formula to the right. Using Control-C, pop over here, Control-V, that's one way to do it. We've got an answer. That's a Wednesday, double-click. Whoops, we got a Sunday, we got a Saturday, we got a Saturday. We'd like to screen those out. And what we ultimately want to see here in column G is an adjusted date wherever appropriate. So we can use an if function here to check for the weekday. So we'll start off by simply saying if the weekday of F2 equals 1. That means if it's a Sunday, what do we want to do with that day? we want to take this date and add 1 to it, comma. Now, if that's not true, then we want to check to see if the weekday of that cell F2 is equal to 7. That's Saturday. And if it is, comma, we want to subtract 1 from that day. In other words, we'll bump it back to the previous Friday. So in that case, we want to do a subtraction. Now, when that's not true, the only weekdays that we have left are the valid ones. And so in those cases, we'll use the same date that we actually see there, the one in F2. So right parenthesis to close the second if, another right parenthesis for the first one. This should get adjusted. Our adjusted shipping date in the first example will not change because it was a Wednesday. Now, what we really want to do here, though, is display the new date. So the next thing to do would be to copy this format over here. One of a number of different ways to do this is using the right mouse button, drag any edge of this cell rightward, and copy here as formats only. So that's the valid date. It's going to stay the same. The next one should jump to the 25th. And that's what happens. Next one's okay. This one here is going to go back to March 1st. Because we said on the Saturday entries, we take them back one. And so you can see how that's playing out. And I'll double click to copy it downward. The weekday function, used along with the if function, allows us to make a check and take any of those Sunday dates, turn them into Monday dates, and to turn the Saturday dates into Friday dates to make these adjustments. There we are. And so the weekday function is a powerful tool for letting us analyze day of the week type information in calculations. When you're tabulating differences between dates, sometimes you want to not include weekends. For example, we've got some projects listed in column A, their starting dates, and their ending dates in column B. A simple subtraction of these two does give us a date difference, but it's counting all days. And so as we zoom in on this and write a formula in cell C2, if we want to know the number of days between these two, it's equal the later date minus the earlier date. It's 126 days. But we don't want to count the weekends, let's say. Maybe it's a 5-day-a-week operation. We don't work weekends. What we really want to do here is to calculate the number of working days. And the function is net work days. And since that is a long entry, let's choose this. And by the way, recognize that there is an option, a related function called international, that allows us to have different weekend days in question. Maybe they're not throughout the world Saturdays and Sundays only, and they aren't. So that gives us some capability there. But we'll use net work days, and as soon as we find it, we can just tab it into place. The starting date we put in first, that's in A3, comma. The ending date here, we're not counting Saturdays and Sundays. It's only 91 working days. Now, over in column E, we've got our holidays listed throughout this time frame too. I'm simply going to copy this formula downward. For the moment, it's the same, but let's say we don't want to count those holidays. There is an option here to follow the end date, comma, to put in the holidays. Now we can either highlight the appropriate holidays, but it doesn't hurt to highlight more than are necessary, so we'll just, do that. That's fine. Covers the dates in question. So instead of 91 days, looks like we've got 3 holidays in there. So it's 88 days instead. You've got to have this list nearby in order to refer to it. We've got some similar examples down here that extend across the next year, and that's fine as long as your holidays are covered there as well too. And so in the example here, we'll copy this downward, then make an adjustment to the holiday reference instead of those cells here. Again, we could possibly highlight them all or just the relevant ones, and that'll be these right down here as we slide across them. There we go. And we do the same kind of thing here. Something I want to point out, though, is what if we're looking at data within the same week? And we'll see how this is done. So let's, for example, we could actually use this date here. I'll pull it down here using the control key, and that's a Monday. So over here, I'll put in the Friday entry. First of all, just drag it to the right, make it a little bit simpler. That's actually the Tuesday. And so the 10th is Friday. So what's the number of working days there? We can just drag this function downward. That's 5. Now, if we subtract the dates, and sometimes we do that, equal the later date minus the earlier date, it's 4. And so sometimes you want to be thinking about when you're calculating date differences. If the project started at midday on the 6th and ended at midday on the 10th, 5 really should be 4. And so you have to think out those situations a little bit sometimes. Network days does count the first date and the last date. And many times that's appropriate and not a problem. If you simply subtract them though, sometimes you'll get one less. And be thinking about that when you're using formulas that are calculating date and time differences. And if you do need to use this for international type situations where the weekends are different, there is that other capability, that other function called Network Days International. When you're trying to calculate a final date, perhaps working with projects, you need to use a function called Workday if you want to be able to account for weekends and possibly holidays. And like its companion Network Days, we also have the capability here of adjusting this to different cultures in the world where the weekends might not be Saturdays and Sundays, they could be Fridays and Saturdays, and some other combinations as well. So, simple example here of a project that begins on May 6th, 2013 at 60 days. If we just do simple math here, a starting date plus a 60-day length will give us a completion date of July 5th. But let's say we don't work weekends, so we'll use the function called Workday. And I'll first use it in its standard way. Notice that its companion is called Workday International. So Workday simply uses standard American type, English type weekends. Left parenthesis here. Here's our starting date, comma. Here's the number of days. And for the moment, we're ignoring the holidays. But we get an answer of July 29th. And if we do want to account for the holidays, I'll simply copy this function down here, then make an adjustment here to include, or better yet, to not include the holidays. So we either highlight the relevant cells or enough cells around them to get the idea across. It's going to be somewhere in those. Enter. And so the actual project ending date will be the 31st because we do have a couple of holidays within that time frame. If we use the example here, we can essentially just copy this downward. We'll get an answer here. Now, we would have to make an adjustment, possibly. No, we're all set here as well, too. Now, what if we wanted to account for different weekend settings or different days of the week kinds of settings built into Excel, but by way of a different function called Workday International, we possibly will include a different weekend set. So let's take a look at that. Equal Workday. As we start to type it, immediately we see the other choice. Workday International. Tab that into place. Here's our starting date, comma. Here's the number of days, comma. But what kind of weekend do we have? And you'll see all the 2-day consecutive combinations listed here. Some parts of the world, it's Friday and Saturday that's the weekend. And maybe based on the working environment here, and you're not necessarily thinking international, but maybe you've got one day only. So each day of the week is represented here as an option as well, too. So 17 different choices there. And this doesn't necessarily mean we'll get a different answer if we were to compare this with the simple Workday function, but sometimes, of course, we would. So if we're using this option right here, Friday, Saturday, we can either type the 7 or just tab that into place. And if we don't want to include the holidays, of course, we'll highlight what we believe to be the relevant cells. That's probably good enough. And enter, and we get an answer there. But a different set of weekends. If we use the regular Workday function here, we might or might not get the same answer. This time we've got this date, comma, the number of working days, comma, and the relevant holidays. So we might come up with the same answer or we might not. It depends upon how the comparison between a standard American type weekend, which is Saturday, Sunday, versus the international setting that I used here for Friday, Saturday. So with the Workday function and also its companion Network Days, we do have the option in these calculations to include different kinds of weekends. But both functions are valuable in the sense that we do need to count days across multiple weeks and months and not include holidays and/or weekends. Excel has a very valuable function that helps you calculate date differences. It's called DateDiff, but there's something very strange about it. If you go to the Formulas tab and take a look at the date and time functions, you will not find DateDiff. It's not there. If you press the FX button, which is another way to track down functions, if you go into the date and time category, you do not find DateDiff. Oddly enough, if you're using the Mac version of Excel, you will find this function with documentation. So it's a bit strange. You'll also notice something different. If you type this function, unlike most other functions, and here too, note you don't see it in the list, but as we type this, if it's a normal function, at this point, as soon as we put in the left parenthesis, we'll get those pop-up tips below this that give us some clue as to what to put in next. All this does for us is confirm in a slightly vague way that the function appears to be valid. So what do we put in here? We're trying to calculate the difference between these two dates. If it's simply a number of days difference, we could subtract the two cells and get there pretty fast without date diff. But let's show some of the variations that we could be using here. Date diff begins by putting in the starting date, comma, and the ending date, right here, comma. And then one of 6 different entries. They're displayed over here in column E. Whichever one of these we use, it must be within double quotes. Now, as you look at the dates there, it represents about a 3-year period. Not quite 3 years, but almost 3. If we want to display years here, double quote Y, double quote, enter. Now, it's not 3 years yet, so this calculation is just like sort of an anniversary date. We could do it that way. We actually haven't reached the date. We're only a few days away, about a week away. But sometimes we want to know that. How many months has it been here? We'll change that to an M, and it's 35 months. Almost 36, but not quite. It's 35 months. Now, the remaining 3 entries are all a little bit different, and they allow us to, in different ways, calculate the amount of time beyond a boundary. So if someone were to say, how many months has it been since the last yearly anniversary? We put in YM. How many months has it been since the last yearly anniversary? Probably going to be 11. Almost that 3rd anniversary, but it's 11 months after the last anniversary. How many days has it been since the last anniversary? That's going to be about 358 or something like that, because we're almost at that 3rd year mark. It's 357. So there we are. How many days has it been since the last year? And the last example there, how many days has it been since the last monthly anniversary? And it's 23 days. So you can see in different ways how this is likely to be used. A better use of this might be over in column H here, and we need to know the number of service years. And this also would apply for a situation where you're trying to calculate someone's age. You probably know that putting in age in a column should never be pure numbers. It should always be a formula. We want this to be accurate all the time. So we can use the date diff function in combination with the today function to make sure that this entry is always accurate. We want to count service years here. Equal date diff, left parenthesis. Here's our starting date, comma. We want to compare it with today. And as I'm typing this, it's April 17th of 2013. So today is followed by 2 parentheses, comma. And if we want to track years, double quote, Y, double quote. Right parenthesis, control enter, and it's 17 years. Double clicking here, we've got the other entries as well. If we have quite a few entries here, every time we open this file, some of these possibly will have changed because we're always using today's date to make the comparison. And let's say this is always up to date. And again, imagine if this said birth date and this said age, you would always have the accurate age here to the day with these kinds of calculations. Now, there's one bug in date diff. If you don't use MD, you're probably never going to encounter it. Here it is in the list down here. Here's a series of dates, January 29th of 2013, then the following 3 days, the 30th, 31st, and the 1st. And we're going to be comparing these dates with March 2nd. So in this example here, what are we doing? Here's our starting date of January 29th. Here's our ending date. How many days has it been since the last monthly anniversary? And the reason this happens is because of the February issue. There is no February 29th of this year, so when was that first monthly anniversary? Well, I guess you could say it's March 1st, which is the first day after the missing February 29th. So we get a 1 there. But here we get a 0, and then suddenly we get a -1. Now, I've only seen this happen with the MD option, and so I tend not to use that anyway. And I think it only happens in the February time frame here too. But all of the uses of date diff seem to work beautifully, and it's particularly handy, not only in the examples that we saw here, but perhaps better, and I use this in a number of different workbooks, to calculate service years or birth dates, simply by comparing a date with today's date and then using the Y entry. But it's a very valuable tool, but you won't find documentation within the Excel help system at all, unless you're using Excel for the Mac. When you're trying to calculate monthly differences, sometimes you run into the issue that we have different numbers of days in different months, and calculating those is not a question of adding days, but of adding months. And there are 2 potential functions you might consider using here, eDate and EO month. As we look at the data in columns B and C, each of these employees has a probationary period, and it varies, as we can see. We've got our starting dates in column B. The probationary period in the first case is 3 months later. We want to know this ending date, so we simply want to come up with an answer of September 4th. Now, do we add 90 days or 91 days, 92 days, 89 days? We simply don't have a number that stands for all the months. But the function eDate allows us to come up with the calculation here to come up with the same day in the appropriate month. So here's our starting date, comma, here's the number of months, and as we press enter, it's September 4th. And as we double click and copy this down the column, we can see what else is happening. Do recognize though, we might have a situation like we have in row 8 here. This is October 31st, 4-month probationary period. If you add 4 months, of course there is no, and there never will be, any February 31st, so it simply reverts to the closest day in those examples. We don't have any other one quite like that, but you could imagine that happening from time to time. Now, what if this is calculated differently? In other words, this company says, okay, when your probationary period starts, your probationary period will end on the last day of that 3rd month. Instead of coming up with an answer like September 4th, we'd like to see September 30th. And the function we're using here is EO month, meaning end of month. We've got our starting date, which is B2, our probationary period 3. Now we get the answer. That's the last day of the month. Double click here and we see what's happening in all the other cases. We're adding the 5 months, the 3 months, the 4 months, whatever, and then extending the probationary period until the end of the month. Now, the permanent status, let's say, after the probationary period would start the day later. So if we did have column D in place here, we'd simply write a function that takes this entry +1. We could certainly do that, do it that way, and that's just fine. But if we didn't have column D there, what we would do is simply make a change or use this same kind of a function here. Let's just start over with this. How about EO month, left parenthesis. Here's our starting date, comma, here are the months, right parenthesis. Now that would give us September 30th, but we'll simply add 1. This is for those situations where maybe we don't have the column D. So there's our entry that way, and by double clicking, we'll get the same kind of answers we got previously, but it's a different use and a different approach to how we handle this. There could be times too when we want to move backward using either of these functions. So we've got an end date right here for a project, perhaps, or probationary period. We don't know necessarily, but we've got an end date. This is how long the program was. What was the starting date? Equal eDate, left parenthesis. Here's our starting date, comma, minus here. So what are we expecting to see here? The 7th of October of 2012. And that's the answer that we get. So we can move backward with these as well. Now, in certain worksheets, dynamic type worksheets, you might always need to have certain dates displayed. The last day of the current month. Remember, it's EO month that gives us last day of the month. And the current month, I'll just use the function today. Now, as I'm typing this, it's April 17th of 2013. But how many months forward or backward do I want to go? None. So it's 0, right parenthesis, enter. So that's the last day of the current month as I work with this. Now, as I open and close this file and as I move into May, at that point, this will read May 31st without changing the function at all. It works for today's date, and since we're not moving forward into any different month, it finds the last day of the month. Now, maybe you do billing on the last day of the previous month. So sometimes you might want to move backward. Equal EO month, today's date. Again, as I'm typing this, it's April 17th of 2013. So what's the last day of the last month? -1, right parentheses. And throughout the month of April, this is the entry that will appear here. So at different times, you do need to be able to calculate these different month differences moving forward and or backward using potentially either the eDate or the EO month functions. When you're getting data from other sources, sometimes you have issues with date and time type entries. In column A in this list, this data appears to be entered as text. We don't know how it happened necessarily, but it's a problem. And if we were to try and sort, for example, this data here, I'm going to use the AZ or the ZA buttons on the data tab in the ribbon. I'll use AZ here. That certainly doesn't do anything with the data. Does a reverse sort here? Does it help? There's 2014, there's September out of 2011, then a date out of 2010, then a date out of 2011. Our data is all messed up here. So there are a couple of ways around this. If the information looks like a date, and you might have tons of entries, they're probably not mixed up like this, but they might be one or the other. One fix is to use the function called dateValue. We'll use it on this cell, see what happens. Looks like it's displaying a different variation on it. We'll double click to copy this down here. So we make the column wider just to make sure it's right aligned. That's all looking good. Looks like those are real dates, and now we have something to work with. Similarly with times, we might try sorting these or doing other things with them. Occasionally you do get correct answers if you apply math to these. If, for example, if somebody says, well, I know that's text, but I still want to see what would happen if I add 15 minutes to it, equal this plus, and you could put in within double quotes, 0:15, double quote, and you get an answer that initially doesn't look very correct. But if we were to right click and format this with format cells and use the time category of 13:30 or the 1:30 p.m. that puts in the AM PM, we see we actually do have a correct answer. So sometimes simply applying formulas will make this work. But a better approach here, and one that you don't have to experiment with too much, is likely to be to use the time value function. And I've highlighted both cells here, so as I type this, I'm referring to this cell, but I'll press Control Enter here, and we'll have answers for both of these that now make sense. But the display here, we probably want to use this kind of a display. So a quick shortcut for copying a formula is to use the right mouse button and drag this cell entry downward. And then after letting go of the right mouse button, we'll copy here as formats only. So those are a couple of different approaches to cleaning up data. And here's another one too. I'm going to move these aside. Now recognize that they do represent entries that we can work with. Now, another approach to cleaning up data like this is simply to apply math to them. I'm going to pick an empty cell here and simply press Control C. We're copying an empty cell. Then I'm going to select the data here, right click and paste special and simply add. I'm adding 0 to these. And simply by applying math, it's done something that initially looks really weird, but these are date type entries. And a quick keystroke shortcut that you might want to use to make them look like dates, Control-Shift-#. It's the only keystroke shortcut for dates. That confirms that those are accurate. Now, if you didn't know the shortcut, what you would do here is press Control-1 or right-click Format Cells, pick a date format that makes sense to you. Certainly one of the common ones is the first one there. We could use that. And that confirms too that we've cleaned up the data. Remember, all we did is we added zeros to these. That too is not always foolproof, but sometimes it does work. Now these don't look like they're accurate, at least at first, but they too represent portions of the day and they can be displayed as time. The one keystroke shortcut you might want to use, the only one that exists for time entries, Control-Shift-#, and we see those entries that way. If you didn't know the shortcut, and let me undo this, right click, go to Format Cells, and one of the time categories here, and one of the time formats here, either the 24-hour style, 13:30, or the one below it that shows AM, PM. I'll use the first one, and so we see our numbers displayed that way. Meanwhile, these numbers here that are working off the correct data in column A no longer have any purpose, and so we wouldn't use them in that context. But I think you can see when you're getting data, and as I press Control-Z here a few times, we'll be moving backward here. When confronted with data like we see in column A there, we sometimes have to take steps to clean it up. And many times it's the date value or the time value function that's going to help us clean up that data. In Excel, there's a category of formulas, sometimes referred to as array formulas. And there are also some special functions that fall under the heading of array functions. However, if you're on the Formulas tab and you're checking out some of the many functions, it's highly unlikely you'll encounter this term. Now, you may encounter a particular function and it is described as an array function, but you probably are not looking for functions based on that concept or that word or phrase. An array formula is extremely powerful, and so are the array functions, and they're difficult to describe except by way of example. And what they typically involve is the ability to handle large amounts of information across parallel sets of data, maybe a parallel set of rows, parallel set of columns. That's not exactly a definition, but let's start with a simple example here in this worksheet where in columns B and column C, we've got some items being sold. Here's the units sold, the unit price, and simple little formula here to calculate the total. And at the bottom, we're adding up all these. Now, we probably want that information, but there certainly can be times when, and it could be with a larger list, smaller list, doesn't make any difference. What if we simply wanted to take all of this data here, times all of this data, and come up with the answer without those interim totals? We might need that at different times. I'm going to write a formula here that looks as if it might work, but as we try this, and notice what I'm about to do here is a little bit unusual. I'm going to be highlighting all of these cells here. That's the units sold times the unit price. And I'll press enter and be disappointed because it doesn't work. And you wouldn't expect that to work based on the way you learn how to use formulas in Excel. Excel can't really do that sort of thing. But it can if, and this sounds like I'm making it up, if you press Control-Shift-Enter, it's as if you're sending a signal to Excel to say, let's do multiply B2 by C2, and then B3 times C3. Keep doing that all the way down the two columns, and then add them all up. So I'm going to press Control-Shift-Enter, and there's an answer. And you'll recognize that it's the same answer we got here by adding up the interim totals. The difference, of course, is a formatting difference, and with the right mouse button, I could simply drag this down here with the right mouse button and copy here as formats only. Now, something else about this. With this being the active cell, look in the formula bar. I didn't type any braces. How did they get there? They are there. If you click there to edit the cell, they disappear. Similarly, if you double click, as I'm about to do in Excel D13, you don't see the braces either. So what's going on here? It sounds like I'm making this up practically, doesn't it? I will press Control-Shift-Enter, which you could say triggers the capability of doing what we want to do here. Now, again, we're not quite defining this because it's hard to do that, but now the action is complete and it does work. The more of these you see, the more you begin to understand how they work. Let's take a look at another situation in columns F, G, and H. We've got a bunch of order dates, and maybe the product that this company provides requires a substantial amount of assembly and then packaging before shipping. And it takes a number of days. We've got formulas in column H that simply subtract the two dates to indicate how much time has elapsed between ordering and shipping. And we'd like to know what the average amount of the time is. Now, I could write a simple average function right here, make it a little bit faster. On the Home tab, I'll use the drop arrow to the right of AutoSum, choose average, and looks like it's all set there, and I'll press enter. And it's 17.67, 17 2/3. Now, what if we really don't need the interim information? We simply want to know the average elapsed time. So, like our previous example, we're going to be typing here, equal average, left parenthesis, and we want to take all of the shipping dates minus all of the order dates, similar to what we had done with columns B and C. And here too, if we simply press enter, we do not get an answer that makes any sense. In fact, it's incorrect. But as I double click, as we look at this again, everything will change if I press Control-Shift-Enter. And we do have a correct answer. And as you look in the formula bar, you see those braces again, which I did not type. Remember, all I did is press Control-Shift-Enter. So we're seeing some examples of here of how we're handling data in what you might call a parallel fashion. And that's often the case with these kinds of formulas. Here's another example over here where we've got some data and we've got some duplicates in this list. There are 2 Brian Lyons there, and perhaps some others in this list, 2 Jessica Wilsons. Now, if we've got duplicates here, not just the names, let's look to the right here. Looks like we've got, same kind of building. They're in the same building, same social security number, same phone number. Those are duplicates. Now, we might have people with the same name here, but we need to be checking this. Now, Excel does have a great tool for getting rid of these. In fact, the data doesn't even have to be sorted, as it could be here. It might not be. But we don't even have the data in any particular order. We could get rid of the duplicates by way of the Data tab and a feature that was introduced in 2007 called Remove Duplicates. And that's all well and good. But what if you want to identify which records have been sorted? Let's just click here in column K and do an AZ sort to make sure we've got any of those double names when they occur that they're together. So we see a Thomas Allen right there too. Okay, now here's what we might want to do. If we'd like to identify where these are the same, we can use the if function along with and to start comparing these. And if we start this equal if, we'll use the and function and say the following. When this cell is equal to the cell above it, and this cell is equal to the cell above it, and this cell is equal to the cell above it, one more time here, comma, and this is equal to this. For this to be foolproof, ideally we do this all the way over into column T in this example here. But we really don't want to finish this. What I will do here is say, let's imagine that we did, and had we done that, we'd have a right parenthesis in here, comma, and then we would put in, for example, if all those are the same, then this is a duplicate. Put in dupe. And if it's not, it's a unique record, that sort of thing. And that would work just fine. But imagine how large that would really be if we had to extend that all the way across into column T. Now I'm going to do it a different way. And to get started, I'll just copy this and then make a change to it. What if we were to say, and we've already identified as we scroll rightward here, that we need to do this out to column T if we truly are going to check every single cell. Let's make a change here and say, if K4 colon T4 equals K3 colon T3. And then let's get rid of all the rest of this here. And it looks like I made one tiny mistake over here of K3. There we go. If K4, there it is. If K4 colon T4, in other words, let's look at all the entries in row 4, comparing them with all of the entries in row 3. Now, if I press Control, first of all, if I press Enter, we don't get a sensible answer. But double-clicking to re-edit and then simply pressing Control-Shift-Enter, we will get an answer. And as we double-click, copy this downward, it found, for example, a duplicate right here. Now, when we press Control tilde, we can see these functions being displayed side by side as we look in rows 3 and 4 here. And I didn't even complete the entry in J3 here. So you can imagine how wide that would be if we went all the way out to column T. But the array formula here gets the job done in a much more compact way. And it does help us identify those duplicate entries that we have here. So you can begin to see, as you look at some of these examples here, how these array formulas work. The more examples you see, the more these start to fall into place. But they're tremendously powerful, and as we'll see in upcoming movies, there are other ways to use these features to get to capabilities that we can't get to with other kinds of formulas and functions. In Excel, there is no function called unique, and yet the need to count the number of unique entries within a column or within a range can be really important. In this particular worksheet here, we've got a number of different departments here. In this worksheet here, and I'll double click the bottom edge of one of these cells to show that it goes down to row 687, we've got a lot of different departments in column B. If we sort the data, it'll pull all the data together by department, but that doesn't give us a count of how many different departments we have. And so in this list, the need for counting the number of unique entries in column B is apparent. And this list might grow, it might shrink. We're going to show you two different ways to do this. One will require us converting the list into the table. We'll get to that after first showing you how to work with the data using a very unusual function that's an array formula. We will first show you how to get this unique count using an array formula that's very unusual. The formula is as follows. Now, I saw this at first about 15 years ago, didn't truly understand it, but I did realize that it worked every time I tried it. So let's show what it is. Equal sum, left parenthesis, 1 divided by, and then we're going to use the function after a left parenthesis, countif, left parenthesis. We can't use the entire column reference, so we have to put in the address. It's B2, and I'm simply highlighting a portion of this, save a little bit of typing time, down to 687, comma, and we need to use this all over again. Now, you might be familiar with the countif function, but the way it's being used here is a little bit different. So I'm simply copying this part of the address and pasting it here. Right parenthesis, notice the color coding of the parentheses, another right parenthesis, and we're done. It works. There are 24 different entries there. If we do this with a smaller list, perhaps the logic of it becomes a little more apparent. Here's a much smaller list containing different states. And if you look at that, this is a much smaller list simply containing a number of different states. Colorado, Kentucky, California, and Ohio. Those are the only ones. If we use the COUNTIF function in its basic form here, simply to tell us how often, for example, Colorado appears, we could simply refer to column K here. There's nothing else in the column, comma, and then click this cell to see how often Colorado appears in the list. 4 times. And if we copy this down the column by double-clicking, we haven't really achieved a whole lot. But if the question were to somehow come up, what does this entry represent as a portion of all of the Colorado entries? Well, it's 1/4. And so if we alter this formula that we have here and put in 1 divided by COUNTIF, complete that and recopy it, we're not seeing the actual percentages, but that of course means 25%. If we were to highlight our various Colorado entries here, we would in effect be saying each one is a quarter, therefore they add up to 1. Similarly with Kentucky. But California has 5 entries here, so each one of these is 20% of the California entries. Only 3 Ohio entries, each one of these is a third. So what happens when we highlight all of these? What are we getting? A sum of 4. And of course, that tells us there are 4 different states. So in a much larger example that we first saw, the same kind of logic is being used. And it's not exactly apparent at first, but you saw what happened over here, comparing that formula with the formula we saw over here. Here we're comparing a set of COUNTIFs as well, and then dividing by 1. But we cannot achieve this without pressing Control-Shift-Enter. Now, if our original data is in a table, it's a little bit simpler, and it has the added advantage of if the table grows, we will always have a correct answer. So let's convert this data into a table. A quick way to do this is Control-T. You can also press Control-L or go to the Insert tab or the Home tab. This is reasonably fast. Click OK. There it is. Now, since this is a table, we'll start our formula over again, pretty much the same as we did before. And to make this formula visible, I'll use a new function in Excel 2013, equal formula text. It simply allows us to display the text of a formula located elsewhere. There it is right there. So let's keep that in mind and keep it in view. And we'll start off typing equal sum, pretty much the same as the previous use of the formula. 1 divided by, left parenthesis, COUNTIF. Now, I just created a table. If I type the letter T, not only does this expose formulas, but it exposes any tables that we might have created. And there it is right there. I'll just click it and tab into place. And a characteristic of tables is that we automatically have field names. So I'll press left bracket and we see the field names in the table. The one we're interested in is department. We'll just click that right there, tab it into place, and then a right bracket, comma, and then we do this all over again. So we could either type it or copy it. I'll simply highlight this data here, press Control-C, click over here, press Control-V, some more right parentheses again, and Control-Shift-Enter. And that gives us the 24. And let me display that. I'll simply double click it for the moment. Compare that with the previous use. It's a little bit longer, although only slightly, but it does have the added advantage, since this is now a table, of being able to account for new entries. And so if we add new records, and that entails some new departments, this use of the function will automatically adjust, whereas the previous use of our array formula will not. So I think you can see the real power of this. And one of these years, I do expect to see a function in Excel called unique, which will allow us to get to this answer more easily. Excel's frequency function is an array function. It's different than other functions. You must press Control-Shift-Enter for it to work, and it gives us a frequency distribution count. In this list on the worksheet called frequency, we've got Social Security numbers in column A, salaries in column B. This goes all the way down to row 621. So we've got 620 different salaries here. Now, in arbitrary fashion, I've put in some data in column D. Every 10,000. I could have used 15,000, 20,000. But what I'd like to be able to come up with here is how many of these entries here are between 0 and 10,000, between 10 and 20,000, and so on. With the frequency function, we highlight the cells ahead of time that will contain the results. What I've also set up here is a chart to the right that we'll be reflecting the data that's about to emerge in column E. That's certainly not a requirement, but it will reinforce the fact that we're doing a frequency distribution. With these cells highlighted, I'm typing equal frequency, left parenthesis. What we first need is the category called data array. Where are these salaries? They're coming out of column B. I'll simply click column B. The next term is called bins array. This is the arbitrary set of cells right here. Now, when you're using the frequency function, it's common to have the data right next to these. They don't have to be right next to them, but it's commonly done and makes sense here too. And if I press enter, I'll get an answer, but not one that makes much sense. So what I really want to do here as I backtrack is, once again, equal frequency, left parenthesis. Here are the salaries in question, comma. Here's the bins array right here. I'll press Control, Shift, Enter. And so not only do we have data here in column E, but we also have a nice chart to reflect what's going on. And so as we look at the data here, we see the number 5 next to 10,000. If you're not sure what that means, and if it's not an issue about sorting the data, let's sort the data over to the left in column B, and of course the column A entries will go with it. We'll go to the Data tab and simply click AZ. And what are we seeing here? We've got 5 salaries here that are 10,000 or below. Notice that one of them is exactly 10,000. So that's where the 5 comes from. And so we could possibly put additional labeling on the chart to bring this out. The 5 means there are 5 records here between 0 and 10,000 inclusive. There are 31 records above 10,000 up to and including 20,000 and so on. And we see the breakout here. If the data gets adjusted, maybe some of these salaries are going to be changed. I'll simply change this to 10,001. And as I press enter, watch the 5 become a 4 over here. So we've made a change to the data. So this is reflective. Another aspect of this that's a little unusual is if you attempt to delete any of these, you can't delete any one of these, although you can delete them all. So if I press delete here, you get a message, you cannot change any part of an array. And yet, if I wanted to redesign this and put in breakpoints every 5,000, for example, I would want to get rid of these altogether, delete, and then possibly do these over again with a different set of intervals here. So frequency is an array function, and we must press Control-Shift-Enter. I'll simply press Control-Z here to bring it back into display and emphasizing the function again. You can see it in the formula bar, or as I zoom in here, you can also see it right here. There's how it appears. Remember, we don't see the braces until we press Control-Shift-Enter, and we don't see them when entering as well. But it's a powerful tool for coming up with a frequency distribution, the array function frequency. With some worksheets, it occurs to you that maybe the layout you have would be better if you could somehow change the row-column layout into column-row. In other words, in the example here, what if we had started this worksheet and then maybe decided that it might look better if we put the months in column A and then sales, expenses, profits across a row. Maybe we're going to be adding 6 more months here. So certainly one approach here, and has nothing to do with formulas, is simply to copy this data and transpose it by way of a command, right-click, under Paste Special, Transpose. And that could be just fine. Notice when you do this that formulas, for example, the formula in H4, which adds up data from the 6 cells to its left, gets transformed into a formula here that adds up 6 cells from above. And that's all well and good. But you might have an additional need. What if you wanted to have this kind of a layout somewhere else? Not necessarily on this sheet, although you could, maybe in a different worksheet, but you want it to always reflect the data. In other words, you want to have 2 separate layouts in different locations. And when you phrase the data in the original location, you want it to occur in the other one as well. So let's get rid of the transposed data here and actually approach this by way of a function called transpose. As we do this, we want to first look at how many rows and columns we have here. Notice that when you slide across rows and columns, to the left of the formula bar, you see, for example, 4RX9C, meaning what? 4 rows by 9 columns. And when you're dragging a bigger list, you'll sometimes actually see this on the worksheet too, as we get well beyond here. So now we're seeing in the lower right-hand corner of the highlighted range. Now it's 38 rows by 11 columns, just to point that out. Now let's go back to the data itself here. What we want to do is essentially remember this layout, possibly write it down. So as we're doing this here, it's 4 rows by 9 columns. Let's say we set up a shadow of this, or a duplicate of it, but going in a reverse set of rows and columns layout. So this time, and for the moment, we'll do it right on this worksheet, but we could be elsewhere completely. So we want to do what? 4 columns by 9 rows. And there's that layout. Now we're going to type equal transpose, left parenthesis. Here's our source data right here. And we'll simply press Control-Shift-Enter. This is an array function, Control-Shift-Enter. And now we've got the data displayed here, like we saw it before, but each of these is an array formula. And we'd get rid of this cell, but you cannot change part of an array. Certainly change the format of that though. Now, here's the idea. This could be, we could have copied it elsewhere by way of transpose, could have put it off to the right or in it, possibly even in a different worksheet. But if we want this to always be reflective of the other data, it will be. And so if we're adjusting this January entry and we make it 160, we press enter, and what's happening in the lower list? It's 160, and all the totals are adjusting as well. So it's a specialized use of a function. The transpose function allows us to take data from elsewhere, transpose it into a different row column layout, and have it always be dependent upon that original data. The transpose function. In this worksheet called Trend, we're tracking data from December of 2010 well into 2013, tracking sales. And as I zoom back a little bit here, notice we've got a chart to the right. And as I click on the chart, recognize that the chart is getting data from columns A and B and also columns C and D, which are currently empty. And what we want to do is to calculate a linear trend line in column C using an array function called trend. And then a function in column D called growth, which will display an exponentially calculated line. And you may or may not be familiar with those terms if you have used the trend line capability. If you are familiar with regression analysis, you probably also are familiar with these terms. So we're about to put in column C an array formula called trend. And like with the frequency function that you might have seen in a previous movie, we highlight the cells ahead of time. All these entries in column C. And let me zoom in so we can see this clearly. We type equal trend, left parenthesis, and then simply highlight the sales entries right here, all the way downward. This is an array function. I'll press Control-Shift-Enter. And not only have we made the entries here, but as I zoom back, the chart is now reflective of the data that went into column C, a linear regression line. Similarly, in column D, we'll do the same kind of thing. Highlight all these cells ahead of time, and this time equal growth, left parenthesis. And again, we'll be highlighting the sales data from column B. Down to there, Control-Shift-Enter. And so in the example we're seeing here, we're using the trend function in column C, the growth function in column D, both of them based on the data in column B, to introduce these trend lines into the worksheet with actual values. If you're familiar with the concept of using trend lines using Excel charts, you know that you can add the lines, but you don't get the values behind them. And sometimes that's necessary. And so the trend and growth functions actually produce values that are then depicted in a chart if you've chosen to use the chart. So the chart isn't really necessary here, although it does bring out the data nicely, and it reinforces the value of these two functions, trend and growth. If you've worked with various lookup functions in Excel, you know how difficult it is sometimes to match up data. We've got 2 different lists here, and they could easily be and might well be on different worksheets, possibly even different workbooks. And in the list on the left, we're trying to match up data. It's already been done. We don't need array formulas here, but let's take a look at it. We've got a situation where we've got last names and first names in separate columns, and we're trying to match them up with the data that we currently see over in column G. And so the formula in cell D2 is doing something that you might have seen. We're actually combining the data. For example, in the first case here, we're taking the last name, which is Randall, then putting in a comma and a space and combining it with the first name, Yvonne. And in effect, this data here is equal to Randall, comma, space, Yvonne. Then we're using that to look up data in column G. And once we find it, then we're going into column H to pick up the ID. And sure enough, it's working here. 891 is Yvonne Randall. We see this name over in the list here down at the bottom right there. So we put together Randall and Yvonne to match up with the entries here. Now, imagine the reverse kind of situation. We've got data in column G here. We need to get the sales numbers from another list. We see it over here in column A. Remember, it might be in a different workbook completely. We somehow need to take Margarita Roy and match up the names. But here it's going to be a bit trickier. Could we somehow use a VLOOKUP? If we start down that path, and you may or may not be familiar with VLOOKUP, but if we start down this path, we need to take Margarita Roy, whose name is put in this order, and somehow compare it with a combination of columns A and B. And there's no real way to do that directly here. How do we somehow introduce the comma into the data over in A and B when it's not there? And that's not going to work. And what we need to use here is the match function. I'm going to make the column wider so we can see this even better. We start with the match function. And with the match function, what we're trying to do here is to take this name here, Roy, Margarita, and match it up with the combination of the data from column A and double quote, comma, space, double quote, and the data in column B, comma, and the match function allows us to search for an exact match. In this case, put in the 0. And if I were to press enter here, we get no answer. We can't do that with standard Excel techniques. However, if we press Control-Shift-Enter, we at least find out that we have a match. It's in the third position of that column A and B. We see it right over here. So we're partially there. The match function often requires the index function to go further here. We want to use the index function now to simply say, we're looking at data in column C only. The index function allows us to look in a table. We're looking in a table that has only one column. We need to get the data from a certain row in that column, and the match function here that was entered as an array formula gave us that information. We need a right parenthesis here, and if we press enter, we're not going to get an answer that we really want, but if we press Control-Shift-Enter, we will get the correct answer. Now we're expecting here to see 77,945, and that's what we get. And as we double click and copy this down the column, we're going to get these other entries as well. Notice that it's taking a little bit of time, and I sometimes have used these functions. They do take some time. Let's again redisplay the formula here, and we see what's happening. So the match portion of this has to be an array formula. We don't type the braces there. We include that portion of the formula, in this example here, inside the index function, but we must press Control-Shift-Enter for this work. So this is a somewhat creative use of a combination of using two different functions, one of which is an array function, one of which isn't, but as I said, we do press Control-Shift-Enter to make these work. And this is the best way to come up with the answer within this context here. If you're trying to write a formula that refers to dynamic data that keeps getting added to or subtracted from, there could be times when you're trying to say, I want to get the last entry out of a column or a group of cells. In this worksheet here called Offset, we got some reporting date information in column A and a closing rate, perhaps a stock market rate in column B. And we want to have in cell D2 the last reporting date. The list is going to grow in column A, maybe quite large eventually, also in column B. We always want to see the last reporting date. And so looking at the data right now, in D2, we would like to see 5/15/2013, and over in E2, we want to see 256. We're going to be using a function called offset. If you haven't heard about it, and you might not have encountered the need to use it, you will find it under lookup and reference functions. And as we slide over the description here, offset returns a reference to a range that is a given number of rows and columns from a given reference. Perhaps a longer explanation might be better there, but at least it captures the essence of what it is we're trying to do. We've got a dynamic situation here. Before using offset, I want to introduce another function that you might have encountered, and it's going to be helpful as we use offset. We need to know how much information is in column A. And right now you can see that 9 cells have data. And the function called COUNTA simply counts non-blank cells. And it doesn't have anything to do with column A necessarily. It does in this case. But COUNTA means count entries. And so the answer here will be, as we look at the data there, 9. That's going to help us as we use the offset function. Equal offset. We begin with a starting location. That's what the term reference means here. Our starting location is cell A1, comma. Now, how many cells downward do we want to move? We want to go grab the data out of A9. That happens to be 8 cells downward. Now, earlier we saw how COUNTA gave us the value 9. Let's put in our COUNTA right now for column A, minus 1. So that's going to be 8. We want to move 8 cells downward, comma. Do we want to move any columns leftward or rightward? No, we don't. We put in 0. The other two arguments here are optional. We don't need them now. So we'll put in our right parentheses. And if this is working smoothly, we should get the answer 5/15/2013. And there it is. And if I put in a new date here, either by dragging or typing, it should change. And it has. Now, we want to do a similar thing in column E, but we want to do it for the column B entries. And we can just copy this rightward. Now, the format will need to be changed. At first, it will look a little bit strange. But as we look at the function here, the offset as it's been counted, now we're looking in column B. And that's just fine, although we could use column A here as well. It doesn't make any difference. But what we want to do here is just change the format. And a quick format change off the Home tab would work just fine here, the comma button. And we're expecting to see right now 256 because we haven't put in a new closing rate yet. Maybe the closing rate for May 16th here is 259. We put that in place, and that's what we see right here. Now, if you're familiar with how to use array formulas, we can use these in combination with offset to come up with an average of the last 3 days. If we highlight those 3 cells, we'll see that in the status bar at the bottom of the screen, 256.27. How can we come up with an average here using average and offset? Equal average, left parenthesis, we'll use offset. And now what we're about to do is use B1 as our starting reference point, comma, and like before, we'll use a COUNTA, this time on column B, minus 3. In other words, we don't want to go all the way to the bottom. We want to go all the bottom, but up 3 cells, comma. We don't want to move any columns rightward. That's the 0. And now we will be putting in a value for the height, and that's going to be 3 cells because we want to do an average of the last 3 cells. Right parenthesis, and since this is an array formula, in other words, it won't work unless we make it an array formula, we need to press Control-Shift-Enter. And there's our answer, 256.27. I'll highlight the last 3 cells again in the closing rates here, and you see the average at the bottom, 256.27. To do this for 5 days, a simple switch here. I'll simply take this data right here, highlight it, Control-C, and Escape. Let's just plug it in over here and make a couple of quick changes. Control-V, and we'll change both of those 3s to be a 5. Control-Shift-Enter, and there's our average for the last 5 days, 251.06. Once again, we can verify it by highlighting those 5 cells. We see at the bottom of the screen that the average is 251.06. Now, eventually what you might want to do is just have a different number here and have a formula work off whatever number is here. So I'll put in a 6 here, and what might that be? Once again, I'll simply paste what I had copied before and then make some changes. So I had this kind of an entry. This time, instead of minus 3 here, we want to actually refer to the data in H1 right there. And we want this 3 also to refer to H1. So now we'll be getting an average as I press Control-Shift-Enter, an average of the last 6, 250.33. So I can go highlight those last 6 cells to verify that. Looks like we're on the right track. Same answer there. And so we could change that to a 4 or a 2 or whatever we want. So you can imagine different ways of using this. So I've seen a number of different examples of how the offset function allows us to pull data from different locations. And even when that location is going to be changing, as we've seen in these examples, we can take advantage of this technique, possibly using array formulas as we did in columns F, G, and H, or in the earlier simple examples in column D and E, a direct use of the offset function. If you see a description of the function called indirect, it's unlikely that you'll find it very useful. It's one of those lookup and reference functions. As we slide over it here from the Formulas tab in the ribbon, indirect is described as returns the reference specified by a text string. Many examples use something like this. In a certain cell, you've got a cell address displayed, and you want to be able to get the content of that cell. Maybe this is set up in such a way that it's dynamic. If we type the function indirect and then refer to that cell, we won't get a C3, we'll get the contents of cell C3. So how useful is this likely to be? In this particular workbook, this worksheet called Indirect 1 has formulas in these cells here that gather data from 4 other sheets, East, South, Midwest, and West. They're all in the same workbook. As we take a look at one of these formulas in cell B3, we see that we're adding up data from each of the B3 cells in the East through West sheets. East, South, Midwest, and West is the notation style that we're using there to refer to all of those sheets. Now, what we also want to have here is the total found on each of those sheets. For example, on the East sheet, we've got a grand total there in cell G6, and we'd like to have that be displayed right here. And we have the same situation for South and Midwest and West. Now, imagine if this structure were set up for 50 different states. Putting in one of these formulas isn't so bad. Putting in 4 of them maybe isn't so bad. But there should be a way to write this formula in such a way that we could just copy it down the column. So let's begin with a simple idea. We're only writing one formula for the moment, and we want to get the total out of the East sheet. Type equal, click on the East sheet, then click the cell in question, G6, and press enter. And we have an answer. Now, that's gathering data from another sheet. If we drag this downward, we're not going to be getting data from the South or the Midwest sheets. We'll be getting data from other cells on the East sheet. So there ought to be a way to do this. So it would be great if there were a way to do this, and the indirect function will give us that capability. What I'm going to do first is double-click this cell and highlight this portion of it, press Control-C, escape, and paste it over here as simply text. I'll put in a leading space and then a Control-V. Keep it there for reference. We don't need the C3 here anywhere. We'd like to be able to create the same kind of structure here that we see in cell F9. So I'm going to use the function indirect. And in order to mimic that construction that we're seeing for the moment sitting over there in cell F9, I'm going to grab the data from A9. And of course, that's the word East. And we want to combine this with the remainder of that formula, which would be and that means gather other data to put next to the East, double quote, exclamation point, G6. On all the other sheets, the grand total we need is in cell G6. And as we put in the double quote, then right parenthesis and enter, we have an answer. And as we drag this downward, we have answers for the other sheets as well. Now, when you look at the formula itself, here's the one for Midwest, for example. We don't know necessarily whether that's accurate. Just a quick look will verify that. We don't see the word Midwest in here, but that is exactly what's occurring. And if we jump over to Midwest, the total, 17,930, there it is. So you can see how the function works particularly well in this situation, and imagine how powerful it would be if we had a model here based on either 12 months or 50 states. This is the way to get it done quickly with the indirect function. When you're setting up worksheets that require data entry, you can save time and provide a lot of accuracy if you give people the opportunity to choose from a pick list. And in the worksheet that we're setting up here, let's say we will be manually putting in the sales dates, the order numbers, but for states, we only have sales in certain states. And you can see there in column F, we got a table off to the right. This table ultimately that we're seeing here could be in a different worksheet, might be better there, could be even in a different workbook. What we'd like to provide here is a pick list in column C that allows us to pick just from those states. We also have sales, but only in certain cities. And we've got a complete list of our cities to the right here, as I scroll rightward, for each state. And here too, we don't want anybody typing anything. It's going to be a lot faster, and nobody will misspell anything if they pick from a list. If someone enters the state here from a pick list of California, when they click in column D, we want them to be able to see only the California cities to pick from. And so what we're actually trying to get at here is the idea of a two-tiered pick list. It's going to involve the data validation concept, which you might or might not be familiar with, but also a use of the indirect function, and in a very powerful way. And again, I would emphasize the idea that ultimately this table might be placed on another sheet, possibly in another workbook. Let's begin the process here by simply providing, by way of data validation, a way to get the state names in place automatically. Nothing else will go into column C except these states, so let's just pick column C, and on the Data tab, use this feature called Data Validation. There it is right there. Click it, and under Allow, we want to choose List. Every time I see Allow, I want it to say Require, because that's really what it means here. The source of the list. We can move this over, and then simply slide across the cells that have our state names. Right there, down to Wisconsin. Click OK. So what we've set up so far here, and not requiring any functions, is simply a pick list here that allows us to pick a state as we need it here. We can scroll up and down, they're alphabetized, that's usually the way you'd want to do it. And we'll just pick a state here, maybe California for the moment. Now, what we'd like to be able to have set up here is a similar pick list, but based on what we see in column C. So we want a pick list here that only shows the California cities. So the next thing we need to do is to create range names. And so we want every one of these state codes here to serve as a range name for the data to the right of it. So we want to highlight this and drag rightward. There we are. And just to make sure here, we'll scroll up and down. Looks like we got all of our states there. Actually went a column too far, so I'll go back again just into column Q, just to make sure. And we're going to use a technique here that allows us to pick the names out of the left column here. So we've got this data highlighted. Then we go to the Formulas tab and use the feature called Create from Selection. Automatically generate names from the selected cells. And we're not getting names out of the top row, but we are getting them out of the left column of the highlighted data. Click OK. Now, with that in place, we can set up a pick list in column D here, once again, by way of the Data tab and Data Validation. And we need a list, but the source of the list is going to be the data in column C, even though we will never really be using C1. Right now, the active cell is D1. What we're about to say, in effect, is let's use the function indirect to get data out of cell C1. What this really means is get data in the adjacent cell to the left. And so if we were actually about to put data in cell D2, we would refer to cell C2. So we click OK. Now, this throws people at first when you see this, and all it literally means is that C1 and D1 don't really fit. Do we want to continue? Yes. That may not be an obvious thing to say, but it is in this case. That's exactly what we want to do. So now we've got our pick list set up for column D. We're going to click the drop arrow here and see only California cities. There they are. So we'll pick Los Angeles, and there it is. Pick another state over here. Maybe it'll be Ohio this time. There's our list. There's Ohio. Click here. Which Ohio cities do we see? Well, here we have to kind of scroll up and down. So this is a little bit awkward maybe. And there's a fix for that as well too. In other words, why didn't we see Akron and Cincinnati on top as we went in there? So here's the other thought. And I'll zoom back a little bit here. See this a little bit better. It's pretty apparent that the states have different numbers of cities in them here. The blank cells are not serving us well at all. So let's select them. How can we select the blank cells? What we would like to do is actually delete them from our definition. On the Home tab, the extreme right button, Find and Select, gives us the opportunity to, by way of Go to Special, to select the blank cells. Click OK. We've got our blank cells highlighted. We'll simply right-click and delete the blank cells, shifting all the data leftward. Shift cells left. Click OK. Now, the difference will be, and it wasn't a huge difference, and it wasn't exactly required, but now, for example, in Ohio, when we're clicking this, we just see the cities in question. If there are 8 or fewer, we don't see a scroll bar. So we'll pick Cincinnati. And again, as we look at some of the other states, similar, say, that have fewer than 8, we'll see all of our entries. That's Nebraska. See them that way. So that cleans it up. So this two-way pick list idea is a pretty powerful tool. Think of how it eliminates a lot of typing, a lot of mistyping, a lot of mistaken state codes, possibly a misspelled city, that sort of thing. And again, eventually you probably would want to put this list elsewhere, maybe on a different sheet, and this will continue to work properly. When you set up the pick list too, as I did here, I used the entire column entries. The arrows are still here in effect on the top two cells. You could simply highlight those and get rid of data validation for those two cells. But I think you can see the value here of this two-tiered pick list, and it all pulls together by way of the indirect function in setting up these city entries. As we look at the part numbers in column A in this worksheet called Find Mid, it's possible that these numbers have a scheme to them. Maybe the first two characters refer to the location where the product was made. Maybe some of the characters refer to the color, possibly the time when it was made, something like that. There are times when we want to work with data at the character level. There are a number of functions categorized as text functions. So on the Formulas tab, we'll click the drop arrow here. And the one we're about to use here is one called Find. Here's the description of it. Returns the starting position of one text string within another text string. Find is case sensitive. Sounds a little arcane, perhaps. Let's say that what we'd like to do in this example here is to see if the letter G exists. Now, we can obviously see that in some of the cases, but imagine the list is huge. Now, maybe we're going to be changing that. Maybe we want to pull out the G, make a difference here. Let's just start with a simple idea. We're trying to find out if it exists. Equal find, left parenthesis. We're looking for what? Within double quotes, G. Now, the find function is case sensitive, so this will find a capital G if it's there. But if you look in row 6, for example, that's a lowercase g. We'll not find that one. Where are we looking for this? We're looking within cell A2. Now, there could be times in more complex situations where you don't necessarily want to start looking from the left edge. You might want to start from the third character or the fourth character. So there's a lot of flexibility in this function. In this example here, we simply want to start on the left edge, so we don't need to put in a third argument. And the answer we're going to get here, if found, will be the character position. If not, we'll get an answer like we're about to get here. Value. But by double-clicking the lower right-hand corner, we do see where the G is found, and it's found in the second position there and the second position there. Note that it isn't found here, nor anywhere else. Now, based on that information, sometimes what you would want to say is, well, once we've found it, once we know that location, we might want to pull data out of there starting at that location. And so a variation on this could be to use the mid function. Think of middle. Before we do that, though, let's point out a variation on find. If we want to be able to find a G, whether it's upper or lower case, we can use a different function called search. And I'll make the change there and then recopy it. And the difference, of course, is now we'll see something different in row 6. We found the G there. Now again, whether we put in upper or lowercase makes no difference if we use the search function, because it'll find either variation on that. So sometimes that's the more relevant function. Now, if we go back to the idea that when we do find a G, we want to pull out some data from there, we could use the mid function. I think that's maybe a little bit obscure, but as we look at column C, what if we wanted to pull out the state code? Now, the state, of course, appears in different locations here depending upon the city name. What we do know is that the city names are terminated by a comma. Just for a moment here, let me mention, for those of you who have worked with data like this, if you really want to split the data into city, state, zip, there's a great tool in the Data tab where you can use the feature called Text to Columns. We don't really need that here, although it's certainly an appropriate feature. Let's just pull out the state. Now, we're going to do this based on the fact that we can find where the comma is located. Remember, find. What are we looking for? Within double quotes, a comma. And where are we looking? We're looking in cell C2. And we'll simply complete that function. It's in the 8th position. You can see that. Now, the state name starts 2 characters later. So let's introduce the function called mid. Think of the word middle, although not necessarily literally. Mid allows us to look inside of a cell, say C2, comma, and then start at a certain position. Remember, find told us that the comma was in the 8th position, so we want to use that information plus 2. In other words, we want to start at the 10th position. And if you count the characters from the left, B-O-U-L-D-E-R, comma, space, that's 9 characters. We want to start in the 10th position, comma, and how many characters do we want to pull out here? just the state code, that's 2 characters. So we're using find along with mid, and then enter, and we get our answer here. And this should work for all the other entries as well. Double click. So it's not uncommon to use these functions together, although certainly you can use them independently of each other as well. The mid function, the find function, and you can begin to see how with certain kinds of data, for extracting portions of the data or locating portions of the data, these 2 functions work together beautifully. 2 Excel functions that have long been helpful in extracting data are called left and right, and the terms almost define themselves. Sometimes we want to pull data from the left side of a cell, sometimes from the right. And the new flash fill feature in Excel 2013, in some cases, will negate the need for these. But let's look at some of the data that we see here. For example, in column A, if you haven't seen flash fill, here's a quick example of it. I only want to get the last names out of here. So I'll type Baker and press enter. And now I'll type the H for Hanson, and look what happens. Flash fill automatically senses what I'm trying to get at here, and I'll simply press enter, and we've got all the last names. Now, we could have used the function called left in combination with a function called find. Find would tell us where the comma is, and then based on that, we could pull data out of the left-hand side. But we don't need the left function anymore because of this new capability. You can't always use it though, and for example, the data in column D, even though it says code numbers, those might be real values too. Looks like they're put in as numbers. If I type a 26 here, and I'm hoping to pull out 2 characters from the left-hand side, now I'll type 26 again for the next cell, and it's not because it's the same, but that just doesn't work. In other words, it's not picking up what I'm trying to do, and that is pick up 2 characters from the left edge. Maybe these code numbers were constructed in such a way that the 2 leftmost characters are meaningful and I need to get to them. So I'll simply use the function equal left. Looking in cell D2, comma 2. I want 2 characters from the left-hand side. Of course, it could be 3 or 4 or any other relevant number. And we'll simply copy this down the column here, and it takes care of all the entries that we've got there. We're pulling out the 2 leftmost characters by using the function called left. And similarly, we can do the same thing with right. Ideally, the data in column F should be in 3 separate columns, city, state, zip. But let's say we don't really need that, but we do need the zip code. And you can see that in all cases here, it's the 5 rightmost characters. Equal right, left parenthesis here, from cell F2, comma 5. We simply want to extract the zip code. There it is. Double click. We've got the zip codes for all the others as well. So pulling data from the left side of the cell or the right side of the cell is easily achieved with these 2 functions called left and right. A frequent problem in Excel and a major cleanup issue is the presence of unwanted spaces. As you look at the data in column A, you can surely see some leading spaces in some cases, and notice that there are multiple spaces between the last and first name, and there might even be some trailing spaces, although they're not obvious. And many times these issues come to the forefront when you sort the data. If you've got a huge list and issues like these are occurring 50 rows away, you don't always see them ahead of time. But if we sort this list quickly, I'll click the AZ button on the Data tab up above. We see what's happening. Those with leading spaces occur at the top of the list. Looks like there are a few spaces in front of the W in Kathy Watanuki there, and also in Harvey here and Eric Hendricks and so on. And the multiple spaces just don't look good. How do we clean these up? The function called trim, equal trim. Now, typically you'll set up an extra column if you don't have it already to handle this. Trim, there we go. That looks good. We'll double click. And as you look back and forth, first of all, you can't tell about the trailing spaces unless you go to each cell individually, but they've been taken care of too, as we'll see. But the key idea is that the leading spaces are no longer there. If we were to sort the list eventually now, Kathy Watanuki would be near the bottom, of course. But look what happens to multiple consecutive inner spaces, like the multiple spaces between Hendricks and Eric. They get reduced to 1. Also between Baker and Mark and Catalano and Robert, as we see over here. So this takes care of the spaces. The other issue that we sometimes run into is when we're trying to match data. You can see clearly Fitzgerald there has some leading spaces. But let's imagine we're trying to match up these names. Maybe we're on a different worksheet. We're trying to see if these names exist in column A. Equal match. left parenthesis, there's the name we're trying to match, comma, we'll click column A, comma, and in the match function, 0 means exact match. We're trying to see if there's an exact match. There we are. Not applicable. So what might we do? Looks like Jackie Fitzgerald is okay over there in column A. Don't see any leading spaces, but we do have leading spaces to the right. So we could use the trim function to say, let's look at the trim version of D2. So trim, remember, removes leading spaces, trailing spaces, and it reduces multiple consecutive inner spaces to a single space. Now we're going to take the trim version of cell D2 and see if there's a match. And there is. It's in the 10th position. Since we use the row reference, of course, that means in the 10th row. Now, let's just copy this downward for Don Nichols. See what's going on there. Looks like there's a couple of spaces between the comma and Don. There is, so let's clean that up. Get rid of that. Maybe that's all it takes. And by the way, when you're editing, if you clicked on the right edge of the cell, if there is a trailing space, you would see it. We don't in this case, so that entry looks good. We click enter, and this function still isn't working properly. So what's going on here? We've got trim in place here. There was nothing wrong with Don Nichols anyway, so what's happening here? Let's go check column A, down on Don Nichols here. Now I'm going to double click on the right edge of the cell, somewhere beyond the name, and immediately you see that the blinking cursor is a space after Don. When we don't know that, is there a way to work around this? It's not working here with the trim function, but one thing you could do, it does require an array formula. We could say, let's compare our trimmed version of Don Nichols here with the trim version of all the data in column A. And because this is now an array, we're trying to look in the entire column at once, we'll press Control-Shift-Enter. And we do find Don Nichols in row 15. So that's probably a little unusual to do that, but that's another way to help match up data. Now, getting back to the data in column A and the fact that column B does show our data in the way we would want. Eventually, why not keep this data and throw away the data in column B? So ideally what we want to do now, and there's a very quick way to do this, and you may have seen this in other movies, we will simply drag this data using the right mouse button on top of the old data. And as we drag this, because we're using the right mouse button, we will get a shortcut menu. But we don't see it until we let go of the right mouse button. And there it is. Copy here as values only. So then the data in column A will be clean. The formulas in column B, we don't need anymore. The data in column A looks just great, and we've got our data back in place. So all this happened because of the use of the trim function to get rid of those unnecessary spaces. Remember, it's the leading spaces that cause the biggest problems, not only in sorting, but also in matching. But it's also those trailing spaces that give us issues and concerns when we're matching data. So there's no question the trim function is a great help in cleaning up data. If you need to pull data together from different locations, Excel has a function called concatenate, also a capability referred to by the same name. But the new feature in Excel 2013, Flash Fill, may often negate the need for these functions. Let's talk about, first of all, this new capability. I'd like to pull together in column D the names that we're seeing in columns A, B, and C. In the style, for example, Baker, comma, space, Mark, space, S. And as I type this, and I'll simply type the last name, B-A-K-E-R, comma, space, Mark, space, S. Enter. I'm not going to type all these. Look what happens with the Flash Fill feature. I'll type H, the beginning letter for Hansen, the next name, and immediately Excel picks up on what I want to do, and I'll simply press enter, and we're all done. And if that's all we want to do, we don't need to use any other kind of function or capability here. But let me undo this and say that maybe we want a period behind that, and recognize, of course, we don't have middle initials in all cases here. So if I type a period here behind the S, and then press enter, and now type H for Hansen, Excel again picks up on what I want to do, but it's doing things that I don't want when there's no middle initial involved. You see what's happening there. So when I complete this, you can see we've got some unusual characters there that we really don't want. So a different way to do this is to pull together data from other cells by using the technique referred to as concatenation. And we'll simply start here by typing equal and then getting the data from the last name cell right there, using the ampersand symbol, which means and. So following Baker, what do we want to see here? A comma and a space. So we use double quote, comma, space, double quote. We'd like to see Baker, then comma, space. And then we want to get the first name. That's in cell A2. And after that, what do we want to see? We either want to see a middle initial or we want to see nothing. So let's introduce an if function here. And what we're about to say is if this cell here is empty, and one way to say this is equal double quote, double quote. So if cell C2 is empty here, what do we really want to put in place here? We could say, well, content of C2, which is blank, or we could put in a couple of double quotes. I think C2 reads a little more easily here, so we'll put that in place. Now, what if C2 is not blank? In other words, it has a middle initial. What we need to put in now is a space, double quote, space, double quote. And following that, we do want to gather the data from C2, the actual middle initial. And following that, we want to put in, within double quotes, a period, and then a double quote to complete that, right parenthesis, and we have our construction. Admittedly, and I don't want to insult anybody, a little geeky as we look at this, but it gets the job done. The feature is referred to as concatenation. Now, there's a function called concatenate. We could pretty much go the same way, but I'll just use the simpler version that we actually don't need anymore. I'll actually type it in, though, to show how it works. I won't use the if function in this example, but we could. Let's just pull together the three names. Concatenate. Let's go get Baker, comma. Then we want, after Baker, a comma and a space. So double quote, comma, space, double quote. We'll put that in there. In other words, we're not using the ampersand symbol. We're pulling together data by way of this concatenate function. So we want to get Baker, then a comma, space, comma. Next thing we want to get is that first name right there. That's what we want to get next. And then another space, double quote, space, double quote. And then that middle initial following the double quotes, comma. We get that from C2. There we are. Now, what we will have here, and it's not horrible, but we will have some trailing spaces here. We don't really see that until we turn these into values, but that's the concatenate function. Now, when you've got data in rows, and this is less likely than commas, if you try and pull together this way, flash fill just doesn't work. In other words, we might want to pull together the ID, for example. If I type 1608 hyphen and then put in Baker, maybe I'll just use the last name here. That's all well and good. But as I go to the right here and put in 1607, Excel's not picking up on that or sensing that I'm trying to establish a pattern here. So if I type 1607-Hansen, it's not sensing anything and is not helping me here. So in this case too, if we had this kind of a situation where we wanted to create names like this, we would certainly use either concatenate or the concatenation capability, either way. So another way to do this would be pick up the data from here, ampersand, and then we want hyphen after that, double quote, hyphen, double quote, and getting the data from here. Maybe we'll use the whole name that way. So we see that. Make the column a bit wider to see it, and then drag this across that way. Admittedly, a little bit unusual in this kind of a layout and an unusual kind of combination. Also have to adjust our column widths too. That's easily done. But we've seen how we can pull together data. There's no question that this feature will not be needed as much because of flash fill and the way we use that in columns, but there certainly will be times when you're trying to pull data together from different sources where we use either the concatenate function or perhaps a little bit better concatenation capability as we see it here and in our previous example. Sometimes you get data from other sources and it looks like what we see in column A. Now, nothing truly wrong with that, but it's all uppercase and it doesn't really have to be. And you could make a case for saying, well, that takes up more horizontal space than we really want. And so a name like Don O'Brien, as we see it in A2, a lot of us would want it to look the way we see it in B2. And it's easily handled with a function called proper. Proper will capitalize any letter that begins the entry or follows space or punctuation. We'd like to see the B in O'Brien capitalized. We'd like to see, for example, in row 8, the J in Jones to be capitalized. Also the M in Morgan, of course, and the E in Eric. Just the first letters. The function is called proper. And as we focus on cell A2, Control Enter here, and we'll simply double click, and you see what happens to all of them. Nicely cleaned up quickly. Notice what it does not do. The first D in McDonald is not capitalized. However, if you wanted that to happen. And of course, you probably would have retyped it anyway. But if you put a space after Mac, and that's typically not how we see the name, although occasionally it is, that will cause the D in McDonald to be capitalized. But how many of those would you really have? But you see what it's doing in other cases, and it does exactly what we would want it to do. Now, sometimes you have case issues of a different nature. In column H, we've got part numbers here, and maybe whoever was typing these just wasn't paying attention and thought, well, it doesn't really make any difference whether the letters are upper or lowercase, so nothing was done special there. And in a certain sense, maybe it's not truly wrong, but it generally looks better if those letters are capitalized. So as we zoom in a little bit, we can see it a bit better. In an adjacent column, we will simply use the function called upper, meaning uppercase. This will do nothing to the numbers, but it will make the letters uppercase. And that tends to look a lot better by most people's estimation. Once again, a double click. In all these examples where we're using an additional column to clean up the data, eventually what we want to do, in most cases, is simply to take these results and paste them on top of the old data. And the fast, easy way to do this is with the data selected, drag any edge, maybe the top edge, drag it on top of the old data using the right mouse button. And when you let go, the pop-up menu gives you the option, copy here as values only. And those are all cleaned up, and we don't need column I anymore. Get rid of it. And that looks much better. I think most people would agree. There is another function called lower. We wouldn't use it in this case, and it's not needed nearly as often, but it allows letters to be converted to all lowercase. So proper, lower, and upper have their roles to play in cleaning up the data, making it look the way you want to. And back in column D here, in our entries here, surely here we'd probably want to copy that into column A. Once again, selecting the data and with the right mouse button, dragging it into column A, letting go of the right mouse button, copy here as values only. And then we don't need this data anymore either. Excel has two text functions that are similar in nature. They're called replace and substitute. Both of them allow us to replace information. Replace is based on the concept of replacing information by position. Substitute is based on the concept of replacing information by content. In column A, we've got 4 entries here in cells A2 through A5. We'd like to replace the 5th character with an X. Now, we can replace multiple characters. We can replace one character with many. A few different variations here. Equal replace. Left parenthesis. Old text, we see the pop-up below this, refers to the location of the cell, that's A2, comma. The starting position here, in other words, the character position that we're looking at, is the 5th position. Now, we can replace 2 characters, 3 characters, 4 characters. We want to replace the dash there. If we wanted to replace the dash and the Q, we will put in the number 2 right now. If we simply want to replace one of those characters, and we do, it's the dash we want to replace, we'll put in 1, comma. And what do we want to replace that with? Within double quotes, our capital X. And as we press enter, we're about to see 5979XQE-36. And there it is. And similarly with the other information here, we'll just double click and we're replacing the 5th character. Now the 5th character isn't always a dash. In the second example there, it's a 0. So the 0 is gone and the X is in its place. So replace has to do with character position. Over here in column E, we've got a similar situation, equal replace. But here we want to get rid of that 8th character and replace it with USA. And it might or might not be a dash. That's not the issue. The issue is the position there. So here's our old text, comma. We want to go to the 8th position, wherever that might be in here, and we're only going to be replacing one of the characters, so comma 1. And what are we replacing it with? The 3 characters USA, and we put that within double quotes. And we're all set. We replace the 8th character, which happens to have been a dash, the one between the H and the 87. We replace that with USA, as we're doing over here too. Now, the substitute function, which is similar, replaces data on the basis of content, not location. And oddly enough, it's analogous to the command sequence on the Home tab under Find and Select called Replace. So strangely enough, the substitute function is more like the replace feature. It's more so than the replace function. A little bit of confusion there, potentially. All right, we want to remove as the suggestion says here, only the first dash. And we can replace it with something if we wanted to, or simply replace it with nothing. That's what we want to do here. Equals substitute. Here's the text we're looking at, comma, the old text, and we don't care where it is in there, within double quotes, dash, double quote, with the new text. Now, it could be something or it could be nothing. If it's nothing, double quote, double quote. Now, if we only want to get rid of the first ones in here, we put in comma 1. That's only the first one. So the second one will stay. And there it is. We see what's happening. If we'd like to remove all dashes, why not just copy this down here using the control key? Not quite there yet, but if it's all of these, we don't need to put in any argument here at the end. In other words, by leaving that empty, we're saying take all dashes there and replace them with nothing. You see what happens? Now, we could have done that with the replace command. I'll show you how. Highlight this, and so we wouldn't necessarily needed to have done this, although it certainly wasn't wrong. On the Home tab, we can go to Find and Select, choose Replace. And in this case, and I've done it recently, that's why that's still there. But there's that dash. And what do we have in the next panel below this? Nothing. So we'll do a Replace All. And as you look at the numbers over there that are highlighted, 1, 2, 3, 4, 5, 6, 7, looks like there are 9 different dashes. That's what we should get as we click Replace All. 9 replacements. So in some cases, you might not need to use the substitute function. You might want to use the replace command. Recognize here a different use of substitute. And once again, I'll copy this to the right, make it a bit faster to set this up. What we want to do here, and we haven't done it yet, is to get rid of just the second dash. In other words, we want XXX in its place. So we are replacing the dash here with, in this case, XXX. But we don't want to do it for the first occurrence. We want to do it for the second occurrence of dash in there. Complete that, you see what's happened. The second dash is gone, and as we double click, that's going to be true in all these cases here. Now notice on the third one here, we've got 3 dashes in there, and there the triple X appears between the DJ and the 59, because it's the second X. And sometimes, and once again, copy this downward, make some changes here. In this case here, let's say what we want to do is to replace the dashes there with underscore. And we want to do that for all of them, so we don't need any final argument here. We'll just get rid of the 2. And that's going to replace all the dashes there with underscore, no matter how many there might be. So with these various uses of substitute and replace, you can see how you can control the cleaning up, the alteration of data by either using replace, which allows us to remove information by location, or substitute based on content. Among the many cleanup issues needed in Excel are ways to standardize the display of entries. If you look at the data in column B, those are all numbers, but we want them to be displayed as 6-character entries with leading zeros. If you were setting up the data, here's what you might consider doing. Suppose you were going to put this data in column A. You could simply right-click and go to Format Cells, or press Ctrl-1 either way, and simply use a custom format of 6 zeros. And then as you make your entries, for example here, I'll type 757, what happens when I press Enter, and 44622, and that's going to happen all the way down the column if you were to use these kinds of numbers. And so that would take care of the issue from the start. However, we've got data here, and we want it to look like this. Now, by the way, the green triangles that you sometimes see here are not critical in this example, but you will see them unless you've turned off some of the settings. If you click the button to the left, it'll explain why it's there. The number in this cell is formatted as text or preceded by an apostrophe. That doesn't really bother us now, nor should it concern us. If you were to print the data, you won't see these either. If you'd like to not show these, if you find them annoying, then go to the File menu, choose Options, and then in this dialog box, choose Formulas, and then consider unchecking the boxes that might have caused those green triangles to appear. And so over time, you might want to revisit this particular group of error checking rules. A lot of them are not really errors. They're just warnings to you. So for example here, if we don't want to see inconsistent calculated column formulas in a table, that's usually not a big issue. We can uncheck that box. The one we just saw, numbers formatted as text or preceded by an apostrophe, that isn't necessarily wrong, but if we don't want to see the indicator, we can turn that off. So you can make changes to the display there. Now, column B is all numerical entries. So one way to clean this up, and let's say we get rid of these and use a function that's going to allow us to do this. It's called text. I'll make the column a bit wider so you can see it more clearly. Equal text. We click a cell that has a value right here, comma, then we provide a format for it. We want all the entries, not only in cell B2, but all the other ones, because we're going to be copying this, to be 6 characters. So the format we use, not exactly obvious, 6 zeros. We'll complete that. We see how that's being displayed. Double click, we see how the others are. Now the column might or might not be centered. That's not the issue, and we can certainly change that if we wish, and then readjust it that way. The function in question, text, simply pulls in the information from an adjacent cell and then formats it as a 6-character number with leading zeros. That's easily handled. Now, if you look at the data in column E, it looks like we're looking at similar numbers. However, some of these have letters in them. And if we were to take that formula, in fact, we could take all these formulas and simply, using the control key, copy them over here into column F, and that means these formulas will deal with column E. But look what happens. It doesn't handle these when we've got text in them. In other words, we're trying to convert these numbers into a different kind of display this way. So there's a different approach here, and it involves the use of another function that you might or might not have seen. It's called REPT, meaning repeat. Now, when I show you this first example, you might be saying, why would I ever use that? That doesn't seem to be appropriate here. Suppose you wanted to put text. Now, it could be any character on the keyboard, of course. Maybe it's this X out here. Suppose you'd like to repeat that a number of times in this cell. And we've got values over there in column K, so let's just use that. If we're going to be copying this down the column, let's make our K1 reference here be absolute by pressing F4. What are we going to get now? 5 X's. And if we copy this down the column here, let me see what we get. And we can use any symbol, and you can use multiple symbols too, sometimes just for a special effect. So if I put in a less than arrow followed by a greater than arrow and press enter, watch what we see in column H. Again, sort of fun and games and seemingly not exactly relevant, but ultimately it is. This allows us to repeat any character we want. So leaving column F the way it is, but now working in column G and looking at the column E data, let's first begin by introducing another function called len, equals len, meaning length. What's the length of the content of that cell? It's 3 characters. And as we copy this down, you see the others as well. Now that's vital information. Let's say that we want to have leading zeros here. And the problem, remember, is that we've got numbers and a mixture of text and numbers here. And remember, this text doesn't work except in the case of numbers. So we want to cover all bases here. Now what we need to do is calculate the difference between 6 and how many characters we have here. So for example, in this cell right here, it's got a length of 4, so we want 2 leading zeros. So we're going to take 6 minus this len. So let's start by kind of building the formula this way. If we put in 6 minus the length, this is how many leading zeros we need. I'll do this all the way down the column. This is the number of leading zeros that we need. Now, let's plug that into the REPT function. Remember, the repeat function says, I want to put in a character. What is it? A 0. Double quote, 0, double quote. How many times do we want to put it in there? We want to put it in based on how many zeros we need. And we want to pick up the actual data from E2. So what we should be seeing here is 3 leading zeros and then 757. And that's what we get. And as we double click to copy this down the column, we see what's happening there. Now, I'm not suggesting in any way that this is extremely common, what we're doing here, but on the other hand, it gives us more insight into how some of these functions that seemingly come out of nowhere do have some relevance, and we can use them in a variety of different ways. Again, as we look at this, we're using the REPT function, think of repeat, to repeat 0 here so that we always are filling in the number of leading zeros that we need. We're taking 6 minus the number of characters that are already there. And so this puts in the leading zeros, and then we put in the actual content of the cell over in column E from the data there. And you see how this is being built. So using these different functions, we've just seen how to use text and REPT and also the len function to clean up some data. Excel has a number of functions under the category of information functions. If you're on the Formulas tab in the ribbon, under More Functions, you'll see the category Information, quite a few of them. The two that we're going to look at in this movie are Cell and Info. Both of them give us information about the worksheet, the working environment, and potentially of cells themselves. Let's imagine that we might want to display the current file name and its location. Equals cell, left parenthesis, and look at the choices we have here. As you look at some of these here, they're not exactly obvious what they all do, but I'm going to use the one here for file name right here. And we can just tab it into place. And as I press enter, I might be getting a lot more than I expected. What it's telling me is the name of the current file. Now, some people might say, well, of course I know that. I know which one it is and everything. But it shows us on the right side the sheet name, then the file, then the folder that it's in, and the folder that that's in, and so on and so on, the complete hierarchy. And sometimes that information is valuable, not only for display reasons, but for actual use within a worksheet. Suppose we always want to have the file name actually displayed here. Now that's giving us a lot more than the file name, but if we're familiar with other techniques, we could possibly pull out the name of the file itself. If we just wanted the sheet name, we could pull out the information from the right-hand side based on this concept. What are we looking for? What delineates or what tells us that we've got a sheet name out there? As soon as we find the right bracket. So you could use the function called find, and we're looking for, within double quotes, a right bracket. Now, if we're only looking for that bit of information is helpful. It tells us the following. What? It's in the 72nd position. We want everything after that. So we'll use that along with the mid function. The mid function allows us to look at this data, comma. Now, we don't want to start at the 72nd position. We want to start one character later, so +1. Now, that sheet name might be of different length, and so let's just use a large enough number here. 32 would cover it. Good enough, because 31 is the maximum. Anyway, right parenthesis, and we've got the current sheet name here. And again, sometimes that's useful in certain kinds of worksheets. If we wanted to pull out or extract from here the file name, need to look for two things, the left bracket and the right bracket. So earlier we had done this. We'll do something very similar. This time we're looking for the left bracket, double quote, left bracket, double quote, comma, in this location. It's in the 52nd position. And almost the same, and actually we had done this earlier, equal find. We want to look for the right bracket because that terminates the end of the file name. Double quote, right bracket, double quote, comma, as we look here. So given that bit of information, we can now use the mid function again to say, let's go here, comma, and we use the 52. That's the starting point. That's where the left bracket is, but we need to go one character beyond that, +1, comma. And how many characters do we want to pick up here? Well, we need to subtract these two and then subtract 1. So the 72 minus the 52, that's 20, but actually we need to subtract 1 from that. So this should give us the actual file name. It's 12-information.xlsx. And there it is. So using these techniques, we can, along with the cell function, pull out information from the information like we're seeing in cell D1. Another use of the cell function is to tell us what type of data we've got in the cell. And sometimes we need this for documentation purposes. So right here, I've got some data just to the left of it. That's got text. This is blank. This is a number. This is a formula. Let's again use the cell function. This time we'll use type and just tab it into place, comma, sales. And we're going to get one of three answers. L means label. That's an L. As we drag it down here, B means blank, V means value. And that covers both raw numbers like this and formulas like this. So that is potentially useful information also. You might think of possibly using these with conditional formatting to highlight different cells in the worksheet based on whether they are blank or labels or values. Different ways of using that. The info function gives us a different set. You might want to have displayed, or you might need to know at different times which version of the software you're using, which directory is in use. Equal info, left parenthesis, and here are the choices that we see here. So the operating system version, OS version, is right there. We could tab that into place and simply press enter. and it tells us the current operating system. Similarly with directory here. Again, these are all info as we use them here. Directory, the current directory or folder, tab that into place. And finally, system, once again, info. The operating environment, tab that into place and enter. Now, it's pretty apparent that you don't need these all the time and maybe only occasionally, but it's a good bit of information. And at different times too, you will want to refresh these by pressing the F9 key. Now, these are not going to change, but sometimes when you save a file in a different location, you would expect these to change immediately. They don't always. Press F9 to update them. So, some utility type functions in the information category, cell and info. Excel has a category of functions called is functions. That's not their formal name, but on the formulas tab, if you go to more functions, under information, you'll see a number of functions beginning here that begin with IS. And some of these are really handy at times. A few years ago, I had a list of numbers and I was tabulating a total. For example, in column A here, I'm going to go to the Home tab right now and click Auto Sum off to the right there and redirect this so that it adds up the data here. And I pressed enter and I knew that something was wrong here. You look at these numbers, they're between 2,000 and 3,000 mostly. So there's about 10 of them. That should be about 20 or 30,000 or something. It's way off. And I think a lot of you can probably see what the issue is here, particularly when you see similar numbers side by side. There's a 0 in here, or are there any zeros? Well, those are O's. Those are capital O's. This one has an L or a capital I in it. We're not sure what. That's an O also. Without any real zeros nearby, actually you might see one over in cell G10, but when you see them side by side, you recognize what's going on. Now, one approach to this is to clean these up, is to ask the question, are these text? By the way, in the example that I gave here too, let me take out that sum and see what would happen if we had tried the sum at the bottom. Here we would have found our problem perhaps a bit sooner. We press auto sum here and Excel does what? It looks upward for numbers but stops when it sees a non-number. And so had we put the total down there, we would have perhaps found this problem a bit sooner or understood it a bit better maybe. Now we can check these numbers here to see if they truly are numbers by possibly using is text, is number, or is non-text. These are very similar in nature and they almost explain themselves. Let's just highlight all these cells together and we're going to type here equal is text. And we're asking the question in effect, are these text? Now by definition in Excel, if an entry has at least one non-numeric character, it's text. And the answers we're going to see here will be true or false. I'll press Control Enter. And we can readily see that these are not text, they're pure numbers because we get the answer false. These are all text. That's an O, it's 2902, 34OL or O capital I, we're not sure. 25I6, 25L6, again, you get the idea here. Now, we could just as easily have used is number, and of course we're going to get reverse answers here. Equal is number, left parenthesis, we'll click on cell A2, and then press Control Enter. And so the numbers are true. We see this here, and we see it here, those two cases, and in the last two as well. Now, is non-text almost sounds like the same thing as saying, is it a number? There's only one difference here, and this is the least likely to be used of the three, but we'll show you the difference in a second. Equal is non-text. Well, doesn't that mean numbers? Well, almost, if that's the term to use here. Is non-text. Again, refer to the cells. This time I'll press Control Enter and then recopy. And it looks like we're getting the same answers as we're getting in column C. And many of the times that's going to be the case. But what if the cell's blank? I'll just delete this cell. There's where we see a difference. Is that a number? No, it's not. Is it non-text? Yes, it's not text, is it? It's empty. Now I emptied out a cell that had a number in it. Let's take one that has text in it. This one right here, we'll delete that. And as you might expect, again, we see a difference in the two, but most of the time these two are going to be identical. Now, sometimes we want to check for blanks, and many times we might be using an if function. Let's say we're going to adjust these scores, but if the score is blank, let's say that maybe what we want to do is just put in a default 99. So we want to check if these are blank. And we can work with positive numbers or negative numbers, but we're going to say the following, equal if, we want to test to see if that cell is blank. Now, you can do this with standard techniques such as check this cell, see if it's equal to double quote, double quote. Now, that works, and you might well understand that, but it's not nearly as clear as saying is blank. Right parenthesis. Much more readable, much more understandable. Is that cell blank? If it is blank, comma, we're going to put in a default score of 99. If it's not, we'll simply put in the existing score, something like that. And a right parenthesis there, Control Enter, and we'll simply copy this down the column. And you see what's happening. Anytime there's a blank cell, we come up with a score of 99. Otherwise, we just use the existing score. And again, displaying this is blank. Even though it's sort of a reverse English as you read it, it makes perfect sense, and it's more understandable to a wider audience than G2 equals double quote, double quote. So we've seen how to use not only is blank here, but also 3 other is functions, is text, is number, is non-text, to evaluate data within a worksheet. Excel has a number of error-checking functions. However, they're strangely organized. If you go to the Formulas tab in the ribbon and choose More Functions, you will see in the Information category functions such as is error, and is logical, is non-text, quite a few here relating to error checking. But you'll also find them in the category called logical. There's an if error and a new function called if NA. We don't always need these, but in some situations, it's an ideal way to check errors and to display different information. In this worksheet here, where we're tabulating sales and expenses, and then quite a few variations on different statistics based on those, look what happens if we have a month where the sales and expenses are the same. I'm going to change this to 240. The profits are 0, and then we've got a calculation in row 9, and potentially others too, that are coming up with this error of division by 0. And that's exactly what this formula is trying to do. And that's a distinct error. And we certainly don't want this to be displayed here. We don't want to have to explain it. We might want to display nothing or display NA. And so one approach to this is to do the following. I'm going to make the column wider so we can see the function, and then double click in here and introduce the function is error. Now this is usually found within an if function. We're going to check to see if this calculation, it creates an error. So is error, left parenthesis, and a right parenthesis. If this formula is going to create an error, comma, we want to display something different. If it's simply empty, we'll put in double quote, double quote. If we want to display NA, we can put that in there. Any number of different things we might want to put in there. But this is what we want to have appear in the cell when that calculation causes an error. If it doesn't, comma, what is it we want to do? The actual calculation. So let's just highlight that and press Control C and put it out here. Control V, then a final parenthesis. So it's a bit lengthy here, but once again, it's saying, if this calculation will cause an error, display NA. If it doesn't, perform the calculation. So as we press Enter here, we should see NA. Now, I'm going to leave this here, but put a space in front of it for display purposes, and compare this approach with a newer version, first available in Excel 2007, a new function called if error. And before I do that, I'm going back into here to copy this formula again with Control C, then Escape. So, equal if error. This is going to be much shorter. What is it that we're checking to see is an error? This formula that I just copied, I'll paste it in. When that is an error, we want to display, just like we did before, double quote NA. But when it's not, we don't have to say anything. This calculation will be performed. We put in the right parenthesis, we will get the same answer we got before. Let me redisplay it with a leading space so we can see this side by side. It's pretty apparent that these two functions are quite a bit different in length, and the second one is much easier to read, so we don't have to repeat the formula in there twice. So that's quite an improvement, and it does solve our need here of displaying information instead of displaying a division by 0 error. You can also put in NA in a different way. You can put it in as a function, and a lot of times it doesn't make any difference, but Let's say we go back to this version here. If you want to display this as an actual function, you type NA, left parenthesis, right parenthesis, and it gets displayed this way. A different look for sure, and you might or might not prefer it, but it has another advantage, which we'll show in a second. And it also would work here, of course, same general idea. So right here, if we want to display that as a function, we type NA, left parenthesis, right parenthesis, and get the same kind of an answer. The reason we bring this up is that there is a function called, and we're testing it right here. Here's, first of all, is a VLOOKUP that isn't working, isn't giving us the word sale. It can't find it. So we end up with an NA. And here's a function. Here's the use of the if function along with a function called isNA. Is that an NA? It surely is. Therefore, we put in fail. Now that too has a new function. It's analogous to our isError and ifError, and it's called ifNA. So let me leave this here again with a leading space so we can see it, and possibly just copy this downward and then make some changes. And we'll, for the moment, get rid of the leading space. And the new function is ifNA. If that cell is causing an error, let's display fail. Otherwise, let's display nothing. So that's a bit shorter, not nearly as short as our other comparison. Now, there's one other bit of confusion as we use some of these functions. Suppose we're checking to see if this cell is in error. One way to do this is use that older function. I say older in the sense that it's been around in Excel longer. We want to check to see if this is an error. isError. There is another function called ISERR, and the only difference in the two is that isError checks for all error conditions. Is this an error? It surely is. So what are we going to display here? Now, anything we want, but let's say not found. Otherwise, it's okay, like we found it. isError, and that's what we get. The function ISERR doesn't have the OR portion in it, checks for all error conditions except for NA type errors. So this time we're going to get the answer okay. So as we've seen here and prior examples in this movie, there are quite a few different techniques for checking for errors using these functions. And remember, you'll find some of them, if you're doing research on them or trying to look for them, on the Formulas tab by way of the information functions, and you'll find others under logical functions. There's a new function in Excel 2013, and at first it looks like it doesn't give us a whole lot of capability. It's called isFormula. It allows us to check to see if a cell has a formula in it or not. I'm going to use it right here in column H to simply check the cells to the left. Equal isFormula. Clicking cell G2, then pressing Control-Enter since the cells were selected ahead of time. So in these two cases, these are not formulas, they're just pure numbers. This is a formula, this is a formula, you can see it in the formula bar, and all we're doing is getting that information here. So not of huge value perhaps. But what if it's a much larger worksheet and will continue to grow? We might want to know at a glance where the formulas are. If we use conditional formatting, perhaps for the entire worksheet, no matter when we add a formula or get rid of a formula, we will know which cells in this worksheet have formulas and which ones don't. So we might as well select the entire worksheet. Click in the upper left corner. Then go to the Home tab and choose Conditional Formatting. And we want to create a new rule. And amongst the rule types here, the last one, use a formula to determine which cells to format. Click there. Format values where this formula is true. Now, although we've selected the entire worksheet, the active cell is in cell A1, so we can type equal isFormula, left parenthesis, A1, right parenthesis, and then click Format and decide whether we want to use a numeric format, a font change, a border, or a fill color, or any combination of those. Most obvious difference might be a fill color, so I'll simply use yellow here. Click OK, and all the cells that have formulas are yellow. If I write a new formula out here, maybe I'll use the auto sum button and choose average and average those cells. As soon as I press enter, it turns yellow. If at a later time I don't need that, if I delete the content of this cell, it no longer will have a formula in it. It no longer is yellow. So I think you can see the value of that in certain kinds of worksheets, particularly one that maybe you use once a month or occasionally, and Every time you come back to it, you want to remind yourself where the formulas are. This would be an ideal way to achieve that objective using this new function called isFormula. I've enjoyed presenting this course, and I hope it's been beneficial to you.